All right. Hi, everyone. Welcome to my stream today. Sorry I'm running a little bit late. I actually had some technical difficulties. My main screen appears to be flickering a bunch, which is weird. Yeah. Sorry for the delay. Yeah, we're live now. Sorry. I don't know. It's been weird. Fine. I'm probably not going to be sharing too much today. We can actually check and see if it affects sharing right now. People are going to join on the stream. Their guests aren't joining for like another hour or so. I want to talk actually about a really cool article before then. Um, hey, happy Friday. Yeah, let's see if if you can see the terrible flicker too. Let me see. Let me share my screen here. So let's see. When it flickers, tell me if the screen is stable here. I mean, it looks okay right now. What am I looking at? Do expressions. This is from last time. Um, let's see. Yeah, now it's not going to flicker. Everything's going to be perfectly fine, right? Yeah, of course it is. Okay. Lovely. Okay. Yeah, that's how it always is, isn't it? You have the technical difficulties and then it all just works out, right? Yeah, I don't see any flickering either. It's not actually doing it right now, so um okay. Yeah. Yeah, okay. Cool. Well, sorry for being late then. It's fine. We're not cutting into our guest time. They will be joining us in about an hour and 20 minutes. I just wanted to start early so that I didn't skip on stuff. The last couple streams have been so jam-packed with Ricky staying on like the whole time almost, and just so much conference stuff, watching the Remix conference. Like those guys also went, full time on their talk. And I didn't actually get to talk about a lot of the other topics that have been going on. I've been doing This Week in JavaScript, but I'm always doing R&D, always working on stuff. And okay, yeah, okay, sweet. So you guys don't see the flickering, only I see the flickering because it's my screen now is flickering like crazy, but I don't think it's coming through the stream, right? Yeah, yeah, you guys aren't seeing it. So this is actually maybe a hardware problem on my side. It's like it's not the out from the video from the screen, it's the actual like physical wires. Yeah, so okay, that's fine. I'll deal with the flickering. You guys can just enjoy the stream. Okay, sweet. um okay, cool. Let me open Twitch too, see if make sure give some love over to the Twitch folk as well. Sweet. Okay. Yeah. And yeah, change the Twitch topic. God, I'm so annoyed every time. It's just like talk show. It's like no software and game development. Thank you. Done. Okay. Did I actually update it though? It's like I changed the category, but it doesn't. Okay, there it is. Okay, it takes a minute to apply. Okay, whatever. Sweet. Okay, so let's get into some stuff then. Yeah, I mean, I've had some more time to think about what I saw in Remix Comp, think about the general direction of stuff, but let's see if we can get into some other stuff. Just managed to start solid app on my LG TV. Nice. How have I been? I've been pretty good. I've been really pushing through async stuff. The last couple months, as you know, have been just like pulling my hair out, kind of getting a lot of the async stuff working. But I think the model is actually really compelling now. Like there's a few pieces we'll go over today, hopefully, that'll kind of really tie it all together. So yeah. Okay. Well, I actually just want to get started right now. Just dive right in with talk about this article. Uh, it's on topic, off topic, but it's a great place to start. This is the kind of article that honestly Theo is probably going to cover, and he'll probably cover it better than I do in a certain way that's more understandable for people who probably draw some Excalidraws. We've drawn these Excalidraws, and he's drawn these Excalidraws like a dozen times. So I don't know how many if I want to draw it again. Again, he's making content for anyone to consume, so he probably will. But I want to talk about this article because first of all, I adore the approach. This is a very numbers benchmark type approach. And let me share the article in the chat. Right. Yeah. Did it actually go through? Yeah, there it is. There we go. Nice. Yeah, I know. Although streaming earlier, I think it's actually been able to help a lot there. I used to, when I started the stream, I used to stream at 8 p.m. Pacific time. It was like I put the kids down to sleep, then I come and do my stream. And it was an interesting timing because basically Europe off the map, not happening. But even East Coast US was like midnight, like so no one was watching it. It was like a very Pacific time thing. And I guess probably would have been pretty nice for people in like Asia, but now that I stream, hopefully closer in the mornings. I mean, it started when I did midday when I joined Netlify. Like it used to be that I, actually worked like on my Fridays at work, like at eBay, so I wasn't going to stream during it. But once I, part of promotion stuff when I was doing Netlify and now with Sentry, more normal kind of time for at least the US audience, which actually still works for Europe. It's late evening in Europe, but at least you can see it. So the only people who unfortunately miss out on the live timing is people, like in the Philippines or Japan or China. So you can't win it all, so to speak. It's 1 p.m. in Brazil. Sounds good. Yeah. It's not even 1 a.m. here in your live. Yeah. All right. So let's talk about this. React server components, do they really improve performance? And I love the question here because this is an empirical question, right? It's not like theoretically should they improve performance, but do they actually do? And they went through the whole gambit, and I love this, right? Heard of server components, probably have. Yeah, I don't really care, APIs and next. Okay, honestly, I want to kind of get right into the experiments, so to speak. So they made a project measure, implemented interactive Beetle website. One of the pages is like this. So this looks like Gmail. It looks like an email client, right? There's a sidebar. This is pretty typical. And the messages. Yeah, so we have two panels, two separate, so this is your nav, and then this is that. I honestly don't think the difference here is going to be that noticeable between these two. Like obviously one endpoint might be slower, one might be slower thing, but your problems are rarely, like if you can parallelize the fetching, your problems are rarely, like there's always that endpoint that's slower than the other one, and you're just like, man, why is this so slow? But generally speaking, it's the waterfalls that kill you, not like the straight up endpoints. Okay, I got it. Defining what we're measuring. When it comes to performance, there are a million things and one things you can measure. Website is good or bad, blah, blah, blah. For this particular experiment, I want to use different in-loading performance difference between data fetching approaches. Performance tab, the Crow Dev tools measurement, CPU 6 times slowdown, network slow 4G. That's fair. I used to use 3G for these, but yeah, I think this is fine. Sounds reasonable. Yeah, so then they're going to measure LCP, largest contentful paint, sidebar, message visible time, page interactive. That's when you can actually, toggle something and have it do something. It is interesting because interactivity time these days might be kind of like interestingly inverse because of event playback. It's possible to interact with the page ahead of time, and then like especially if you're using like actual built-in elements that don't require JavaScript to function, you can like start typing into an input or clicking a checkbox or doing something like that. And even though the framework in JavaScript won't be there, it something on the page will collect the event and then like replay the trigger event when the JavaScript on the page loads. And then that way, like the JavaScript on the page very quickly catches up to where the event is. So like under that metric, are you interactive at the point that the downstream thing work happens? Or are you interactive at the point that you can interact with the page? I'm not sure. it probably won't matter too much for this, but it's just something to kind of call out, like both the selective hydration in React, the event replay back in Solid, and in I believe resumability with Quick works the same way. We all basically load a script that collects certain common input events before the framework loads. Just kind of interesting. Yeah, I think Angular actually added this pretty recently, kind of inspired by Wiz, which also does it. Any resumable framework does it, and any framework that has interest in kind of, it's like one of the best, easiest wins you can get in terms of hydration timing. And it's fun kind of thing to do because you can't just go, okay, now JavaScript loaded, run all the events. You actually have to replay them in order, and you should replay them like sometimes parts of the page hydrate at different times, especially when you're streaming content in. So like if someone interacts with something lower in the page, below the like maybe like below like some kind of boundary where you haven't hydrated yet, and then they interact with something above and it starts hydrating at the top and hits the above thing, you shouldn't run the event on the above thing until you've ran the thing on the below thing. You actually should run the events in the order that they were received, even if the hydration doesn't match. So like there's some fun around those implementations. Yeah, we do that in Solid, and a number of frameworks do that these days, right? Right. I'm just quick summary here. We haven't even got into anything big. I'm just started this article. I shared the link in chat a little bit up, but essentially I'm talking about this article. We'll talk about the main Micro-Frontend stuff when the guests join us in about an hour or in 10 minutes. Okay. So, okay. This seems reasonable. They're using Chrome timelines. I actually love, I'm interested to see some of the results as we go through this. Like I did briefly look over it, but I used like not all metrics should be treated equal. And I think it's important to just lay them all out because one of the big things is Lighthouse scores, like just pure Lighthouse scores, used to be like almost even weighting in the metrics, which means I could take client-side rendered stuff and outscore server rendered stuff just because the difference in certain metrics was so much better. And then when you averaged it out, it like was like it was like, okay, well, this one wins. So I'm going to admit, when I first got into the world of server-side rendering, I was like, who needs it? I was like, every single real-world demo, I was like, with my Solid demos, I was beating every other framework. And then when they were, in my hubris, I was thinking, oh, it's just because I made the client so fast. You know, the reality was that a lot of their implementations on the server were just slow. So it was like the opposite thing. In fact, if they'd done their stuff more client side, it would have been closer in performance to what I had been doing. But I was just looking at these real world demos and being like just slaying them. And it was the wrong conclusion because of the way I looked at the metrics. So I think it's important to kind of look at this balanced. Okay, right. HTTP to HTTP2, Chrome limit 6H. Yeah, okay. This is an important point. Here, I don't know if it's funny, I'm not reading the article completely, but you can see this picture where it's showing that in HTTP1, Chrome won't let you do 6 requests at a time. And then it kind of like, so you got cascading with HTTP2, it's all at the same time. This is really actually super important, just on a different side. There's two different ways you can approach parallelization when your page is loading. You can kind of keep an open connection and stream it, or you can do a bunch of parallel requests. And I've actually often been on the big side of parallel requests because parallel requests are a lot simpler to reconstitute. You don't have to make like a special, what do you call it, transport format or something in order to like kind of merge in the stuff into the stream. And this is actually fairly relevant. In a lot of like loading metrics. Like I think when we were first talking about something like server functions with the React guys, they're like, oh, I'd like to see if you batch them all in a single call. And I was like, why would you do that? Like the difference between a stream that starts sending stuff back on the same different time period and a parallel thing, it's basically the same on the network time. The only difference is now you have to like have a special format and figure out how to unwind the different pieces where if these are all independent, they all just pop they'll just pop in as they finish anyways. So just an aside here. This case we're talking about looks like JavaScript bundles, which is, again, this is huge, right? Because this is like the people who are like, you don't need the bundle. This is their argument. They're like, look, we used to bundle so that we could do it all in one chunk. Now it might actually be, faster to do, not bundle and have smaller pieces. It's fair, right? Because if Chrome's the, do you have one longer piece process versus these ones finish faster? This gives more control to the browser, arguably. But again, the key to bundling isn't that it's one bundle. It's like dead code elimination. It's tree shaking abilities where you can actually make the total output smaller. So, sorry, this is an aside. Let's keep on going. Yeah, and I think this is going to be actually very relevant in this comparison. You can have the perfect setup and the perfect set of measurements and go through all this stuff, but then because of one of your base assumptions, you have to, like, the whole thing might actually have an issue. Like, this article is about React. If this article includes things that were not React, you might actually come to a different conclusion. But let's keep on going. The fall season is good at tree shaking. Yeah, definitely. Okay, so measuring client-side rendering. What do we hear? Script and link elements in the head. And then, yeah, basically rendering an empty root, okay? Div, beautiful, empty div in a beautiful page. You have some code in your entry point, and then you basically render to the DOM, okay? Looks pretty typical, right? Strip up the blank page. And then they got the timeline, HTML, JavaScript, still empty screen, processing that JavaScript. That's the point at which it paints. Or actually, that's the point at which it starts fetching the API call. See, I don't even have to do the Excel draw. It's right in front of me here, right? And then it finishes painting, right? In real life, it's much messier, of course, right? Blah, 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 data fetching message triggered inside JavaScript, right? So basically, you have this, like, this is your first waterfall. Go to the server, actually, you can see all the waterfalls. Go to the server, get the HTML. HTML come back and says, okay, go to the server, get the JavaScript, come back. And then JavaScript runs and then goes, go to the server, get the data, come back. So we're already going 1, 2, 3, right? And then finally we finish, right? This is, you can't avoid the first one, and you can't really avoid the second one, but, can we avoid the third one? Is an interesting question. And can we, get further ahead in our timeline even before the second one? Okay, so let's see here. Data fetching sidebar again. It could be data fetching framework like TanStack, sure, why not? But it doesn't really matter. What's important here is that the data fetching trigger JavaScript needs to download, compile, execute it. Exactly. So our first numbers, 4.1 seconds, 4.7, 5.1. Now, what's interesting here is, first of all, I love that they're highlighting no caching. For benchmarking, you shouldn't really be caching. It is interesting to see the caching in terms of what the overall end user experience is. I think it's an important metric. And the fact that this article includes both is just perfect. Like this is very well done. Just gonna put out there. But one interesting thing is, I'm glad this is the case, is that their data fetching are, oh no, I guess this is the gap of the data fetching. I wonder why LCP is so high here. I guess because of the time it takes for the JavaScript to load to render the page. One thing that was interesting is when I was doing my old client-side rendering apps, my LCP, I guess because maybe the content, I was actually getting really good. Maybe it's time to first byte. Maybe old metrics basically, yeah, maybe it wasn't LCP. Maybe old metrics are really over-indexed on time to first byte. So like I was getting like insanely fast time to first byte because it wasn't doing anything on the server, and then it would skew the rest of the metrics, right? But yeah, so this is our baseline. This seems like obviously everything's slowed down, but 5 seconds is freaking slow, right? But again, this gives you a baseline. Okay, let's keep on going. Just page error and everything is a client, no back and forth, incredibly fast in this case. Yeah, they're just saying it's just navigating from the inbox to settings takes just 80 milliseconds. Yeah, exactly. Yeah, so client-side routing is great, but we're talking about initial load here, right? What do we do? Client-side rendering. So they added a couple more things here. They showed when it was cached, the LCP is 800 milliseconds. The sidebar JS cache is 1.5 in 2 seconds. So being cached makes a huge difference here, right? This even on a slow network with slow down CPU, like keep in mind this is not like users might get like better experience than this. This is like considerably better. And then the final thing is when toggle becomes interactive, which, as you know, is the second that it renders. So it's basically the same as the message's cache score, right? Although, how are they measuring it here, actually? They're saying it's actually when the LCP shows. So the toggle is not part of the messages or the sidebar. Okay. I'll take it. Okay, so yeah, the toggle isn't part of the messages sidebar. So basically, when you have a client-side app, the LCP equals the interactive point. Makes sense. Let's keep going. I feel very few companies benefit from caching anyway. Most companies don't have web apps their users come to very often. I mean, it's an interesting question, right? Because if their app is mostly non-dynamic, then they might not, like they might even, I'd go the opposite way. Like I would like actually pre-render stuff. I'd have like a very aggressive cache because there's just no reason to if things don't update often. If people are like on a social media site, like it's the opposite, like where it's very interactive, not interactive, very dynamic, constantly changing content. Then in certain ways the caches become important for performance because people spend a lot of time on there, but they become less important in general. I'm not sure if I can make the conclusion there because like you'll be reinvalidating the cache all the time. So it's like on one side you want more caching because you want because people are like really jamming at it, but on the other hand, if like people don't come there often, then I guess the question is like if your content changes reasonably often and then people don't go there very often, you basically have to throw away the cache all the time, right? I guess, yeah, I guess we're talking about caching from a JS standpoint, not from a data standpoint. So you can't really, it is funny though, on the spectrum where people go and spend their time a lot, the caching gets a lot more beneficial, and that's usually on apps that are highly interactive or highly dynamic. But yeah, I mean, if I don't go to Reddit every week, I'm sure that the cache there is not particularly useful, even though it is a fairly dynamic site. Yeah, browser cache, yeah, like yeah, like not the data caching, but like actual like the JavaScript or the images. Yeah, I got you. Yeah. Yeah, and to be fair, I was also talking about, yeah, I guess I was talking about server cache, wasn't I? Yeah, that's fair. Yeah, browser cache. Okay, so they have a demo. We're not going to look at it at the moment. I think somebody wants to go deeper dive. Okay, fetching server-side rendering, no data fetching. So what they're going to do here is they're going to do a render to string. Not terribly too important in the details, but what's cool about render to string is that, oh, interesting. I wonder what, I guess because you don't know what page you're going to be on with the client-side rendering, you can't like get the static assets ahead of time, like the CSS or the images. So yeah, this is like, you see how the CSS and images kind of like got pulled down here? But it's still 1, 2, process 3. It's the same dance, except you get to see something earlier, right? But the LCP will be quite a bit nicer here. Right? Yeah, look at the LCP. 1.6, 4.7, 1.5. Yeah, and then the rest of the numbers are basically the same. There is, I like that they show this, that this is slightly faster. I think, let's think about this. Why is this slightly faster? Sometimes simply server rendering, actually, I'm trying to think, why? Yeah. There is an interactivity gap, which is just, I think they're taking this 4 seconds and subtracting the 1.61 from it. So like, they're just showing this is the amount of time on the page that that you can't interact with it, which is fair because there's that gap. I'm trying to decide why this is different though, because if you look at the timeline, you get the JavaScript just as soon, and process and fetch, everything should be just as quick. I would expect these to basically be the same. Maybe they are, maybe this is just like a variance. I'm not going to stress on this too much. The key point is that like now you see it, but everything else is basically the same, right? You see it right away, but now it takes 2 seconds. Cached, it's fast. You almost immediately can interact with it, but initial load is taking the hit. The funny thing is this architecture is what most people were doing with Next.js page router, which was crazy to me to a certain degree because I was like, but I understand how we got here, and I think this, if this comparison continues on where I think it goes next, we'll see why it got here. But like a lot of people end up using this architecture because it gets you good LCP, and LCP has this like, well, it's good because it makes the page feel like it loads faster, but it also has this is a huge averaging improvement over the page load times. Technically, if you fetch data on the server, you should actually lower the total time, but your LCP will go up if you don't have streaming, which means that perceivably your page is slower. So let's continue. I'm pretty sure that's where they're going to go next. Because if you don't have streaming, and this is the world I walked into when I was doing those client-side demos. I was making like really fast client-side demos, and these people were basically making apps that did data serving, data fetching on the server, and did not have streaming. So yeah, what are they doing here? Serve static API. And so they grab their agent page, they fetch their data on the server, and then they kind of jam it all into a string. Okay, so this is like this is nothing fancy. This is called like the fetch ahead approach, where when you hit the request, you basically do all your data fetching up front and then you render. There's no streaming, there's no render as you go kind of strategies. This is just the basic case. So do all the data fetching, then send back the page. So oh, right, and then they're serializing their data on the server. So they're making their JSON, right? You need this data for hydration. This is why a lot of people didn't implement streaming during this time period, because like you have to make sure that the data is there to hydrate as well. So you like, it's way easier just to go fetch all the data, jam it all into the page, then like account for different parts of the page coming in and different JSON coming in as it's available. So yeah, this is just like, yeah, jam all the data onto the page. And then if it's either take the data from when you're server rendering from what you passed in, or otherwise when you're hydrating, take it from something that you wrote onto the window object. I love how just manual, and like, I love when people just like bare bones it. Like this is what all the frameworks are doing, but they did it themselves. So yeah. Oh, I mean, you can see it, the data fetching's gone. So HTML, so this looks really good, but I'm sure there's going to be a catch here. Let's look. Yeah, see? LCP goes down from our server-side data fetching client side. And then basically these are all the same number, because basically until the data fetches and it sends it back, they all have to wait. And then the total page gets pushed back. See, this is what I'm expecting. I thought these were going to be the same, but see how the total page gets pushed back? It's because it can't fetch the JavaScript until you fetch the data on the server. Now the data on the server is blocking this part. So you actually push back fetching the JavaScript, which means you push back hydration. So when you can interact with the page. So you've actually made like the hydration gap bigger. So even though, so like you can understand why people have this weird like perception around this, because you're like, the page took longer to load and it took longer to hydrate. This is like Next.js, like when a lot of solutions entered this scene. I remember when I was working on it and people were like, you know, what do you think about server rendering? And everyone's like patting themselves on the back. And I'm like, we're like a 2 out of 10 right now. Like we are nowhere where we need to be for server rendering. And this, as I said, this is the time period where I was just making killing, right? You can see it. Like, technically speaking, this is better than this. People should recognize that, but because they couldn't interact with the page until here, 4.6 seconds, and they saw it slower, like the impression is considerably different here, right? Because this, even though this takes longer, you see the shell of the page and you see the stuff loading in with your loading spinners, and you can, and when, you know, yes, there's a delay time here, but like as soon as you get to, you know, maybe the 4-second mark, you can interact with it. Like there's this perception because you can see stuff and you can see the affordances that stuff, you know, might be loading faster. Where here, this actually loaded faster, but the whole total time was longer, and the initial delay was almost another half a second longer to actually, like when you click the button. I think actually in practice, this would feel faster for a lot of things, but the person who's sitting there paying attention, like doing the clicking, like I'm benchmarking it, is going to look at this and be like, this is slower. Like the person who's actually like doing it. So this is probably why Git server side props is called cursed by some people, is because like you think that this would just be strictly better, but it isn't. And people were already trained to see the white page at the time of loading. Yeah. Like they almost phase it out of their thinking. They just know that they're there, right? Where you're like, why am I freaking waiting so long for this page to show up? Yeah, no, definitely. Well, it depends where are you fetching the data is the question. If I'm just like, also time period we're talking about here is before React even released Suspense. This is the kind of solutions we're talking about here are like, this is state of the art. I mean, let me think. What was the first? Well, I guess Solid was the first client routed framework to support streaming. Marco, I got it from Marco, which was like the first kind of server streaming app or framework. But yeah, like 2020, and then so was Remix actually the next client routed framework to get streaming? Like you know, like SPA style? I think so. Like 2023-ish. Is it like 3 years for there? Like probably actually. Yeah. So like, yeah, this was kind of like state of the art before RSCs and before Remix for most people. Like I imagine most people weren't using Solid in 2020 and doing better than this. Yeah. Because yeah, I mean, I remember this. Svelte didn't have it because their await only worked on the client, and Marco's await only worked on the server. And I always thought that was really funny. Like, Svelte Kit, I think around 2022-ish, added like a mechanism, but the wait tag still didn't quite work properly. So yeah, I don't know who was first actually. It was very, I guess it was close between Svelte and Remix, but I want to say Remix was before them. But just putting that on the timeline. Okay, yeah. Oh, yeah, old Next.js, pages router. Okay. Let's just jump straight to the results. I think we know how this is going to look like. Oh, okay. So they did both of them. Client rendering. So you just add the next tax onto it. Interesting though. Yeah, this is interesting. Slightly. I would expected next with client data fetching to have the same characteristics. Um, but they're actually getting better numbers here, which is interesting. Did they say anything about that? Yeah, I guess, you know what? Get server side props might be smarter than what they're doing. Like maybe Next doesn't block. No, but it'd have to. Yeah, the LCP got worse. Okay, so basically Next is just an optimized version of what they did by hand. If I'm reading this, they had like if you look at it, like they got slightly better numbers here, but it's the same kind of trend of pattern, right? They went from 1.61 to 1.6 on LCP, but then the total timelines on these actually reduced, which actually made the gap on hydration slower, but that's only because stuff showed up later. But the overall time actually went down. So I guess this is just slightly more optimal delivery. And then when they move the data fetching, again, this this being the blocker right up front doesn't change on whoever you are. It's basically the same, except they're again, and they same characteristic, move the total time back, right? So yeah, I just take this to be that the Next is doing something slightly more optimal, but it's the same shape, right? Okay, let's continue. See, now they're jumping straight to server components, and I think this is kind of like the React ecosystem side of things, because the other option from here is add streaming to this result, essentially. Because if you add streaming to this result, in theory, um, the the first the this number should become that number essentially, and then these numbers should become these numbers, and then this number should become this number. In theory, right? Like it should basically just take the lowest of both and like basically go like what's the min between each one. That's essentially what streaming should do. And then this one's whatever the new calculation of the difference is. But because React didn't offer streaming and suspense until server components, these things are getting conflagrated. Okay, let's continue. Okay, right. Data fetch, by message. Okay, there's not showing streaming here though, because it's waiting on the longest data fetch. Yeah, okay, yeah. Here we go. Right. Yeah, good visualization here. Again, this is not unique to server components, but okay, React server components, how to render it, blah, blah, blah. As I said, Remix added deferred, obviously, and most frameworks have streaming now. And then they're showing, see the JSON becomes a push structure, right? Your serializer becomes like a incremental kind of thing. Here they're pushing divs, but we have something called Cerevel, which pushes JSON data. So very similar kind of thing on serialization, async components. Await blocking causing fetch waterfalls, it's kind of annoying, but that doesn't really matter. Yeah, so they jump straight to streaming because streaming basically is what makes this make sense, right? Okay, so what do we got here? Next, app router lift and shift. So first thing, this first number gets way lower, which is interesting because if this number is lower than this number, it suggests that these guys are doing something inefficient here, right? Because this is just rendering the page. So this suggests that Next actually made improvements. Like there's no reason why this number should be bigger than this number if all you're doing is doing a synchronous render, right? Like it's not blocked by async. Like this is fetching on the client. This is fetching on the server, but isn't blocked by it. So like technically speaking, these numbers should be different. So what we're actually seeing is performance improvement in Next app router over time, which is or in Next, which is great. Then these numbers are higher than I expected. Yeah. So what maybe I'm not understanding what they did here. Yeah. Okay, so they just made everything client components. Fair enough. The bundle sizes and stuff stayed larger. This hit is odd. This feels if this is what someone just took their SPA and transferred it over, they'd be like, okay, sweet, you gave me faster LCP, but these total numbers are not great, especially coming from something here that was already optimized compared even to the naive, like I'm just doing dumb stuff approach. Like this one, 4.6. Okay, so your interactivity is better. It's closer to client fetch, which makes sense. I said it should be the lowest of the two numbers, so to speak, or the two numbers. But these numbers are freaking atrocious. Like just like even the cached versions are like, I guess they're better than that, but yeah, I guess they're very similar. But like this 2 seconds here is like if you're fetching on the client, like this is horrible. Okay, let's keep on going. All right. So what did they say? Investing with this can sound fun and good thing, but it's I encourage trying to replicate it. It doesn't have to. It might be browser dependent. Make sure you use Chrome. It's also possible that Next was using a trick to cause early paints. Sometimes if you put certain types of script tags in the header, it can actually trigger a paint earlier. So like I think I actually saw that when I was looking at Next at one point. And I actually did it with an Astro demo, and it was the difference between getting like 100 on Lighthouse and getting like 93. So it's kind of interesting how like you can trick benchmarks by putting script tags on the page. But let's keep on going here. Yeah, I'm not surprised people made RSCs in other languages. I think someone in this chat made one in Go, right? Imagine someone implement RSC in Go. I think they're just calling Jay Larkey out, who did so. Yeah, there is something interesting about that server-client divide, and we'll talk about that in a minute after that we get through this article. But yeah, so interesting. See, they said that actually the slowdown was that the JS got pushed back for some reason. Yeah, so because the hydration is more expensive, which delays everything else other than L2 further. Yeah, so this could be random reflector. What they're saying is this is not like an architectural reason for this happening. This is like these numbers surprised me, and they should surprise you. This is like just like there was some extra overhead for the page, maybe something with scaling, and maybe with a different solution, you'd hit that scaling point somewhere further along. But for this demo, they hit it, and like this was the threshold of the extra work that RSCs did that caused the push. Like kind of like what's going on. Like it shouldn't happen in theory, but in practice it does. So the fact that it's a bit meh. Yeah, okay. So then they went back and probably did it properly. Yeah. Oh, so they were doing client-side fetching. Oh, that's why. Yeah, so they were doing client-side data fetching. Okay, that makes way more sense. I mean, it's the worst. I mean, it's basically like that one, but yeah, and it's worse than this one. But yeah, okay, they're doing client-side data fetching. That makes sense. So yeah, this is not. The funny thing is, your first impulse is like, who in the hell would ever do this? Like add RSCs just to do client-side data fetching. But because of the mutation cycle, this can happen more often than you'd think. But let's get to an actual RSC demo. Okay, let's keep on going. All right, let's get down here. Server data fetching. Here. There we go. Okay, right. Sorry. Wait, why does this get slower again? Shouldn't it be like this? This is not streaming. This doesn't look like stream results. It just looks like a more optimized version of this. Except for our interactivity got longer because the RC overhead. There must be another version. Oh, they didn't add suspense yet. Okay. Okay, let's get to the actual version. Sorry. There we go. Wait. Oh, okay. Not quite what I was expected. I was thinking these would be like a little bit longer. Do you know what I mean? Like, because technically you can get this before you get this because of the data fetching block. And why is this still so high? Is this just purely the RSC overhead? TLDR. So TLDR is final with measurements again. Yeah, client-side rendering is the worst from an initial load point of view. However, the page becomes immediately interactive as soon as it appears. Which, if we go back to our client-side interactivity, in the end, our 4 seconds or 4.1, let's say, I don't think this might have just been a bad run. These should be the same number. That 4 seconds is like right here. On the positive, you're seeing the stuff faster, but the biggest benefit is this jump to 128 is an optimization that it looks like that Next did on their side. I don't think this is an architectural improvement. This number, in theory, with client-side data fetching, regardless of your framework, like this one too, should be the same. Like this 128 and one's like there's like a specific optimization or something there. Otherwise, like these should be the same. It's like you hit a server and you return static HTML and you do data fetching on the client. Like React's overhead, maybe Next does some stuff, but like that's the only thing that we're kind of getting obscured here when we go between Next and Nod, is like how much of this is like optimized on the framework side. I mean, on the positive, this suggests that Next does a lot of good optimization compared to like a naive approach, which makes sense. And I think people don't give it enough credit for. But it is interesting because this is not, I don't think it's the RSC technology that should cause this gap. So does this change? Like if, you can see it here again, like if you fetch the data, then you render everything, you know, again, the pages is slower than the app router. So the app router is actually a performance consideration, even without considering streaming. So, okay. Search engine addressing improve initial load, but cause no interactivity gap. Fetching the data on the server will slow down the initial load, but also make the bulk file. Micro-Frontend server-side rendering to react to components with streaming. Even next can make performance worse if you're not careful. Next app router can make no interactive gap worse, but delays. Server components alone don't improve performance. If the app is a mix of client and server components, they don't reduce the bundle size enough to have a measurable improvement. It depends on what your app is. But generally, there is an overhead to using RSCs, which you saw, especially on this interactivity time and hydration time, which means that like, unless your app is really large with minimal interactive points, yeah, you're not going to catch up, right? Because most apps that are really large that have minimal interactive points should probably just like use a different like not React solution. If you think about it, like use Astro. Yeah, like there's no sweet spot there. Anyways, let's keep on going. We don't prove the apps that makes the client that would treats bundle size and measure and streaming experience into matters. The main performance benefit comes completely from rewriting data fetching to be server component first. Well, or I mean that's a collusion. Streaming and suspense are what matter. This is the actual conclusion. The main performance benefit completely rewriting to server component first. No, the complete performance benefit comes from writing it to be streaming first. But okay, by entering carefully, you can the exact same conclusion, improve input, if you're reading things. Yeah, so yeah, this is why I'm torn because I feel like I like server components aren't what made this gap switch between like the 176 and 128. So if you assume you had a solution like, yeah, yeah. This is kind of interesting because this suggests that the conclusion suggests that like server components are what make this possible. But I think in a world that's beyond React, it's actually not the server components. You can get this sort of performance like in something like TanStack, which is in React, I'd argue, because you have streaming and you don't have server components, and you'd have the same kind of performance. Anyways, that's pretty much. I think this is a great article. I think this is the right approach. As I said, I'm missing like the other, like the third option, right? Which I think is relevant here. But I think this is in terms of the story of showing where server components improve and don't improve. I think this is a very compelling article. As I said, the method, the approach, everything about this is just great. In the future, it should be interesting to see if there's like other approaches there. And actually, while we're on that topic, okay, so actually, anybody in chat got a question? Do we know which element on the sample is LCP? Yeah, I'm not actually sure. I don't think they actually sit in the article. If we go back to the beginning, because the one thing that's interesting about the LCP, if you look at the picture of the page, okay, the toggle's here. My guess is because they can measure the sidebar and the message is different, the LCP is basically the header section here. I'm gathering they can like render like this header. They could probably, I wonder which parts of the sidebar are dynamic that they have to load them. They might even be able to get away with rendering the inbox word, but I mean we don't actually see the cascading. I guess if the demo is deployed anywhere, we could see it. Like I don't know what the UX is. Like if it says inbox and then there's like a loading suspense spinner or something here, then like I'm gathering the LCP though it's mostly this content at the top of the page because this is where the toggle is. Okay, I want to quickly I'm going to throw this out right now. Why not? I'm going to actually publish this one while we're here. Let's publish this to the world. I've got a bunch of HackMDs, and I thought this one might actually be suitable. I'm trying to catch up on these, but I've been thinking about this a little bit recently, and I think it's kind of on topic here, because I mean, there's a few reasons for this that I want to say, but I've been noticing a lot of really great attention coming in around. There's a tweet here. Yeah, TanStack Start is really good. So happy React finally has a good meta framework. This is kind of like a jab, I guess, at RCs. And I was just talking about how RCs aren't the only way to accomplish stuff. It feels like everything I love about Svelte brought over to React, right? Server functions, loaders, isomorphic rendering, all this stuff, right? And the reason, I mean, the reason it does is for good reason, right? TanStack Start was very, very inspired by Solid Start, which also inspired the recent changes in SvelteKit, right? This is a common architecture, and I get to do this now because I love doing this. When something feels really good, I kind of cold shot it. I made a talk, I guess almost 2 years ago, which I called the shape of frameworks to come, and I basically was like, this is how frameworks are going to look like. And I mean, to be fair, I was being like maybe a little bit, cocky about it. I thought we'd cracked it. I was really, really, really happy about this. Tanner was completely on board, and they, started the TanStack Start project, along the same image, because like you have to understand, not everyone was, into this, to this kind of architecture at the time. I think I actually bookmarked it somewhere. Thanks, Dev, for this one. Rich Harris actually had just given a talk that said, we will regret reinventing RPC. And he was very critical of the server function stuff that we were doing at the time. Good reason. There was concern about leakage, and especially React, the way they did their server actions. Like for a timeline, Solid introduced server functions right before the first VConf. So I want to say like May 2022. Was that the first VConf? Somewhere around there, maybe April 2022. I had a version actually in 2021 that used proxies instead of a compiler, but the common one came in 2022. Then Quick added them in December 2022. After we had a conversation, I was like, you guys really inspired me with your $ stuff. Like, we can just do this. Then Next added them the following year. And then that's when Rich gave this talk. And now Svelte is adding them now in 2025. But the thing here is, I think that this pattern feels very natural. And I it's funny, Rich around that time did this like transitional app thing where he was talking about like the server kind of transitioning to the client, trying to describe like this thing of where we're thinking about partial hydration, we're thinking about JavaScript bundles, thinking about progressive enhancement, but which is cool. But it was also a very foggy idea at the time, right? And it got some pushback from like the MPA crowd. Like, to be fair, I was part of the MPA crowd, but like because I was working on Marco, but like the Islands, the Freshes, the Astros, the Marcos, the Freshes, the world, we're like, no, you guys aren't, not the same. We've been trying to establish ourselves as something different, and this isn't the same kind of thing. And just a second. Sorry, just 1 second. Actually, yeah, the perfect timing. I actually have a guest here. Just at the perfect time when we're talking about this stuff. Hey Tanner, how's it going?
What up? It's going great.
Your timing is perfect. I just did a whole thing about RSC performance, and I thought I would talk about that HackMD that I showed you this morning.
Yeah,
And you basically kind of showed up at exactly the right time. Yeah, a wild
perfect.
Tanner appears. Yeah, it's fine.
Perfect.
We'll get into the Cloudflare stuff when they join in about half an hour, but we got a few minutes right now to talk.
Funny, I was just talking with Steve Faulkner about Cap and Web, and I just showed him your HackMD article, and I was like, "There's some weird like overlap synergy here." And so, anyways, that's kind of a tangent, but
Yeah, no, that's good. That's great to hear. Yeah, so basically, I was just talking about like the kind of timeline with server functions. I forgot we also had Bling in the middle there for a bit. Well, we were like realizing that there's a difference between a compiler version and this is actually a bundling feature. Like
yeah, bundling versus framework. Yep.
Yeah. Cap and Web looks cool. I haven't seen what this is. Honestly,
I'm gonna rope you into the demo with the Cap and Web team later, like sometime in the future. So don't worry, we'll get a good demo.
Okay, sounds good. Okay, yeah. So all that I'm basically saying is that even if there's been some efforts to get to the right API, I know Rich was saying that like some parts about what we were doing irked him, didn't quite fit right with him. Ultimately, we've kind of all ended up at the same place, which is this architecture built around streaming, server functions with isomorphic preloaders, and basically client is the component kind of deal. And did I post this HackMD in the chat? I did post this HackMD in the chat. Yeah, well, I'll let you comment a bit on this as I go, but basically I just want to kind of establish what do I mean by isomorphic first. This is, I mean, you could call it client first, but I the reason I want to talk about this is because I think we should be differentiating this architecture. A couple of years ago, I did a stream that was like the future frameworks kind of thing.
Yeah, I remember that.
And I was like trying to show the spectrum where I was putting stuff on one side and one on the other side. And Theo fortunately didn't understand what I was saying and was like trying to make Next.js that thing. And I was like, no. Like,
Yeah, because it's not client first, right? I mean, I've been saying client first because sometimes you got to autocorrect. Like you got to correct really far the other direction to get people to understand. Also, for whatever reason, isomorphic is a scary word for some people.
yeah, I mean, it is a scary word. It's like, what the hell does that even mean?
Yeah, but literally, like what we're all building, like 10-sec start, solid start, like, all these frameworks, they really are isomorphic first is the technical, like
yeah,
where they are technically on the spectrum.
right. But that's different than actually what we've been seeing a lot. Like Next, App Router, Marco, Astro, Fresh, even Remix 3 that we just saw are taking what I consider a very server first thing. You start your app and it is on the server, and then you kind of choose what makes it the client, which
You
honestly,
opt into the client. It's like it's about the ergonomics of opting in, right?
which makes a lot of sense when you consider that the web is a server client model, and like for years we've been doing that, and the HTMX guys and the PHP guys are all like, well, you guys idiots are just figuring this out now. And I maybe
for all these teams, it's like we're going back to the way that it was supposed to be, right? I mean, I get that sentiment, but at the same time, we just spent over a decade investing into SPA architecture.
Right. And I think that like there is other approaches where you can accomplish this. I didn't realize when I first started off with Solid Start that was where I was going to end up on the spectrum. I was really trying to make server components work. I was really trying these other things. But then I looked at something like Quick and I was like, these guys are just like, screw. I mean, it's very server and client aware in a sense, but they were just like, screw you, code runs where it best runs, the end. And I mean, it wasn't necessary. Like, it was very optimal in one sense and not in another sense. But I there's something about their like just attitude that was so like in the face of everything that I was like maybe they're onto something too. Like we've been all building these apps, and me and you, we sat at ReactConf in San Francisco, or it wasn't ReactConf, it was like the last one of Ben's like thing before he went to AI. But yeah, it was like the React in the Park like sequel or whatever. It was at the conference on a panel talking about RSCs. And we can like you were talking about saying something about an Angular 2 moment, but I remember I also said something along the lines that like you have to change it from the root, and this is a big ask. Like this is why like
that's the reason that I don't want to do it, right? It's because everybody's asking me to change it from the root, which has more implications than just putting a directive at the root of your app. Like I think I was telling you yesterday, it's like it wants to control everything at that point, right? It wants you to control your routing, your data fetching. It wants you to flip your entire mental model upside down.
Right.
If you've come from isomorphic and SPA land, it is a complete upside down flip.
Yeah, it's kind of crazy. And I mean, I get it, right? I worked a lot on server first frameworks when I was working in Marco. Like I really got into that mentality. I really understood the benefits. I've been like serialization considerations, all these kind of things that come into the design. And then I understood why there's limits to that and why RSCs exist. So we kind of went through this all on stream. But the thing is, all of this has been assuming that we couldn't just continue on the path we're on. And I realized, mostly because kind of like that last article I did on the stream a bit earlier, like when I got to the actual real world, got to the actual benchmarks, got to the stuff, I wasn't seeing the benefits as much as I was hoping for. And to be fair, some of this might be just the shape of my demos, or the fact that there's an implementation detail on RSCs, like,
or really you did see benefits. Like we see benefits. In fact, I think there's a language comparison thing coming out here soon where it's like there are benefits, absolutely, but sometimes most times I would say those benefits are marginal at best, and it takes like a really faithful implementation of these patterns to really get those marginal benefits.
Yeah. So when I say isomorphic first, I'm just going to read this little section here from my article here. The benefit of this model is it reflects the reality of how apps behave after initial load. As much as we create a full page reload mental model with server first frameworks, the client manages the routing in a lot of these tools. Like now that we have view transitions, React server components, like the client is still like the state is persisted in the client.
As it should.
It's easier to approach from a spot perspective because you don't need to reverse your thinking. You don't need to upend your app from the root. More so, interactions with server stay granular. While waterfalls are always a risk, that's no different than the client today. And we can do things to safeguard that. Finally, if isomorphic is your base, then the client shared components don't need special denotations, right?
That's it right there. That's my favorite sentence.
It's only things that run in a specific environment that need to be identified. I mean, I know you're not a big fan of directives, but what I'm saying is like, use server means server only. Use worker means work on the worker. You know,
Yeah, they make more sense in this scenario. If you approach it from this angle, they actually make more sense, right?
It doesn't matter if you use file extension like .remote, like Svelte does, or sure. you like .server, like Remix did at one point, or whatever. Like the idea is that like you're denoting, like the special case is where it runs in a specific environment and not the other way around. Like there are things that I like about use client, which is a whole other tangent, which is the fact that like it identifies, it says like, I am that thing. No matter how you get to it, you're saying I am the thing. But the truth of the matter is the way we've been building forever is our baseline on these client-side frameworks is that the framework is that it's that isomorphic thing, right?
Yeah, it's a client, it is a server, it's both, unless you specify otherwise.
Right, and that's the thing, right? Use client was always weird, right? I remember Theo wanting to call it use interactive or something because it wasn't saying client only or that. It is the isomorphic part.
It's like use hydrated. It's really like what it is.
Well, I mean, but the funny thing is like, yeah, exactly. Remix called it hydrated, which is I think is a perfectly reasonable name for it. So, anyways, what I'm saying is, isomorphic preloaders, server functions, remote functions, if you prefer, better non-blocking async reactivity are with concurrency, streaming SSR. These pieces all allow this architecture to flourish today. We've added things like optimistic updates. Thank you, Remix. I got to give them a big shout out. Their optimistic updates were a game changer. And then things like single flight mutations. Today, the modern take that started with Solid Start, sorry, I'm taking credit for this, and available in Svelte and React Native Svelte code and Tan Start is we're seeing this proliferate beyond one framework. This is an architecture. Cosmetic differences aside, they're essentially the same, and it's just an evolution of the spas we've made. So I think the question comes in, no server components? Not necessarily. Tanner's been helping me a lot with this because he kept on challenging me, and I'm like, okay, fine, let's brainstorm how this can work.
Tanner.
Right? So like at first, I just wrote this article here, which I can share. We've talked about this on stream before, which is like designing how they would work. Tanner looked at it and gave some feedback that actually inspired what I wrote today, which we've been talking about this for ages. But see, my problem with lakes generally, and I was critical about on this in Remix stream, is those waterfalls, right? It's very easy to like set a prop, like picture a world in which you can just import a client component or sort of server component on the client and just like use it like right away, like as a component. You get this weird thing where you're like, okay, client does an update, passes a prop to the server component, which now it's updated, it has to go to the server to render, and the server component then ends up
recursing on itself into
another client component because it changed some props, which then would cause the client component to have to change, which then goes, oh yeah, actually show this server component. Like the trees disconnect. This has been the whole argument with the React.
If composition is your only API for that, and you can't hoist, then yeah, you're in trouble.
Right. Essentially, the whole idea is that like, if you keep the server as a single tree, the same way like we keep the light DOM a single tree in web components, or like I'm trying to think of another example people have seen. Islands are the same way. If you keep it a single tree, then there's no waterfalls. It's like literally by design impossible to waterfall. But we've basically been spending the last like 10 years how to design smart patterns around waterfalling. We have those preloaders for hoisting. The work that's been happening in Solid and Svelte around async. A big props to Svelte on this as well for investing this route, is showing non-blocking async, where you don't just like await in the component, you're actually like get granular async, so that I said the other day.
Keep rendering, if you can keep going down and do things in parallel, you do, right?
Right, exactly. And then things like suspensive stream, when you start putting these pieces together, like I was saying, it's not that far to consider that maybe we can apply the same models. And I think the critical piece that Tanner kind of brought up to me here, which I paraphrased one of his examples that he shared me, and I don't know what these wrappers look like, but just humor me, and this is written in Solid, not in React, but you get the idea, is if getting the server component could be some kind of, I said this a wrapper create sync, but like some kind of like hook, like maybe tanstack query, whatever, even just like some kind of like use wrapper over use or something like some.
Maybe we should use a directive.
This isn't not here. The directive I have is here, but I mean,
Just make some more. Let's make some more directives.
My point is that like if you had some kind of thing like right now we use these kind of patterns like create async or use in a component or tanstack, and you just grab the data. What if the thing you got out was a server component?
Oh, let me point that out really clearly right here. We've been calling them server components, which is a lie. They've actually been server elements.
Oh, okay.
And this is an actual server component that you can render.
Because what's really cool about this model is we're saying, okay, if you have the server function, again, Tanner has a different syntax. I'm just using the directive here for my sake. But essentially, if you came in here and you rendered some stuff on the server, but the thing that I needed to render this was the ID. So I pass this in as an argument, kind of like I would to like tanstack query. You know, you have your dependencies that you have.
Yep.
If you pass
server dependencies,
if you pass the arguments you need to render in something that you can hoist or preload, like this thing, we've done this a bunch, then where you render it, even though it looks like it's getting props, if the props that it gets in here would never cause this to re-render, you actually you actually get kind of into this place where you don't have to worry about the random waterfalls. You actually control it, right? Your server component re-renders is based on data fetching. It's a server function. And then it basically, what did I call it here? Did I have a name for it? Server function return dynamic HTML templates. Yeah. Like think of it as them returning like templates, like the potential of injecting client and server stuff together. Right. If you view it as a way of having dynamic on the fly templates, then it's not just because some prop changed here that's going to cause some weird waterfall. It's deliberate. It's like, hey, you could hoist these up. You could do them in parallel. Tanner had an example where he had like two of these, or no, maybe I did that, where I put two of these up here and then like nested them. That doesn't waterfall because
you can compose them together too. As long as it's slotting, yes. You could take multiple calls to server components and slot them inside of each other different ways inside of client components. Like you can just render them however you want. It's just templating at that point.
Right. And the thing is, they could also, and I go into this more in this article, which is why I tried to link it before in the chat. You can have them. I did Hacker News example to show this stuff here.
The recursiveness of it, yeah.
To make it recursive, but you can pass render props to essentially server functions, and that way the only thing that gets serialized to the client is what you actually like. In here I have somewhere I probably call props.children with like I called the children here with the data from the server. Yep. You could also pass promises through like you're essentially just serializing a server function. You know how we get promises, then we can stream them. Essentially you get to this place where the only thing that you serialize is what you call the client passed in props in on the server, and then they can come back out into the client page, say like via render prop. So it's completely possible to put these together and make the composition pattern like this, even with like a weird thing like this, where this is Hacker News. If you ever seen it, it's got like 1,000 of nested toggle switches on your stories. So you have all these stories nested and you can close and collapse them. Well, in this scenario, what I'm saying is you could say, hey, I want to get my stories from the server and the markup, and then my interactive thing that I'm passing, I use children, it could have been a name prop to make it a little bit more clear, is just this toggle. The toggle has our signal or our state in it. This is the only client code that we really need in the app. This is the client code. And then the rest of this is
server rendered too.
Yes, server rendered, all the nested. Template. Yeah. So so essentially we've managed to render the template and inject these client-side toggle components recursively around it. So like this is the same pattern, and I sort of asked myself, like, can we solve double data and serialization? It's like honestly not directly, but the same way we would in that. If we can identify that a template is being basically passed through as a template, we don't need to serialize it as a prop. during initial rendering. If we go like, if it's been consumed by here, we can reverse the template. We can just pull it out of our markup and get the prop from there so that we don't have to double serialize. To be fair, that stuff is tricky when you consider async timing. Like you can only do that up to the first flush, and then you start kind of coming up with these interesting solutions where you're like, after the first flush, instead of sending the HTML into the document, you just serialize it as a JSON and then client render it. But it's really just putting the string in.
Serialization thing would be very tricky. But I mean, it's
doable.
Even in its worst form, it's really, really cool. And it's something that I think that it would be solvable.
Right. Exactly. So this is just like a hypothetical here. But yeah, so what I say, one could preload the server function, the route preloader, they could call multiple at the top of the components. But the important part is the children projections, slotting props will never cause a server component to re-render. The view code doesn't cause re-renders, but fetching does. You have to update the use or the underlying create async. I think this, while subtle, is a huge difference over just naively importing server components in client scope or using abstractions like frame to do HTML partials, because those generally tie the mechanism to the UI. And the thing is, server components can pass arguments back to the client via render props. I covered that in my other write-up. Yes, it does compose back and forth. The fundamental difference, though, is the client is a single tree and the server isn't, which can, in theory, cause waterfalls, but also means you aren't beholden to reloading the full page or full route section to update parts from the server. So, like,
it can cause waterfalls, but like you said, we've been solving that problem for the last 10 years, and we have great tooling around it now. Yeah. And honestly, like for a lot of the stuff that I'm building, that we're building, it's so much more important for me personally that I could treat these templates on the server as just some more server data, some more server state. I could chuck those server component calls into React Query or TanStackDB or the new Solid 2.0 async stuff, and it doesn't matter because I know that they're only going to refetch when the data that they need to fetch it's called.
It's the granularity again. We get that back. The thing that we lost with server components when you do the mutation is you end up being like, let's re-render the page. This is the closing the loop has been. This is why I wrote those things, and I ultimately gave up on server components because I was just like, this is fine, but like there's this weird tension where you're like, I want this to be interactive. Now I have to make it into client component data fetching, which if you saw in that last article, isn't great. So then you're like, okay, well then I fetch on the server and then I pass the promise through the serialization boundary and then let the client like pick it up after the fact. And
this doesn't solve this problem, but like optimistic updates are a big problem with React server components, right? And there's still a little bit of like, okay, how do you optimistic update a static HTML template kind of a thing, right? But at least you're breaking down the granularity so that some of the optimistic updates you can do aren't trapped inside of this single tree on the server.
Yeah. What did I say? You get partials without having to mark the client side coming in, no use client, island, or hydrated.
I'm sorry, but that alone, just people would love that. I would love that, right? It's so, when you're building these kinds of apps and you're saying isomorphic first, I'm isomorphic first, it's so much easier to reason about the very few and very clear boundary steps where you go into the server to do something and then you just come back to your isomorphic land, and your code base isn't littered with these use clients everywhere in this use server, and you're not like creating multiple files to kind of put them inside of each other. It really just comes down to that one interface of when do you dip into the server to generate this template and when does it come back? And after that, you're done. And it's actually a really clear mental model compared to the server first one.
Yeah, I mean, the thing is, no one's built this yet. So, I mean, I'm speaking hypothetically like I usually do, but I think that having these conversations made me really feel like we should cement this as an architecture, right? Because I want to acknowledge that it's something that's already happening today. Like we already have these things showing, like these patterns showing up in frameworks.
BRB, I'm changing client first to isomorphic first in all of my marketing.
I mean, do we like the term isomorphic?
No, but I'm making a point, right? Is that I think by saying we're client first, I mean, nobody's really thinking about SPA as like a full stack architecture. And so the only language we have to use that we have to describe this without saying isomorphic is client first full stack. That's really what it comes down to, that's what isomorphic means, right?
Yeah.
But people just hate the word.
You're building, it's like you approach things like you're building an app instead of building a client web or like a server client web service, right? Like it's more like mobile. Like your thinking is like, I am building an application and there's one code base versus being like, I have my server stuff and my client stuff. Don't get me wrong, there is server stuff with use server, but you treat it like an API, like something that comes into
it's just an API call.
Which is cool because what did I say here? This is not HTMX or PHP. This is evolution of SPA. Straddling the line is hard. As much as we should recognize leveraging the server more improves initial load considerations, leveraging the client more improves interactive potential. What's interesting to me is whenever we move closer to the server, there's this tension to use non.js on the backend, which feels real. Like render your server components and go. Where this pretty much flies in the face of a bit of given that SPA is the base. But on the other hand, server functions could be done in a different language as long as they can serialize the same. It doesn't help with SSR, admittedly, but it's interesting. I wonder if there's a future where things marked with use server just get deployed to a different server that's closer to the database, and the rest goes to the edge or the browser. At least there's no ambiguity there. Because
that is a great point because, React server components and the server first means that you have to use the same thing on the back end going into your application to generate those. Let's just start calling them templates because that's what they are, right? To generate these server-side templates that are composable. But man, if this protocol was focused on like the isomorphic first use case, and it was just templates, you could fulfill that protocol with anything, whatever you want. You literally could, write Go templating code somewhere in your, whatever, and have it execute it and go. And as long as it came back with those right slots and the right serialization, Bob's your uncle, right? And you could technically fulfill this across frameworks and across languages, which is pretty wild.
Yeah, and this is kind of like whatever I think my answer is to like stuff like PPR. Like the tricky part about PPR is that you render everything outside of the suspense boundary, and it's kind of like this arbitrary switch where you're like, okay, like what's available at the time of rendering versus not. And I think when I was playing with it, I was like, oh crap, what if something's like cached and then not cached, and then like and the boundaries don't match, and then how do you reconcile it? Like this is like no. That's why I made that use pre-render thing joke kind of earlier. It's like you're like, this is definitely somewhere else. There's no so you can basically isolate those pieces and be like, yeah, this is the part that goes next to the database. Definitely.
Even makes use server more meaningful if you really think about it. Like use server right now is more like, oh, how do I create this RPC? But everything's kind of server first anyway. So what does use server mean, right? It almost gives more semantic meaning to use server at the end of the day. It's like, no, we're in an isomorphic environment. Use server means this is only going to run on the server. And it's like a different environment. You can fulfill it however you, sorry, I just wrote a blog post actually on directives and how I just think that they're meh. But
did you actually publish it?
Yeah, I just barely published it actually. Go to handstack.com. Click on blog, left-hand sidebar.
I will cover this later on. But
I just want to show you where it is. There's a blog link about halfway down, right there. Okay. There it is, directives.
Okay, cool. I will check this. I'll make a note of checking this out later. But we are almost ready for the main event, so to speak.
1 minute.
Yeah, I hopefully Natalia joined on, but I'm going to talk a little bit just briefly here. So because I thought it was a really cool idea. Actually, let me put web fragments on here. Today we're going to be talking about micro-frontends, and I think it's interesting because I've never liked micro-frontends. Jack Harrington was always like, look, this is how you put solid in your React app. And I was like, yeah, great. But to be fair, I also worked at eBay, and eBay was an MPA, so they kind of pushed back the micro-frontends thing for a while. In a sense, each separate Marco page was already its own kind of front end. But the reality was, we were in this zone where we had lots of, different parts of the page even there, like the header or the search bar and all this. And they kind of got away with it for a while, but then we had the real task of coming up with a micro-frontend solution. And I think what Dylan came up with at eBay was pretty good, but this is something he had to come up with. We looked out there in the market trying to find a micro-frontend solution, and we weren't really happy with what we saw. A lot of them were like, what's that Webpack thing? Module Federation. Like they were like this client side thing that we kind of pull it all together. And we had a lot of issues with this because it was like the amount of JavaScript, the different versioning. It wasn't solving our problems. We were like, in this case, very server first mentality. We were serving e-commerce sites that needed to be loaded at the speed of light. And essentially, we found ourselves like, crap, we actually have to build our own solution. And it's funny, when you went to, I forget the guy's name was Zach or something, we talked to the guys from Webpack a bit, and they did have a server-side solution.
Zach Jackson, probably.
Yeah, but the thing was like, that wasn't the free thing you were paying for, or sorry, you're getting. You had to like pay for this, or it's like hidden behind like special products and stuff. It wasn't something we could just pick up. However, I've been talking to the guys like Igor from Cloudflare and a few others for a couple of years now, and they've been like, no, we want micro-frontends for everyone. I mean, you can understand why they'd want that. Maybe I'll get them to actually explain why they want that. And there's a lot of similarities to what we had built in-house with eBay here, I got to say. And so I'm actually pretty carefully optimistic that we might have actually cracked this thing. So without any further ado, I think we should invite our guests on the stream here so we can get this conversation started.
In full disclosure, I've seen Web Fragments, and I actually just watched Igor talk about Web Fragments just a last week at Cloudflare Connect. And likewise, I'm really impressed with this approach, both holistically and like even hopefully we dig into some of the internals of how this stuff works too, because it's just really, really cool how it actually works. So I mean, I know some people will probably dig in here and they'll be like, oh, cool, it works for my micro front ends, right? I'm even just excited about the underlying tech that's like how it's operating. Sorry, I don't want to steal any thunder. I'm excited to be here and talk about this with you guys. So let's keep going.
Yeah, sorry. Yeah, I maybe brought you guys in too early. I didn't realize Tanner was going to gush as much as I was going to. So welcome Igor and Natalia to the stream.
Thank you.
Thank you.
Thank you for having us. And I wanted Tanner here because when I showed him the first time, like he was literally the most excited person about the internals. Like people get excited about the results, like what they can do. But when I showed Tanner the insides of how it works, he was like, what? This is impossible. No way. And I was like, okay, we need to bring him on the show because
I started thinking, how else do we use this? Like the internals themselves are cool products, Yeah. Anyways.
That sounds exciting. So, where should we start? Should we just talk about what web fragments are and what inspired the start of this project?
Yeah, maybe let's do a quick introduction. Natalia, do you want to go first, just so everybody knows who we are?
All right.
Sure. So, I'm Natalia, and I work at Developer Tools at Microsoft. So, a little bit of VS Code, GitHub, all these products that you may be familiar with. And Igor.
Yeah, I'm Igor Minar. I'm at Cloudflare engineering, and I build a lot of web developer infrastructure, things that help other developers be successful building web applications. So I'm associated with the developer platform, but also helping internal teams actually use the developer platform for building our own micro-frontend. And what we'll show you today is something that is used at Cloudflare for mission-critical application, for modernization of that application. And I'm excited to show you Web Fragments. And we're intentionally building, just for the context, like Web Fragments, I'm intentionally building it in the open source because I don't want Cloudflare to end up being on a tech island using something that only Cloudflare uses. And I think this is such a cool tech that anybody can really benefit from it. And it would be a shame to keep it behind the firewalls of a single corporation. So with that, I think we should just jump straight into like what are web fragments and what are the problems we're trying to solve. Natalia,
Yeah,
do you want to talk about like why we built web fragments and how we got to?
yeah. And I'm sorry for skipping past the introductions. I get so into the tech that I just want to like dive right in. But yeah, because you first came to me like showing like some kind of like hint of this. I feel like 3 years ago. Was it like 2022-ish? Like it was a while ago.
Yeah, I started working on this in 2021 actually,
Yeah.
before joining Cloudflare. But back then, like I wasn't quite sure how to do it all. It just sounded too crazy, and I felt strongly that that like one of the main motivations, and Natalia can, and this is how like Natalia and I started collaborating because we are both passionate about micro-frontends, and I think I heard Natalia talk about micro-frontends on one of the other podcasts by Brush, and I reached out to her, and ever since then we started like collaborating and brainstorming on ideas. And then I go to Cloudflare, and I did a little more research on web fragments, and eventually it got to the point like we published some blog posts. I think around 2022. You're right, but that was the timeline, and those were more like a research blog posts with some demos and like hints of what would be possible. But then last year we had a dire need within Cloudflare to improve our own Cloudflare dashboard, which is the main control plane for all of our customers. So basically, Cloudflare helps support roughly 20% of the internet. So 20% of the internet is controlled through this control plane that we call dash.cloudflare.com. And it's a big legacy application that is struggling with lots of like legacy typical monolithic SPA problems.
Is this at all related to that like outage that happened with the use effect loop? No. Okay.
Well, yes and no. I mean, the problem is that the application is so there's so much technical debt that it's very easy to sneak in problematic code, and that's what happened in that case. So with the web fragments, we are completely rebuilding dash.cloudflare.com, but doing it incrementally and replacing, like the goal is to replace almost all of the code over time.
Okay, that's cool. Yeah, you were mentioning a while ago that you guys were like actually like using this technology to kind of like shop different technology solutions even within the, like it itself. Like you had some stuff you were building like around Remix or around Quick and different. You test bed to even try different frameworks and different technologies, which is really cool.
And even today at Cloudflare, we are running. We used to run Remix, but with the React Router 7, we didn't feel comfortable staying on Remix, so we moved over to React Router 7, which I have thoughts about that move, but it's like the best thing right now in the React ecosystem, so that's what we're using, and we're also using Quick. So we're kind of like using those two solutions. Quick is still very much experimental. The Remix Router 7 is the mainline development.
Gotcha. Okay. Cool. Yeah. Just I love hearing about like how these things actually going to come together, which is really cool. All right. So
Natalia, would you like to?
Yeah.
Sorry.
Yeah. Go ahead.
I think let's talk about like what is the problem that we're trying to solve, and I think Natalia can cover that part. We've been talking about it a lot.
Yeah, I think that that's exactly what brought us together and in collaborating in this project, because back in the day, I think it was 2017, I was working not in product, but in a very large enterprise platform. And I'm talking about over 1,000 websites that were localized, and it was a massive components library, and then you have to rebrand it for each vertical of the same enterprise. And then you start realizing, okay, it's just loading, and we need to find a solution to reutilize these components in a way that is effective. But not only, we need to find a way to scale this, we need to find a way to integrate new features, to migrate, and then you start thinking about Micro-Frontends. How can we have two versions of components library coexistent, or more than two versions, right? And so I started exploring different potential solutions, one of them, a bit later, I think it was 2020, before the release of Webpack 5, that was Modules Federation. I started diving really deep into it. And of course, like every solution, it has pros, it has cons. And I wanted to try and come out with a different option.
Can we
And
can we pause on that for a minute? Can
Yeah.
you like summarize a bit on the pros and cons? I just want to kind of understand what was there anything specific that kind of stood out to you, which made you want to go a different direction?
Well, back in the day, there wasn't any other way to statically analyze anything that was not running in the same infrastructure that you were running, right? And so that piece of technology offered more options. But of course, there was still the problem that you needed very, very good governance to make it work, and make it work in a way that everybody was on the same page. Because what was really important to us at the moment was, okay, how are we going to migrate from one version to another? And we know, everyone knows and has been facing the problem of dependencies and peer dependencies and optional dependencies, and that's when the things start impacting everyone else. When you want to actually expand your decisions and make them adopted by other teams. And that's what Igor calls fate sharing, right? So you make a decision and you think that it's going to only be affecting your own domain, but it's never the case, right?
Yeah.
So
I mean, you guys have both seen that, you know, with Igor at Google scale and you at Microsoft. Like, it just, I have to imagine the kind of horror stories that come from that are just immense. So,
absolutely.
did you guys like? So there were some solutions around. Were there any internal proprietary solutions? Like, I just, because you said you were looking at like Webpack, but I guess the problem is like the solutions at this point, even like, was this at Microsoft at the time?
No, that wasn't at Microsoft.
Okay.
No, but I don't think we have any proprietary solution at the now or before that time when I wasn't even at Microsoft to solve this problem.
Yeah. So, yeah, because this was like a topic that you'd always like hear certain companies apparently have like some success story with, but then it was never readily available to you. Or then like, you know, you looked out and you're like, okay, I need to do this yourself. And you're always just like trying to wing it. So yeah, I definitely need, it's very cool to kind of hear that kind of progress. But okay, so where did you go next? Like you said, you definitely, there's an issue. So how did you guys end up working together on this? Or
well, initially we were just discussing and exchanging ideas and trying to find a way. I think Igor was already on his end working on the earlier versions of Web Fragments, even before he joined Cloudflare. So he'd come to me and ask me like, so what do you think about, I don't know, let's suppose it's iframes in the context of Micro-Frontends. And so we would have really in-depth technical discussions about the pros and cons of every, I guess, every part, every building block of that idea he had in mind and was putting together. And then last year, I started actively contributing to Web Fragments.
Which is awesome, because now it's like, it's not just Cloudflare. This is a multi-company, multi-person open source project that's there. When did you like? Has this been officially released yet, Igor, or is this just kind of like?
Yeah, it's been on GitHub from the early days. All of the code has been open source. It's just, you know, this is enterprise software, and it doesn't really make sense to market it heavily until it actually works for enterprise use cases. So I did publish together with the team the initial like research blog posts, and got almost zero response. And I was like, yeah, nobody really cares until this is like something people can use. Nobody's gonna care.
It's an interesting topic because the people who really care about it and need it, like, know they need it, and then the other people are kind of like, please just go somewhere else.
Yeah, exactly. So then I was just like, there's no point in trying to like go out and market this because nobody's gonna care until it's close to be ready.
Right.
And it started to be close to be ready like this year. So Natalia and I have done a bunch of talks at various conferences, mainly just to start socializing the concept and the name, and solicit early feedback from people. And that has been very useful because we had a few companies try and pilot and give us feedback, because once again, like, it should be general purpose solution. It shouldn't be just something that works for Cloudflare. And the way we are building it, we're trying to be totally vendor agnostic in any possible way. And that is very much intentional design decision, because we want to support any framework. So regardless of where you're starting from, whatever your current legacy application looks like, you should be able to integrate it with it. And we should also, we don't want to force you into one particular framework as your destination, because the web fragments can be used not only for scaling of existing applications, but modernization. All of us in enterprise, we have these big monolithic applications. Many of them are like 8 to 10 years old, that have been architected using the SPA model typically. So, in a way, you can say that I'm trying to like correct the problems I created with Mishko and AngularJS and Angular, where like SPA is the way to go, and now we're just like, there's something to the server side, and maybe we should do some more side on, like, let's not lose the interactivity on the client side, because that is awesome. Like, that's what AngularJS and React and Vue and all of these frameworks give us. But also, like, let's not throw away the server side completely the way we did with SPAs, because there is value to the server side.
On point with that, Igor, sorry to interrupt you, but that's another reason why I've been drawn to web fragments. I think I am preaching about going back server-side and server-side rendering since also 2020, early 2020. And which I am also part of the GD program for Angular, and it was like, oh, hey, what are you talking about, right? You're supposed to be promoting these client-side technologies. I was like, yeah, but I'm not really sure about it, because in practice, these may be not as good as we want it to be. So yeah, sorry, you were going.
No. So anyway, like, web fragments is a way how I'm trying to course correct, and the direction in which we set the whole industry on to this big shift on the client side. I would like to go back to the server side, but by now we have such a humongous applications that are mission critical in enterprise. And it's just impossible at this point to just rewrite them in one go. Like, big bang migrations no longer are possible because these applications are too big, too fragile, and too important. So there's very little opportunity in the industry for big bang migrations. So that's why I thought, could we use Micro-Frontends as a way to incrementally migrate onto a new stack and modernize these legacy applications? And could we do it in a way where you could go from a legacy big monolithic SPA to a more decentralized server-side or full-stack rendered this Micro-Frontend setup? And that was like one of the driving motivations for web fragments, and that drove many of the decisions and how we baked it.
That's really true too. Yeah, because most like client-side spot frameworks, it's not just as easy as just like going flip the SSR true flag on. It doesn't really work on like that. Part of it is there's like architectural.
It doesn't work at all. Like yeah, people, like, I so often people come to me like, oh, we have this big applications built with React or Angular, and we just want to like get it to server-side render, and it's like, get it.
Yeah, it's kind of funny because like I mean, besides the actual like underlying like solutions not having that as an option, like because you're on Create React app from whenever, like there's architectural structural stuff that has actually shifted over time, but those old apps are not like that. They are built in a very specific way that is not easy to just kind of flip up. So yeah, I mean, that's interesting. Micro-Frontends also as like a modernization migration mechanism, because it's interesting. It's one of those topics where like you see there's a lot of overlap between people's incentives for micro-frontends. I know these are all different technologies, but web components and for what's the third one I would say, islands architecture. All three of these have commonalities of trying to isolate sections of your code to varying degrees and to varying successes. I think safe to say that like on that spectrum, web components are probably the least isolating, islands are the next, and micro-frontends are the most isolating mechanism of the three. But it's I think it's interesting where like some people might even be choosing the wrong solution for the goal, like depending on what the goal is, because I think all three of those are actually great for migration story as well. But there's like trade-offs and benefits to each. So yeah, I'm very interested. Everyone knows what I think about web components and islands. Talk about a lot. Micro-frontends. This is interesting. I want to see what that is, how that works, what that looks like.
Yeah, should we jump into some code and demos and stuff?
Sure.
Yes, please.
You guys can obviously, if there's anything to share on the share screen, we can do that.
I think for the folks that are not familiar with micro-frontends, there are important distinctions, and it's about the split. How do you break apart your application and how you put it back together, right? So if you are thinking about island architecture or you're thinking about web fragments, you're probably thinking about migrating in a horizontal fashion, which means you are loading one page, and in that page you're going to have different components, and then some of those are going to be migrated into a new technology, but the rest of the page stays the same. And typically, you're going to try to align the technology stack and the tooling of the areas that are legacy and those that are new. In web fragments, you can both have a vertical split, which means you could have a completely different application per domain, or you could have a completely different application in the same horizontal split, and they don't have to share the tooling you use to build it. You don't have to share the vendor where you're running the hosting and the infrastructure, and you don't have to share the framework you chose to use it. So, Igor, I think you were wanting to share something, or I don't know who was sharing their screen.
Can I share my screen?
Yeah,
sure. I don't know how this is controlled.
Yeah, give me 2 seconds. I just need to remove myself so that I can add you. Bang.
Cool. Yeah. Can I control this? Yes, I can. Okay, so if you think about web fragments, like one of the things like I keep on talking about is that many of the problems that we have in software engineering today have already been solved in some other domain, often in another software engineering domain. And in case of micro-frontends, it's really the inspiration that we should be drawing from is microservices from the backend. So on the backend, many of these problems have surfaced much earlier because people got into a situation where they had big applications very early on. And what happened on the server side is that they built microservices and they came up with virtualization, way to encapsulate things. So like imagine building microservices without a Docker. Like what would you do? Like you would still have your independent applications and you would upload them or install them on these virtual physical servers, and have them coexist in one operating system, and eventually they would collide in some way. They would collide, either the ports would collide, or there will be file system collisions, or system library collisions would occur sooner or later. So on the back end, we came up with virtualization, and Docker is probably the most well-known solution to that. Docker allows you to run an application in this virtual container that looks like operating system, so the application doesn't know that it's not running in a real operating system. But this allows you to run multiple applications on one physical host without the collisions. So on the front end, we adopted some of this, but we adopted only half of the solution. The microservices became Micro-Frontends. And we kind of didn't figure out how to do virtualization. So we're still loading all of the Micro-Frontends on the client side into one physical host on the one window, browser window, just like as if you were installing multiple applications on the server into one physical operating system. So what Web Fragments solve, and this is what they are radically different in, is that they give you micro-frontends, but they also give virtualization. So it's really the combination of two that we are familiar with on the server side is now available on the client side. And we can talk about how that works, but what it enables you to do is you can take legacy application that typically has some kind of shells and header, navigation, some content area, and you can identify what is the most valuable part of this application that you would like to modernize and turn into a fragment. And just like Natalia mentioned, you can do a horizontal split, you can do a vertical split. It's totally up to you. Web Fragments don't care. You can make fragments as small as a single button. You can make fragments as big as a ginormous monolithic SPA. It really doesn't matter to fragments. But once you identify, then let's say that we're going to replace one particular route. Maybe it's the homepage, because that's the one that our customers see the most often. Then you can rebuild it using hopefully new stack. Hopefully you will go full stack and do server-side rendering. And you deploy it. And you deploy it to some place. And Web Fragments don't care where that is. If you are on AWS today, you can continue deploying to AWS. If you want to switch to another vendor, so for example, you want to go to Azure or you want to go to Cloudflare, you can deploy the fragment itself to a different provider. That's totally fine. It's totally up to you. We don't care. And then you compose the legacy application with this new part. So basically, what used to be provided by some route and component within the monolith is now the UI is provided by a web fragment. And you can seamlessly compose the legacy application and the new application, even though they are probably using different technologies by now and potentially hosted on different providers. So this allows you to break up the monolith and avoid fate sharing, which is really the ultimate problem. And many people tell me that that scaling front ends is really just a matter of discipline. There's really only so much discipline you can have when your team is growing to like 50 or 100 or 2,000 front-end engineers. Like the biggest micro front-end I worked on was at Google, where Google Cloud Console was contributed to by, I think, 2,500 30-day actives contributors. And at that scale, like, it doesn't matter how good your monolith is and how disciplined you are. Like, somebody's going to screw up, make a mistake, and it's going to affect everybody. The build is going to get slower. The payload size is going to get bigger. And you basically need to decouple the fates of these individual teams and find a way to deploy parts of the application independently, but in a way where the user is not aware of that. Because you want to have cohesive experience, but you don't want the developers to contribute to single monolithic code base. So with this, what you get is you get independent development cycles. So each of these fragments can be developed and deployed independently of each other. You get truly decoupled from the monolith and from all of the other fragments that are being built. and you can compose them back together. Everything is fully encapsulated. This is the virtualization part that is so critical. Like encapsulation is achieved through virtualization, and we'll talk about that. And it's all tech and provider agnostic, so there's no locking. You don't need to worry about, if you start using this, then forever you'll be on Webpack, or you're locked to Cloudflare. Like, this stuff works really well in Cloudflare because that's where we build it, and I think the Cloudflare is pretty cool. But you don't have to use it with Cloudflare. I'm collaborating with Natalia intentionally because I want this tech to be accessible and available to anybody, and people should be able to use it wherever they are. So with that, let's look at the demo. And this is a demo that Natalia actually built and made it super awesome looking. This is definitely not my work. I'm not a visual person, but I do appreciate the visual goodness here. Natalia, do you want to talk about what this application is about?
Yeah, so we started off a React application, a fully client-side SPA. I think it was React 19. I don't even remember. So it was a prototype of an e-commerce client-side with a banner that is dynamic, and it has a catalog, and it has the shopping cart. That's the usual layout for this kind of application. And each
each item.
Yeah, each item has its detail page. That's also pretty standard. And what we did to demonstrate how web fragments work is we are keeping what we call the shell, or the host. The host application continues to be this React application, now running on an Express server, because web fragments needs middleware, and we're going to talk about it in a bit. And what it's doing is now fetching these web fragments from a remote host, which are rebuilt and run in different hosts than the shell application for the catalog and the shopping cart. So now the catalog, with its internal routing, is a Next application, and the shopping cart, and you can see it here, Igor is running it on localhost, but we have also the same demo deployed. The shell is in Azure, and some of the fragments are on Cloudflare. And the shopping cart is a quick application, and you can see it here, standalone, in its standalone deployment. They are both fully functional standalone, but then when they are put together, combined, or composed into the legacy host, they become fully functional, interacting with each other. So obviously the user experience is not affected, is not impacted by this split, but each one of these applications map to a different team, an independent team that is working on them, choosing their own technologies, running on their own release cycles, and on the hosts that they prefer, while the legacy application continues to work in the same way.
Yeah, so
that's very
just to
cool.
recap, like this is the legacy version. I know that I'm switching between tabs. So in this tab, we have the legacy version, which is monolithic. Client-side SPA built with React. We actually gave it the proper enterprise treatment. So if I do a hard reload, we see loading for 5 seconds, because that's what enterprise applications look like these days.
Because we're loading the analytics scripts. And
yeah, we're loading all the analytics scripts, the marketing scripts, and whatnot. And then the application comes in and just shows all of this in one go. So we took this application, cut out this catalog part, and rebuilt it as Next. So this is the Next application. It's fully interactive. This is vanilla Next. There's nothing special about it. No plugins installed, no modifications, just vanilla Next. One thing that you'll see is that the router is set up to match the routes of the legacy application. So we have /store/catalog, which is the actually that's interesting.
Well, maybe
Oh.
not, but we could have done it.
Okay. Yeah, we could have done. But if I go here, then we have store product product. Okay, because it's prefixed. That's why. That's why it was a little off. So we see product 1, and here we see store product 1. So it's just prefixed. And then this application is the shopping cart, and just for fun, we built it with Quick to just show that you can mix and match different technologies. And this tab is the composed view, and I have this
Right.
toggle to actually show where the boundaries are. So these are the boundaries of the fragments. As a user, until I pointed out, you can't really tell that these are 3 different applications running. But once we have the border on, then it's very clear where the boundaries are. You can still, everything works the way you would expect. So I can go to the detail page, the product, the URL updates. I can use the back button. Like everything just works the way you would expect. As a user, you have no idea that something's different. You can even add things to the cart. Things add to the cart, even though we are now doing like cross fragment communication. And there's one piece that is kind of cool, and that is, remember how in this application the treatment you had was this, where you get 5-second pause and then everything comes in. Well, we thought it would be shame. Oh, here it is. It would be shame to not take advantage of like, oh, both of these fragments are server-side rendered, but the shell is client-side rendered. So if I do a reload, you see instantly, you see this fragment rendered instantly. This one is not rendering yet because there's some pending work that needs to be done, but that will also come in very fast. And the rest is missing. And the rest is missing because it doesn't exist yet. It's a client-side rendered application, right? So there's this technology that we call piercing, which is part of web fragments, comes out of the box. And what that allows you to do is it allows you to pierce the server-side rendered content through non-existing client-side rendered content and display it as early as possible. Now, in production environment, you would actually probably generate like skeleton or something so it's less visually odd than this. But the cool thing is that this application is actually fully interactive. I can click on it and do navigations while the legacy application is still starting. So think about this, like the legacy application doesn't exist yet. It hasn't rendered any DOM, but I'm able to render the inside part of the DOM tree, show it to the user, make it fully interactive, and once the legacy application, the shell starts and renders, then you will, if you look at the inspector here, you'll see that this is deeply nested in the legacy shell. And you can't really tell, you can, if I highlight, you see that the fragment is nested, and there's this web fragment tag. It's nested in the tree rendered by the client-side application. But that tree doesn't exist at the time when this subtree is created. So there's like a bunch of magic here, and I'm hoping that we can dig into that and talk about how that works.
Yeah, I was gonna say I've seen like out of order streaming, but that's like, this is like that generally works outside in. This is inside out, which is just like
yes, exactly. How can you render a child within a tree where the parent doesn't exist yet? So I don't know in which order do you want to tackle this, but yeah,
there's
what interests you? Where would you like to go?
I mean, there's a lot in this demo. I think the first question, and it came up from chat, and I was thinking this too, because you loaded the apps separately, right? So like the one that really comes to mind is the shopping cart, right? Like where you can add stuff to the cart, and you're like, how is it, if you can load the quick app separately, how is the main app talking to the quick app, or like how is the Nux app talking to the quick app or whatever? Like, and that's the first thing that comes to my mind. I don't know, Tanner, is anything that first comes to your mind?
talk
Natalia,
about
do
the
you wanna-
isolation. I mean, it's funny we call it isolation, but it's also very entangled with the way that like state sharing happens as well. Talk about it. Show them.
Yeah, like this is number one question we get. So Natalia, you go. You tackle this one.
So I think somebody else in the stream is asking about state, and so let's tackle that in communication between fragments. What we're trying to do also with web fragments is to leverage the web platform APIs as much as possible, because that's one way of becoming future-proof, right? And what we're using here is nothing but broadcast channel API. So we're using a bus, and we are just having each one of the fragments listen to it. And this is how the fragments share state and how they share it also with the host. That's,
right.
Yeah.
Okay, so there's a single like or producer or set of services behind, and then
Yes.
like they all communicated with it. In this example, is this something that lives on something that lives on the client, or are you?
So right now it's implemented in userland.
Yeah.
We have a PR open for a while that we need to go back to make it part of the web fragments library itself. It's going to come really quick because it's one of the main concerns of folks, and it makes sense. State management can be pretty complex, but it doesn't have to be, right? And we're trying to simplify it. And this diagram shows exactly what's happening here. So we have the different contexts, and we're going to speak of context when we explain the virtualization of JavaScript in web fragments. But basically, they are all communicating by listening, subscribing, or posting to this channel.
Right. Once again, I jumped like straight down a very specific topic instead of like the more general question, which would be like what does this look like? How do you get a fragment on a page? But that makes So there's an event bus essentially, and you're actually that image is actually from the like post message kind of APIs stuff you find right in the browser.
Yeah, exactly.
So very cool.
So we get this question about sharing state a lot, and to the point where we build a slide about it, because there are things that are shared between fragments when they run on the client side, and there are things that are isolated. But in general, the mental model that we're trying to encourage people to follow is that sharing as little state on the client side as possible is actually a good thing, because the more sharing there is on the client side, the more coupling there is, which also means that if you want to develop your fragment in isolation, then you can't really, because now you need to recreate that state. So people often ask me, like, can I use a Redux store and reuse it from the host application, from the legacy application, and access it? And I was like, well, technically you could. Should you? No. Because as soon as you start doing that, you no longer can build those fragments in isolation. So you cannot just spin up vanilla Nuxt or Quick or Remix or whatever dev server and build the fragment in isolation. And I very strongly believe that it is super beneficial to be able to build these fragments in isolation, because then you can run end-to-end tests in isolation, which makes them less flaky. And it's like the entire state sharing problem just is minimized when only little state is shared. So what we do share is origin. So everything that runs in the client side runs on a single origin. There is no cross-origin anything unless you bring some third party something. DOM is shared, and we're going to look at the DOM tree. You might have seen a glance of it. Browser location and history are shared, because otherwise we wouldn't be able to do routing. So in the application that we showed you, there are actually 3 routers. In this application, we have 3 routers because the legacy application has a top-level router, and then there are 2 child routers, one in the Nuxt app and one in the Quick app. And these are just vanilla routers that come with those frameworks. You don't have to use a framework. You can use vanilla JavaScript if you want to. In fact, like I don't know. There might be some use cases where you use like PHP or Ruby on Rails to build your fragment, because for whether business reasons or technical reasons, that might be the right choice for you. And this is not coupled to any kind of like JavaScript framework, anything. It's really the APIs that we are targeting as the surface area that Web Fragments support is HTTP, HTML, JavaScript on the client side. So as long as you give us HTTP endpoint on the server side that is capable of sending HTML stream and is capable of providing static assets, that's all we need. And whatever is on the other side of that HTTP endpoint, we don't care. It can be C++ application.
Yeah, this is interesting. Like, there's this, like this state sharing concept or lack of is actually a really big shift or change, bigger than people might give credit for. First of all, the decoupling is important here, very, very, very important. But it's also like having everything basically like an event-based architecture makes a lot of sense, right? Like everything being driven off these kind of shared events. And it's what's interesting to me, like the thing that I tip off on when I hear that or that thinking is this is actually something that would be in common with, say, WebSocket solutions people have, and also local first with a lot of like those kind of like embedded database things. I mean, these are different technologies, but these are, again, things that work primarily on driving the UI frameworks from an event-based system. It's just something that I'm kind of like, I always look for similarities between these technology and what that means for the people who are actually developing these isolated front ends. Like, what does that look like? You know, I'm a JavaScript framework author as well. So like, I'm always thinking about the impact on what future JavaScript frameworks look like based on how the data gets into our app. And I think a fundamental piece that all these things we just talked about have in common is being driven by an event system. So just something.
Yeah, but you know, we actually have a demo of, so events are good for communication between fragments, but there's one issue with events, and this is why Natalia mentioned that there's a PR pending where we are thinking of even more advanced approach based on signals. Because the problem with events is that in an application where different parts can load at different times, there is no guarantee that when you send the event, the other party is ready to receive it. So we actually need persistent events of some kind. And signals are much better for modeling that, because what you ultimately want is not necessarily you don't necessarily want events. You want state that is reactive state that is shared between fragments, and that state is then persistent. So there's like a little more work to be done there, but these are like kind of like very advanced use cases that we don't need right now. But I think like these are solvable problems if people like you take a look at this and be like, oh, of course we could do this with signals. Like I nerd sniped Pavel Kozlovsky from the Angular team, and we built like Angular demo with Angular signals where the signals were shared between two fragments. So it's definitely possible.
Yeah. I mean, then it's stateful, so then you kind of go, am I entering the shared state problem again? But it's like, there are definitely boundaries, especially along the async boundaries of stuff inside and out. We actually had a lot of fun with this. Has it been almost a year? I had Dev Agro, solid core team on a thing, and he was working on putting signals on the server, for example. And this is kind of like a similar idea where you have this he has to branch the client server model with signals. I imagine the same kind of problems that exist there, where you're kind of like looking like, I don't want to say share the state exactly so that they're too coupled, but I want to be able to still provide some kind of guarantees on either side coming in. So like, definitely I've been working with people who've been kind of thinking about this signals across the boundaries kind of thinking. So yeah, very, very cool.
Yeah. So coming back to things that are shared, viewport sizing. One thing we didn't really show in this demo, but we can tweak it a little to show that, is that these fragments are not constrained. Like with the iframe, the iframe is constrained to the rectangle of the iframe unless you use JavaScript to resize the iframe dynamically, which is pain in the butt. You can really render things anywhere. We can actually, like, let me show you a quick demo. We generate this application. Natalia, you know more about this one. Describe it. What does it do?
It just calls a model to get a random slogan for a shirt in this e-commerce use case. So as you can see, if you could see the boundary of the fragment, it's just a button. It's not me, it's just a model, right? So if you could see it in a page, it would the boundary would be just a button, right? Can you close the model?
Yeah, but so this is AI generated. I know,
yes.
it's just so funny.
Yes, it's
okay, so this is the UI,
yes.
and when you
yes.
when you click that button, it shows the model dialog that overtakes
that
the whole
expands, right?
that
That's
expands.
not possible. That's not possible with iframe today, right? Or ever for the
Just
25, 30 years that it exists. But with web fragments, you can actually place that model anywhere in the screen and make it even full screen, full viewport.
Yeah, so let's add it here.
Yes.
So this is the standalone mode, which might not be clear. I'm switching tabs. So this is the standalone mode of this application. This is AI-generated application that uses AI to generate custom t-shirts. And let's incorporate it here. And I'm just going to add that button right here into this area.
That was a question earlier. Someone was like, was this app generated with Gemini or?
No, it's calling a local model because it's tiny. I don't even remember which one I use. You can check in the source code. I didn't want to make calls outside of to the cloud because we were showcasing this at a conference and I didn't want to have any internet issues.
So all I have to do is I already have this prepared. So there are two pieces to it.
Can you make a code a little bigger? Sorry,
yes, thank you for calling it out. So I'm gonna add this web fragment part here. So we are in the shopping cart template. We are in the legacy application that renders the shell, including the shell that contains the container for the cart. And in that, I'm just going to add this web fragment element that has some ID and some SRC. And then there's a second part to it, which is
the registration and the gateway.
Yeah, which is this part. So it's already added here. So one thing we didn't talk about is that on the server side, in order to get started with this, like what we did to modernize the legacy application was two things. We added a middleware in front of the legacy application. There's setting dot. Oops. Here. And this is an Express application, and we just added this middleware. This is Node middleware that comes from Web Fragments. It's part of Web Fragments, and you need to configure that middleware with what we call a gateway. And the gateway is basically a server-side like middleware router that just knows about all of the fragments and how to route requests that this middleware is receiving and send them to different endpoints. There's a little bit of CSS, which we can talk about later, but the point is here are different fragments that are registered. So the gateway knows about, there's a store fragment, there's some CSS classes that are attached, but this is a crucial piece. So there's this route patterns, which means anytime the gateway intercepts a request that starts with /store/something or /_fragment/next/something, then it's going to route that request to the endpoint that is defined here. In this case, it's this localhost 4174, which is the standalone version of the application that I showed you in the tab. And we do this for every fragment. So every fragment has this kind of registration. And the three crucial parts are the ID, the patterns that need to be routed, and the endpoint definition, where to route them to. So I think you're going to get a
Actually, the piercing classes are also important in the context of that trick that Igor showed you, where the application renders exactly where it should be. That's because we are defining those rules in that pre-piercing.
Yeah. So we have this here, and now I should be able to switch back to. Sorry, this is a little clunky, so I apologize. But I should be able to switch back to the browser. And if I reload, we now have the button here. So the button exists, and when we click on it, we see the full page overlay over the legacy application on all the other fragments. So this is the part that is very difficult to do with iframes, because you just can't overlay something. Like iframe is not transparent. Even if you can resize it, you will never make this this effect with iframes. And yeah, it's fully functional application. I'm curious what it's going to say for Tanner. What an idiot. Okay. Yeah, so we can add things to the card and close this. It should be, yeah, we have the thing. Like, and again, we use the broadcast channel to add things to the card from the model dialog. So yeah, there's like more interactivity cross fragments. And yeah, you saw it took very little to add this button. We generated the app, we configured the gateway with the new fragment, and we dropped the web fragment element into the right place of the host application where that fragment should be rendered. So if we look on the DOM, we'll see that we are somewhere in, yeah, we are in this aside, which is card side, and like if we went back to the template, you would see that this is exactly the place in the template where we dropped that element. Now, let's take a look at this, because I'm sure you have questions here.
It's an actual, okay, I mean, this is an actual web component. I see the shadow roots. You're actually using the shadow DOM to isolate.
Yes.
So we mentioned that, yeah, we isolate CSS and JavaScript. Isolation of CSS, evidently with shadow root, and we don't have to worry about pollution or contamination of CSS from one fragment to another. And then the virtualization of JavaScript. Let's dive into that, Igor.
But how do you share the DOM?
How do you share the DOM? Yeah, how do you share the DOM? Like, that's a loaded question. What do you mean by that? Let's step back just a little.
Well, I mean, you had it back on your slide, right? It's you're sharing the DOM. Okay, you're sharing the DOM space. You're layering modals over other things, right? I think that's one of the most unique and coolest things about this approach is that you have isolated JavaScript environments.
Yes. So if we scroll,
virtualization, right? But they're sharing the same like physical space.
Yeah. So if we scroll down into this application, and we will see that this is not a good script to look at. Let's take a look at this script. This is a good script to take a look at. So
Nux config right in there.
Yeah. So take a look. So we are in this is single DOM document that has this web fragment right here that then contains shadow root boundary, that then contains web fragment host, and then another shadow root boundary. And we can discuss why we need two. But then it contains something that looks a lot like HTML document. So we had to prefix things with WF dash, because you can only have one HTML element in a document.
Yeah.
Otherwise, things would break. But let me show you something that's going to surprise you. So you think that this is WF HTML. What do you think is going to happen if I do tag name? Oh, you can see it already. Yeah, it's going to say
it's
that
an actual HTML element. Yeah.
Yeah, it's an actual HTML element. And in fact, if I do query selector all and look for HTML element, it's going to return the query selector all is going to return this HTML element. So the fact that you see the WF dash here is because you see what the browser sees and not what the application sees. And I wish I could do this. Like I could even trick the dev tools, but maybe I need to talk to Adi Osmani or somebody to help me with that. But this is where like the illusion, like we are really creating an illusion. Like we could say that web fragments is really like one big illusion. We're building an illusion that this application is running in the mainframe, and this DOM tree is really a standalone document. And the illusion is good enough that we trick the application running in this fragment into believing that. So when you use DevTools, you see what the browser sees, and the browser sees the real thing. It sees like, oh, there's this DOM tree with a legacy application and shadow roots, and then it sees these WF prefixed elements. But let's go into the script tag, because I think that's where things are going to get interesting. So you see this script tag here, right? Now, the script tag is trying to assign window.next an empty object. So obviously, if I do window.next I should get the empty object, but I don't. That's surprising, right? Because you look at this, and if you know how DOM and JavaScript works, there's nothing that says that this script should not execute. It says like this looks like a normal script that should execute and should execute in the top context. The fact that we have shadow root here doesn't change the fact that we are executing in the top context, because web components and shadow root doesn't do any kind of JavaScript isolation. So this is where reframing comes in play. And reframing is the virtualization technology that powers web fragments. And what we do is this script here doesn't actually execute. There is a different replica of this script that executes. And that one is down here in this hidden iframe. So if we look, we were looking at, I think it was the button. If I look down here.
How did you make the script tag inert, though, to not run in the other context?
Okay, let me just finish this, and then I'll come back to your question. So we see this tag, right? Like this is the script that is executing. It's in an iframe that is hidden, that has the name of the fragment. And using normal dev tools, we don't even have special dev tools, because really like all of the stuff that we are doing is based on standards and browser APIs. I can switch contexts to this fragment. So we call the fragment WF slogan. That's what the name is. And I can go here, and I can call window.next, and this is where the object is.
Drum roll.
So yeah, drum roll. It shows a bunch of proxy stuff. This is not a proxy. It must come from Next. This is literally the raw thing that comes from Next. And I didn't realize that Next was. I guess for reactivity they're using proxies everywhere. So that would make sense. Yeah. But I can do the same thing with all the other ones. If I can go to card and and I should be able to do like window. I think there's like quick events is one of the globals.
We all do this. I remember on an early version you were like, Ryan, can you make it not thrash on top of itself? And I'm like, yeah, eventually I'll figure out a way not to thrash it. Now I don't have to worry about this, right? Like it literally just works in its own context.
Exactly.
That's awesome.
So yeah, and this works for Solid as well. So let's talk about like what's going on here. So we have this.
Igor, if these scripts are executing in this iframe, how are they manipulating the DOM?
Yeah, that's a good question, right? Because like this script somewhere at some point is going to do like window on the document.create element and append child, and we'll just.
Sorry, I know all the questions to ask. So.
Yeah. So so right now I'm in the card. That's fine. We can be in the card, and I can do document.body, and what I'm getting is quick fragment as the body, which is kind of surprising. But let's find that fragment. So it's here. This is the fragment. This is fragment host, show the document, and document then contains top-level element is quick fragment. So this is one. The quick application doesn't actually render body. It just renders the top-level element is this. So that's why we return body. But if we switch to the slogan, let's do the store, and do body, then let's unroll this. It's this element. So if I highlight it here and do triple window, oh, because I'm in different context, store. True. So what is happening? I'm in the store fragment, and if I check what is the document body, I'm getting this element. And if I do document, let's say in this do child document dot create element, and let's do div. Oops. If I scroll down, there is my div that I just created. So the key thing here is that even though I'm generating, I'm running the application in the iframe, the iframe was heavily monkey patched so that any kind of DOM operation that is executed in the iframe is actually happening in the main document, but it's scoped to this WF document and shadow root. So if you do query selector all, if you do append child, if you do any kind of DOM operation, those DOM operations work just fine, but don't happen in the iframe. They happen in the main document, scoped to the area of the document where the fragment is placed. And this is how we can fool the application into doing all of its regular DOM manipulation that it would. But the DOM manipulation is happening in a single document, but it's encapsulated by the shadow root. So any style sheets don't leak out or don't leak in from the host application. Any IDs are isolated. Any events are actually very, very interesting. Like I had to really think super hard about how to handle events, but even event propagation works exactly how you would expect. And there's no difference between standalone execution of event propagation and this embedded mode, both in the capture and bubble phase. So like everything just works exactly how you would expect. So really, like we're creating this illusion, and that illusion is so good that very complex applications now run in this environment without knowing that they are in a container. They believe that they are running in the top frame, but they're really in a container.
Yeah, I mean, if they think that's their owning document, then I mean, I know there's a lot more details on that, but that, like, as a core, like, basic concept, I mean, that would do most things. Like
that's the virtualization, right? I love the parallel that I love that parallel with Docker, but that is the virtualization mechanic at work right there. That you're proxying all this stuff. So actually, somebody had a good question that might might stretch the rules a little bit, but somebody said, can you escape with document.parent element?
Document.parent element.
Like if you're in one of those lower frames.
Okay, so let's do it. Let's go to cart. Which one do I have open?
Parent is the shadow root, right?
Cart
document would still give you the WF document tag.
Here,
right?
let's go to this teleport. Let's go one deeper. So let's go to this one, and we are in the store. So let's switch over to store. And what was it? Do dot parent element. So you get the Nux, right? That's what you expect.
No, but like
If
Document.
you did, if inside of here you just did document,
Oh,
just document dot parent element. Does the document actually have a parent element itself?
Yeah. Document dot. No, because document doesn't have parent element.
Gotcha. So,
But you can do something like owning owner. Is it owner document,
Owner
and
document.
that returns the document. So there is a document object that also exists. That is part of that comes from the iframe, but that document object is also heavily monkey patched, so that any kind of API you call on it will be virtualized into that shadow root. So if I do body, that's how that works.
I'm actually curious as how much work has been going into. Oh, we tried to run this thing, and we found something that needs to be, that we weren't monkey patching. Like, has that been a long journey? And like, what would you say the progress of that journey is?
Yes and no. It's actually like it was surprisingly fast. Like when I first built the first demo of reframing, the first version of reframing, I built in 2022, and my goal was to just get vanilla JavaScript running in this way. And of course it didn't. So I had to like, okay, what does it take to monkey patch this world to get some like hello world running? And it wasn't that much work. I was like, okay, how far can I get? So then I took a React application and found a bunch of bugs and fixed those. And then I took a Solid application, found a bunch of bugs, and found bugs in Solid and reported them to Ryan, and he fixed those. Then we tried Quick, and we tried all of the mainstream frameworks out there, and little by little we like expanded the surface area that was patched in the correct way, and eventually we built a test suite that compares the native behavior of the browser to this virtualized behavior of web fragments, and makes sure that they are they're exactly the same. Like you can't tell the difference. There were moments where there were things that cannot be monkey patched in the browser. It's rare, but it does happen. So for example, location, window.location is a non-configurable property. And that's kind of a deal breaker, because if location in the iframe is different than the location in the top frame, then you cannot have unified routing. But we were able to find a workaround for that. So we actually are okay with running two locations, and we just keep them in sync through pop state and replace state and like all of the normal things. So when something happens in the top frame, we replay the operation in the iframe. If something happens in the iframe, we replay the same operation in the top frame.
Interesting. So you mirror, you can resort to mirroring in the cases where you can't actually share or monkey patch, I guess.
Yeah. So like little by little since 2022, and it's like this has not been my full-time project until summer last year, when I like started heavily working on this, because we started using it at Cloudflare. Little by little, like we just got bigger and bigger applications running. And if you let's take a look. Let me show you something. So Cloudflare actually has. Let me show you how we use this at Cloudflare. And this here is Cloudflare dashboard. So if you go to -cloudflare.com, this is what you will see. I'm just using one of my accounts, and this application is very slow to load. And I'm on a 2 gig internet connection, so it took only 5 seconds. If you're a normal human, then it's going to take like 10 to 20 seconds. If you're on an airplane, good luck to you. You're not going to have a good time. But so this is the application we are replacing. It's massive SPA built with React. Started 8 years ago. Everybody from the company is contributing to it. And one thing we're doing is we started with something very low risk, and we rewrote this part as a separate fragment. So this part, the user preferences, we rebuilt that as a separate application. So you can see that it's deployed on URL that is not production URL, but this is where the application actually lives. And it's fully standalone application. I can change things. And if I go back, I should see that those two things are now connected. I don't like emails. I don't need more emails. Let me just reload, and you see that the state disappeared because it's talking to the same backend. This is the standalone version, and this is the virtualized version within the dashboard. And best of all, if I go here and reload this application, you'll see this piercing effect. You see that that actually broke really bad. I don't know what happened there. Oh, I know. There's one bug that is pending that I'm fixing right now, and that's why this broke. So let me. I'm also on a preview version, so there's like a whole bunch of stuff that. Okay, I'm on a preview version. Let me exit this. And we're going to have a much better time. Okay, so this is the production version. So if I reload, you see the fragment instantly loading, and then we added skeleton here and a kind of like temporary shell that is displayed while the legacy application is starting. And then once the legacy application is started, we strip the skeleton and replace it with the legacy application. And then this the fragment is then placed into the DOM tree in that exact location. In the meantime, it's been held in place using temporary style sheets. So this effect of this being placed here is because there is a set of temporary style sheets that position the element exactly where it's going to be once the legacy application is started. And once it's there, once the legacy application starts, we do a DOM move operation into that location and strip the temporary style sheets. And we do it in a way where state is preserved. So if I do text select text, text selection stays preserved. If I start typing into some input box, all of that state gets preserved. Because DOM operations are destructive, the state is erased. So we actually like capture the state before the move and then restore it after the move.
Nice.
The atomic DOM move API that came to Chrome is helping a lot. Surprisingly, it's not good enough, and I need to talk to the Chrome team about it because things like style sheets get reevaluated. I think it's style sheets. Style sheets get reevaluated and causes flash of unstyled content. So there's still like a little bit of shenanigans that we have to do even with atomic DOM move operation. So the main thing I wanted to show you is that how far this scales is that Cloudflare actually has two dashboards. So this is the main dashboard with all of the services that we have, except for what we call Zero Trust Business. And Zero Trust Business has its own separate dashboard that looks a lot like it, but it's deployed on a separate domain. It's a separate SPA that started as a fork of the main dashboard 5 years ago, but since then completely diverged. It's built by a different team. This dashboard is, I think, 300 routes. So it's not a small application, and it's still only 1/3 of the main dashboard, roughly speaking. So what we have tried, one trouble with having two dashboards is that customers often get confused about where they are and how they navigate between the two, because their user journeys often span both dashboards, and they get lost between the two SPAs. And when they do realize that they need to hit this back button, this is the experience they get because we need to bootstrap. And again, like imagine I'm on a super fast connection, very fast computer. This takes much longer for normal humans. So what if we could go to Zero Trust? What if we could go to, let me just navigate there, to this dashboard. And what if we strip the header, the navigation, and this footer, and preserve just the content with all of the routing and wrapped it into a web fragment? And then took that web fragment and nested it into the first dashboard. That would be crazy, right? So I ran this experiment at the beginning of the summer, and I realized that it actually works now. Like we had such a good emulation, like virtualization is so good, and the capabilities of the framework are so good that we can do it. So let me just make sure that I have the right cookies set. So I'm going to reload this with a preview URL that I have here. And if I go down here, now this is a menu that is available only for me because I'm on a special preview build. But I can click here, and we're now loading that second dashboard, the application with 300 routes, as a web fragment nested into the original, the main dashboard that we have that is very big. And so we have two massive SPAs running side by side, not even knowing about each other, but things just work. And what is crazy is that if I do a reload, the piercing works as well, but it's the client-side version of it. And you see, like the two applications are racing to see which one's going to render first. We are thinking of like, should we be able to control the order between them and prioritize one over another? There are like interesting, like this is a completely uncharted territory. Like nobody has ever done stuff like this. So there's like a lot of experimentation. Like what is the right user pattern? What is the right user experience to do?
The funny thing is actually there's a lot of similarities between this and suspense and suspense list. There's actually React started doing some experiments around how they could control the ordering of like different suspense boundaries loading in, like forward, backwards, reverse. They had a few things. The funny thing is still under experimental. I agree. This is an area that's like the idea of like coordinating these different zones of streaming in terms of an app. And is there like a correct answer? Because something's going to suffer in some case, right? Like something's going to load slower than it could, or something is like. And the perception has so much of a big part about this because it like what's in front of you, like where it sits on the screen. Like there's not a single one size fits all. So making it configurable is like really interesting challenge.
Yeah. So we don't know. I think we're gonna make things configurable and just see, in the real world, what is the right what works, and it also might depend on the concrete scenario and concrete application that you're loading. Like I don't think there's one right solution. So we'll see. One thing I don't think I can show you just yet because it's still like I think we are just finishing the demo for Monday. Is that, as I mentioned, we have this massive SPA. Let me go here. So this is the production. Oh, go away. We are rebuilding this SPA, and we have several fragments that we have built, just like the profile fragment that I showed you. But we want to shift to different migration strategy now that we have proven that this seems to have legs. We actually want to rebuild the shell of the application using brand new stack. So do server-side rendering for the shell. And just like we took the Zero Trust dashboard, the secondary dashboard, take the main dashboard, strip the header, navigation, and the footer, wrap it into a fragment, and load that into the new shell. And so that's what we're working on right now. And the team just showed me a demo where the first step on this journey is taking this main dashboard and making the rendering of the header, navigation, and the footer conditional, such that we can wrap the dashboard in the web fragment and drop it back into the main dashboard. So visually, it looks like the original application, but now we have two instances of the application running in the same window. One instance is providing the shell, and one is providing the content. And that then allows us to verify that the content works well, and it's like an incremental step towards replacing the shell completely. And we have that working now. Maybe the team is going to send me a URL to show. I don't have the URL handy, but yeah, if somebody from the team is listening and wants to send me a URL, I'm going
to there are some people in chat that have, at least one person who's been answering questions, which has been very helpful, although I do want to bring a couple of them on the stream so that people watching the stream can actually get the answer to a couple of these questions too.
Yeah, sure.
But yeah, no, this is, I mean, before I go to that, just because what you just said, I mean, there was I think someone was joking about how many micro front ends on a page is too many. But like I guess one of the questions about when you first thing came to mind when you're like, I'm loading the same app twice on the screen. I'm just like, I started thinking about like the semi-large, decently large apps and like bandwidth and all that stuff. I mean, I guess the reality is the migration story is the most important thing here, because this is a temporary state, not the eventual state. But like, I mean,
but one thing that I do want to point out is that because it's the same application being loaded twice, we benefit from the shared HTTP cache. So you actually don't download JavaScript twice, because browser will dedupe those requests.
Beautiful.
And you end up downloading things once. This is also interesting for, like, often people asking like, okay, will I download React 17 times if I have 17 fragments? And my answer is, well, maybe don't use React, but if you have to, if you have to, you can externalize it, because React is not tree shakeable. So there is no benefit of bundling it into the application. So you can make it external dependency, and you can guarantee, you can make sure that the URL is unique and shared across all of the fragments. And then you download it just once, but you do instantiate it multiple times, because React has an internal state, and we do want to isolate that state. So you can download once, you amortize the cost of the payload size download, but when it comes to the actual virtualization and isolation, we do want to bootstrap React multiple times, once for each fragment.
Yeah.
So cool.
I mean, okay, this was a bit earlier in the stream, but there's like, does the standalone app come with that extra top and left spacing to account for the main app now? Because like, this is back when you were trying to show the standalone getting injected in. And actually, I think we got an answer for that one. Extra top and left spacing is injected during SSR based on a request header. It's this part. So at Cloudflare, like, we don't have it in this application. Like you see that this application takes up the field viewport. But at Cloudflare, as we are building things, we thought that it would be actually good to position the fragment, even during development, the way it's going to be in production. So we have this temporary shell that we are rendering in standalone mode automatically based on some headers. So we can position the fragment where it's going to be in production. Yeah, no, that's cool. I can see that using a lot of like I figured, like, I was looking for stuff on the URL this whole time, but yeah, of course, and headers is easy because like standalone mode will act like the default way, and then like you have some more control when you're actually like injecting the fragment in terms of setting headers and stuff. So that's cool. What else do we got here? Okay, a bunch of people talking about the dashboard and the use effect thing. We covered that at the beginning of the stream, and. What else we got here? I saw another question. No, they're still talking about the data fetching library with use effect. Okay, no, I mean, I think that was that one.
Yes, somebody keeps bringing it up. How do you not run the scripts?
Yes.
I was going to go back.
That was my question before.
Yeah.
So I think we were here.
Sorry, did I see the solid Spearsky triangle concurrent rendering demo?
Yes, you did.
Now I nerd sniped you. Okay, so let's finish this. So this is Ryan's your thing that I'm using at conferences now, because people often wonder about the overhead of the virtualization. Like every time you hear virtualization, people are like, oh, slow, not really production. Like it's going to come with a big overhead. So I thought, like, what is the craziest thing that I could run in a web fragment to really stress test it? To see like what is the overhead of all the monkey patching we are doing and all the virtualization.
This has a artificial delay in it, so it's like it's made to be even slower, which makes it brutal. Yeah.
Okay, so I took this is basically your code just redeployed on my account or our account, and I then configured the application, this enterprise application, to include it. And I'll just make the code change. I'm not going to switch because it's very disruptive when I switch screens between windows. I'll make the change and reload the window, and it should render at the bottom here. Here, so it's rendering here, and intentional. Like the UI is messed up, but that's kind of intentional because I do want to show that you can really layer the different fragments in whatever way you want. You are in charge. You can just use CSS to say like the triangle should be at the top or at the bottom. Like, I don't care. It's totally up to you. And when you compare the performance of this versus this, and I don't know if I can, let's see if I can make it a little more. It's the same. Like you cannot, like I even run it in Profiler, and the Profiler didn't show anything like statistically significant in terms of the difference. If you really know what to look for, like you will find some frames. But the point I'm trying to make is that the monkey patching we're doing is super lightweight and very intentionally lightweight, so that we are not introducing performance overhead to the application.
Yeah, this demo is one that was designed to try and push past what the browser can handle, and then try and make scheduling make up for it. So this demo should be just like eating the CPU. So like
negligible in the context of Fragments.
Right. Cool. So should we answer the big question, like what's up with the script?
Yes.
Now that we finally can get to it. Okay, so if you read the HTML, it's DOM spec. If you read the DOM spec, there's this interesting clause in the DOM spec that says that there's an internal slot for the script element that determines if a script executed already or not. And this slot is used to make sure that a script that executed once doesn't re-execute if you move elements around. And we take advantage of that little dumb thing. So what we do is we create a script tag that we execute while it's empty without src being set. The internal state of the element is set to execute it, and then we set the src so that it looks like script with external source, and then we append it to the right place in the document, so then it looks like, oh, here it is. And the reason why we do this is really React hydration and all of the frameworks that have indices that expect DOM elements to be in certain place. So it's important to preserve this behavior and the shape of the DOM tree, even though the script is actually executed somewhere else. So
let me rephrase that. You execute an empty script that does nothing, and then you masquerade. You make that script masquerade as the one that's going to run.
Not quite. So I take an empty script, I execute it as empty script, and then I set src on that script and append it to the place in the DOM where the application expects it. But by then the src takes no effect, and the script is just sitting there already executed as empty script. But to framework or developer, it looks like external script.
Yeah. I guess it could have stayed as the empty script, because usually we just count by. Oh no, I guess that was a React. Actually, yeah. They'll look at the attributes. Yeah, they'll look at the attributes. Yeah.
So let me let's find the source code of this.
Yeah. So I was thinking like it's more for just it's more just to satisfy.
Yeah,
people looking at DOM or hydration things that are looking at like the actual DOM.
Yeah. So what I actually like, there's this mini library within Web Fragments, the client side side of Web Fragments. We call it reframed because it's using iframes but kind of reframing what is happening in the iframe. I saw, was it Ryan Florence, who now started calling their thing frames, and somebody suggested that it should be reframe. I was like, don't use reframe, it's already used, it's ours. So in this library, originally, I built it as a standalone library, but actually realized that it's almost impossible to reuse it without a bunch of other stuff that Web Fragments give you. So then I just inlined it into Web Fragments. but the original intention was to make it external library. So if we look, there's this script execution and make element inert. And so there's actually, like, depending on, and we haven't really talked about this, there's a difference in how the application executes when you do hard reload versus when a fragment loads using soft navigation. Because during hard reload, all of the body is nested into the initial HTML payload that's coming from the legacy application. And during soft navigation, we are just getting HTML stream directly from the fragment endpoint that we need to stream into a DOM container, if that makes sense. And I actually use a piece of Marco for this. There's a library called Variable DOM by Dylan Piercy. And we use Variable DOM, and kudos to Dylan, because if you look at the Variable DOM as a library, it blew my mind when I saw it and how it works. But the thing that I want to show you is, so one of the techniques is if script type is set to, so the first thing is, let me actually, sorry, I need to step back because this is not going to make sense otherwise. Let's look at the payload of this application. And let's look at the network panel. I'm going to refresh. And I care about the initial payload response. And can I go up? Come on, show me more. Oh, dev tools, come on. Oh, really? Okay, sorry, I don't know how to make this any bigger. I don't know why. That's annoying. Okay, so this is the initial payload if I do hard reload. And if you inspect the initial payload, there's an HTML that comes from the legacy application. This is the index.html of the client-side rendered SPA. And we scroll down, and down here we see the body, which also comes from the legacy application. And then we see web fragment host that contains declarative shadow root, that then contains WF document, WF element, HTML head, and all of the things that that you get from the actual endpoint, the fragment endpoint, but prefixed with WF. This is an extra element that I had to add to make events capture and bubble properly. But everything below that is really the original stream from the fragment, but a few elements were prefixed with WF. And then the elements themselves, when initialized, were monkey patched so that if you do tag name or query select all, you can still look them up the way you expect. So if you look down here, let's find some script tags. So this is server-side rendered. That's why it's inline. So this is how we instantly can show the server-side rendered stuff. If you scroll down, come on, there must be somewhere script.
Hey, I'm going to interrupt really quick and say goodbye. Unfortunately, I have to run to my next thing.
Sounds good.
But I'm really glad that I was able to hang out with you guys and
thank you.
cheerlead this awesome tech. When Igor showed this to me, it was reframed and it was separate, and it was like a year ago, and we were geeking out over it at React Summit or something like that. But anyway, it's awesome to see how far it's come. But I got to take off. Thanks for having me.
Thanks for being here.
Thanks
Tanner.
for joining us. So what you see here is that when the stream comes from in the initial payload, the type is actually set to inert, because at this point there's nothing of web fragments that has monkey patched anything yet, and this script would be fetched and executed. So part of the middleware is this very lightweight rewrite that identifies all of the scripts and changes the type to be inert, and stores the original type in this extra attribute. And once the web container it's bootstrapping, it knows how to set this, restore this to the right type, and using this value. And by then, this script is already marked as executed, because even if the type is inert, the internal slot is set to executed. So by changing the type, nothing executes anymore. So that's one way. But then there's this other scenario, and I think it's easier to show it in this. If I go here, let me go here, and the second scenario is if you do soft navigation. So let's go to network, and I'm going to click here to open up the preferences. And in this case, we did soft navigation. And we'll see that there are two requests that were made by Web Fragment to the server. One is the response request headers. Where are request headers? Request headers. Sec fetch. I don't know why.
The
I don't
request
see.
above.
Oh, because it was cached. This is already coming from cache. I think if I disabled the cache, then let's disable the cache. So there's a special header the browser automatically sends if the request is coming from iframe versus document. It's called secfetchdest. And secfetchdest is one of the headers that we heavily use. Oh my gosh, now you see how long it's taking to load. If I throttle it to slow 4G and disable the cache, it's like, oh my gosh. But the fragment is loaded already, and it should be interactive. I should be able to switch. See, I'm able to switch between them. So if you're on an airplane, this stuff actually works. You can interact with the main content of the application, even though the legacy is still pulling additional 5 megabytes of JavaScript. It's a little bit janky right now, but let me unthrottle this just so that we don't delay things more. Go back, go here, and let's look at these two requests. Okay, now they were not cached. Perfect. So let me make this bigger. Oops. And if you look at the request headers, there is secfetchdest that says iframe. So in the middleware, now I can tell that, oh, this request to this URL was made by the iframe, and I'm able to send a response. And what we send back is minimal valid HTML. And the reason why we do this is because we need the iframe to be initialized at the very same location as the host application, so that the initial state of window the location is exactly the same, and the iframe is the same origin iframe. And once it's initialized, then we can use the events and pop state and push state to keep the two in sync. So this is little implementation detail to make the window location work. But once this request is cached, you don't need to make it to the server anymore. The second request, the same URL, has different secfetchdest. So if you check, its secfetchdest is empty, which means it was a fetch request. So we used fetch to call this URL.
Yeah.
And the gateway intercepted it and see oh, you're trying to get the HTML stream from the fragment. Let me just proxy and send the request to the actual endpoint of that application, which is this. So if I navigate here, and this produces some HTML, initial HTML. So if we look here and compare this HTML stream, if you compare this HTML stream, so it starts with some HTML and a bunch of preloads, to this one, you see that it's exactly the same, except HTML is now prefixed with WF. Everything else is the same. And script tags, let's find some script tags. Script tags. So script tags are not made inert in this case, because what we receive back in fetch is HTTP stream that we send to writable DOM, and writable DOM in a streaming way will start pumping out elements, and I'm able to intercept the creation of the elements before they append it to the document, and I'm able to do the trick to like make the script tag inert.
Yeah.
So the cool thing about this and the use of writable DOM in this case is that anything in Web Fragments is fully streaming enabled, and that was like one of the key requirements, because with different loaders and all these other patterns, it's absolutely critical that there's no piece in the stack that buffers or does anything crazy that would like prevent streaming from happening. So even the HTML rewrites are happening through HTML Rewriter, which is a Cloudflare library that allows you to do stream-based HTML rewrites. So everything throughout in any kind of scenario is streaming enabled.
Okay, yeah, because I was thinking, I mean, that's obviously why like streaming was very important at eBay, and why Dylan did so much work on building the streaming core stuff. Yeah. But we hit a blocker when we were building our iframe. We were doing something I said kind of similar, and it was at the time that we couldn't stream the declarative shadow DOM. I guess that was like I think that got unlocked about 2 years ago, but
so we lucked out, because by the time we needed declarative shadow DOM, it was just baselined by like a month. So like we were like, the moment when it was like, oh, declarative shadow DOM, is that something we can use now? And I checked the MDN docs, and it was like baselined a month ago. I was like, we're using that. And it just worked beautifully. Like when I showed Mishko Hevery from Angular and Quick, like declarative shadow DOM and how we use shadow DOM and web components, is like, oh my gosh, this is the first valid use case of web components that I can think of. Like the totally like for encapsulation, it works out of the box, and we just need to add the JavaScript encapsulation with the reframed library. And that was it.
No, that was funny. It was actually kind of the same thing, because we had a very similar debate internally at the Marco team, because like Dylan was like, well, because they're trying to sell us on web components, and then Dylan's like, I think I found a usage. But then we got stuck.
This is a perfect use case for web components. Like I think there's like a lot of misconceptions about what web components are good for and what they're not good for. And some people say that they're completely useless. I don't think they're completely useless. I don't think they're as useful as what they were initially hyped to be. So I don't see them ever becoming a mainstream thing, at least not for the foreseeable future, unless other things in the browser change. But for this kind of like niche use cases, amazing API. I really love it.
Yeah, no, it works great. I got a couple questions I just want to kind of throw out here. I mean, everyone, my chat, they like poking holes in things like all day.
Yeah, that's why I'm here. Like that's what we are here, because we want you to poke holes, and we want to like. There are things. Okay, I'm gonna seed one thing. We solved out of order streaming. Let's just leave it at that, and we'll come back to it later.
Okay.
Let's tackle your question.
A couple questions for how would document.current script work? Because I guess this is clearly about the way the script execution stuff is happening.
Yeah, it's monkey patched. It returns the right value.
Right, because the script that's actually running is the one that's running in the iframe. So like I imagine within that zone, you can keep the rules. Like the one that runs inert will never actually run, so it doesn't matter, right? So like.
The one that is inert doesn't matter. But what we do is we actually point. So if you do document.current script, we point to the inert script to completely fool you.
That's awesome. How does the web accessibility tree look like? That was another question here. Can I put these on?
There's like the current script is one of the things that we patch. So web accessibility tree. What exactly would you like to know?
Yeah, I mean, they asked this about 10 minutes ago, so I'm not sure if they're around. They were just wondering. I think that it was when you were looking at all the WF elements, but I mean, they're thinking about if this would have impact on accessibility. I mean, the DOM with itself within its localized scope works perfectly fine. I imagine with the way you patch it. I guess I'm trying to think of.
It's valid HTML, so there are no accessibility issues unless you cause them in your fragments,
So,
like I don't know, keyboard trap or whatever, maybe. But
these elements are valid HTML elements that are custom, unregistered, or I forget what is the name of the state where there's no registration. So the screen readers will just ignore them, but then we'll look inside of them and we'll see all of the proper semantically structured HTML.
Right.
And because the web fragment is nested in the right place in the host application, the accessibility story is actually way better. Like it's a proper accessibility story because the accessibility tree correctly reflects the application tree.
Yeah, right. I was trying to think of it. Is it HTML unknown element or something? It's something like that. It's like what is this? Yeah. Okay, that makes a lot of sense. What else do I got here? Sorry, I'm glad I can put the questions on. Before when we had 4 of us, they kept on blocking Natalia's head, and I was like, felt really bad putting the chat on the screen. But we're good now. Is it safe to share your Cloudflare request headers? I don't. What is that?
I don't understand the question.
I don't understand either. Sorry, that was weird. It was at the point when we were talking about the other header stuff. I guess I just kind of got tied in.
Maybe the better token you were disclosing, like that's short-lived. I guess I don't know what they're.
I showed. So one thing I showed, like I quickly scrolled through cookies. And there might have been like auth token.
Right. Which
cut off.
Which reminds me, I think there was a question way earlier. Someone was asking, they're like, "What's the auth story here?" But I don't know if there's anything specific in terms of auth. But that was a question from a little while ago.
I logged out. Now we are safe.
Yeah, it's gone. It's dead. So we have it. I mean, at Cloudflare, they obviously have an auth story, but we have it pending to release a sample where we show how we do it, and folks can take a look at it.
Yeah, I mean, as long as you can establish the patterns around communication, I think that everything should work out fine. All right. Nice.
There was a question on what is the auth story. Because we have a single origin or same origin, the host application is in charge of or some other application is in charge of setting the auth cookies, and those cookies are then shared across all the fragments. So when the fragments make requests, those cookies are automatically attached to all the requests, and you can then use them for authentication and authorization.
Nice. He was showing no. Yeah, so I'm just caught up on chat. Sorry, we went for a little stint for there. What happens if different servers on the fragment have different content currents? I guess this was a follow-up question. Did we just answer that? We have different content security policy over
different servers. Oh yeah, that's actually a good question. So as of version 0.8, which we released a few weeks ago, you can have per fragment CSP policy. So each fragment can define its own CSP policy. But there's a caveat, because CSP policy spans both JavaScript execution and DOM fetching. Because you have single DOM, the CSP policy of the host application applies to like downloading images and fonts and whatnot. Not really scripts, because we don't download scripts from the main content, main context because of the reframing. But any kind of like script execution is guarded by the fragment-specific CSP policy. So you can set that.
Makes sense. Are local storage and session storage isolated? So I guess they're just wondering about like some of the other like on the window APIs.
Natalia, I've been talking so much. So do you want to take that one?
No, go ahead. It's like 10 p.m. here.
It's the same because it's the same origin. So those storage solutions, just like cookies, are associated with origin, and because it's same origin, you can. So that's one way to share state if you really want to.
Right.
Again, be careful when you're sharing state between fragments because of the breakage of encapsulation and start coupling things.
Okay. I think we caught up on the questions, which is sweet. You wanted to say something about out of order streaming?
I knew that we would come back to that. Yeah, so this is not implemented yet, but I would like to start working on this later this year. So because the one interesting challenge we have with piercing and how piercing works is that the initial HTML is inlined in the initial request. So if we look here and do hard reload, what happens here? Let me try to make this a little bit bigger. I don't know if I don't know how to unbig there. Overview. Okay, that's a little bit better. Screenshots. Okay. Here, now I can make it bigger. So because the initial HTML payload contains a combination of the legacy HTML, few things that were injected by the gateway, like these temporary style sheets, and then the host itself. This connection remains open for as long as this host is streaming. So if we have the store fragment using different loaders, it will start generating all of this HTML. We'll send all of this HTML down the pipe, and at the very end, we'll start adding script tags for the different loaders. And it can keep the connection open for as long as it needs until it fetches like all the different loaders are done, are still loading. The problem is that we are now blocking the connection, right? Because this cannot render. Anything below this cannot render until anything after the fragment. If there's anything, I think in this case, yeah, there's nothing. So, but if I wanted to render two fragments, one after another, the first one would block the server-side rendering with different loader would block the rendering of the second one. Okay. Because we cannot stop streaming this and start streaming the other one until the first stream is completely exhausted. So we've been thinking about this with Natalia, and we think we have a solution. And the solution comes down to what if instead of waiting in the gateway, in this middleware, for the fragment stream to be completely exhausted, what if we just took whatever is readily available in like the first chunk, flushed it down to the client, and then made a marker saying like there's going to be more content here, but we don't have it. We are waiting for the stream. And we could then start streaming the next fragment and the next fragment and so on. We would, on the server side, we would still have all of these connections open because we're waiting for the different loaders to resolve. And once they do resolve, we would like to send the additional payload back to the client, but do it in a non-blocking way and append the new content to the right place. So what if we just build this customary format that only the gateway and some little client-side piece provided by Web Fragment knows about, that use it to encapsulate basically the frames or the chunks that are coming from these different loader streams, would send them to the client. On the client, they could be appended into a template element.
Yeah.
And not rendered, because they will be rendered in the wrong location. But in this template element, the client-side part of Web Fragments could look out for them. And as they appear, they were like, oh, you belong to this other fragment. Let me just move you over there. Yeah. And as they come, we just keep on adding things, to different fragments.
That's what I'm saying. You could just you start you have the main initial thing for both fragments, but then you start just appending these other like little chunks and route them in. Though that's cool.
Yeah. So basically, we would be able to multiplex a single HTTP HTML stream and enable multiple HTML streams to be like piggybacking on one HTTP connection, and in the browser still appear in the right location, and it's all full streaming enabled.
Okay. Yeah. I mean, that sounds like fun to wire up, because it's that's interesting, because inside the app you have them streaming the content themselves, and then I mean it's just it's this double gameplay, I guess, because for example we stream template elements, right? Like when we do our out of order streaming in Solid. So it's if you had a solid chunk come in and then it's template and it's gonna
that would still work, right? Because this is just HTTP allows you to layer different transport encodings and compressions and whatnot, and they don't know of each other. You could do the same thing at the HTML level and basically encapsulate chunks of HTML in a way that are suitable for the transport. And as long as you serialize them and deserialize them in a way that doesn't change the content, then you can achieve out of order streaming for any framework. But instead of doing it within the framework, we do it at the fragment level. So then, I think it's honestly much easier. Out of order streaming within the framework is just super hard, as you know, because there are just so many things that you need to align to get it right.
It's similar, right? Like the suspense boundary, which I was already saying, there's a similarity between the fragment boundaries and the suspense boundaries, right? Okay. Yeah, but if you're already setting up that way, it's interesting, because then, I think it's, this is an interesting thing, because you're right, then there does become a choice of whether how much the async stays within the scope of the framework, or how much of it ends up becoming let's just make that a separate zone. I guess it depends on the use case, but having both is powerful too.
Yeah, but also the point is that you can then get out of order streaming even for frameworks that don't
have it.
Right, and that is the biggest value add.
There's a few of those still.
Few of them, most of them, right?
No, I mean React does out of order streaming. Solid does out of order streaming. Svelte does out of order streaming. I don't know about Vue. Vue, I'm not sure about.
I don't believe so.
Yeah, Quick and Astro don't. They do in order. I'm actually not sure. You're right. Maybe it's 50% of the big ones. Not. Yeah. So yes, very cool. Sorry, I'm just.
Cool. Sorry. Any other questions? Come on.
Yeah. Let's see what
I'm looking for hard questions.
Yeah. Are we getting specific? If you use engine and exit gateway reverse proxy, does that eliminate rest only? Or what? Okay, call save rest only. Are SSE and or WebSockets possible? I guess these are other ways of thinking about.
We are going to be enabling server-sent events and WebSockets at some point. For now, we support Web API and Web Fetch API and Express kind of Connect API, the regular node server-side types.
So right now we are at 0.8, and there are a few features that we would like to add. WebSockets is one of the must-haves for 1.0. And
server-sent events, I wasn't thinking about it, but if there is a good case to support them, maybe we can think about it.
Server-side events are just HTTP, right? So that might actually work out of the box. I don't know. We need to experiment. Some of these things were usually all of these technologies, how do WebSockets work, or how does CSP work? it's actually not that difficult to make it all work once you sit down. And sometimes it just these technologies just work out of the box. Other times it just requires some minimal tweaking on our side. And as people are building bigger and bigger applications, then these needs surface, and then that's when we fix them. But yeah, it's been an interesting journey because, as I said, like originally, not even vanilla JavaScript Hello World worked, and now we have these massive applications working. So
this virtualization thing is just wild. I mean, when you just think about what it's actually doing and what it accomplishes, right? Because you're pairing like the isolation from iframes in a sense, but then you're not completely isolating everything. So it's actually like works really to the benefit, and it really changes things. As I said, like I've used. We did try to build similar type stuff, but we hit blockers earlier on in the process, and then we never got to the point of virtualization. We only got as far as like basically these like streaming HTML kind of stuff, and or sorry, like the fragments being like these almost, you know. But yeah, I mean, I'm just trying to think.
A huge benefit is for developers working on the host, right? Because debugging these applications is essentially much easier, much simpler than if you have the full stack and the whole JavaScript to understand where a bug is coming from.
Yeah, I mean, it's clearly transparent. I mean, it's like one of those moments, kind of like another time I kind of had this kind of feeling was when I first saw, was it Party Town or whatever, like from the Quick Guys, when they did that thing where they had all the analytics scripts running off in the worker. I mean, this is a little bit different, but it's still that feeling where you're just like, I just didn't even picture that this would be possible, and that completely changes what's like. You suddenly go, okay, well, what I thought was possible or impossible is now possible. What does that change? You know, sometimes maybe at first it's the little things, but then you're like, you kind of keep on going. And you're like, there's huge implications of what this can do, right?
Yeah, exactly. Like, and that is the most exciting part about this. Is that like, it's not just that I think we have like a really solid solution for micro-frontends, but also I think we broke down some barriers in the web development that existed for dozens of years. And now, as you said, like things that were previously impossible are now possible. And, you know, I fully expect that there will be others that will adopt some of the patterns that we have pioneered into their own libraries, or will come join us and help us build web fragments. But yeah, I think there are pretty big implications to what we have developed.
And even standardize some parts. Right?
Yeah, that's actually a good segue, because let me actually share my screen one more time. So I just have a few more slides. So yeah, this stuff is at production. At Cloudflare, we're working towards 1.0. Goal is by the end of the year. We're looking for early adopters. So if there's some enterprise out there that thinks that this would be great, I can share the link later with you, so you can drop it into, maybe I can just send it, or you can use this QR code. There is this link where people can sign up. We also have Discord that we just started, so it's just been bootstrapped, but I saw people joining already. So people can come and talk to us on Discord. Come on. Okay, I don't know how to copy this. And here, I have a hard time giving up. So I guess that's how we build web fragments.
Yeah, I did share in the chat the link for the sign up.
Perfect. Thank you. Yeah. So then, when it comes to roadmap, like we just need to battle test everything. Do this like multi-fragment SSR support. Potentially like explore the out-of-order streaming. I don't know if that's my wait for after 1.0, but if it's easy to implement, which it might be, and I would like to squeeze it in. But after that, after 1.0, I think there's like a lot of interesting web standards that we've been either utilizing or looking at. atomic DOM move operation. We would really like to use it. Right now it's only in Chrome, and we found issues with it. So working with standard bodies to fix some of these. There's like interesting scope custom element registries proposal, which would enable custom element support across web fragments, because right now the custom element registry is global, so it's shared, and that can be a problem for if you register one custom element in one fragment and another custom element with the same name in another fragment, they will collide. So that is like something that we could benefit. Shadow Realms is very interesting proposal out there that is a different take on virtualization with some similarities, but also different takes. And I would like for us to work more closely with that committee and just see, could we pick up pieces of Shadow Realm, or could this reframing bit be baked into the browser? Because right now we did make it work with a lot of magic, and the thing that I'm worried about is that yes, we made it work, but will this keep on working for years to come? Like we've already seen with Zone.js was in a similar project where it was crazy monkey patching of the world. And at some point, async await came, and it was like the first async entry point in the browser that we could not monkey patch from userland. And that basically killed Zone.js, which later got resurrected as async context, and like parts of it are now being like baked into the browser. But I really want web fragments to not just be a userland library, but a part of it to be pushed into the browser, so that we don't have to worry that 5 years from now something load bearing is going to stop working and reframing is going to break, for example. That would be very unfortunate. And then there's the writable DOM or streamable DOM. I think what Dylan did is excellent, and we should bake it into the browser. That has so much usage, and getting that would be, as a native API, would be awesome.
I think he created that library when I forget who is this. The guys on the Chrome team were on a GitHub issue and being like, "Hey, can I do this?" And they're like, "Oh, you'd have to do something like this." Dylan literally saw a comment on an npm on a GitHub issue, and that's what inspired the whole library in the first place. So
I talked about this with Dylan, and he said that they ran into issues with, I think it was like with web components. There was some pushback from web component folks who didn't like something about it. But I think it would be good to bake it into the browser. And I think we have proven that there are many different use cases for it. Excuse me. The last thing I want to show you is my team is awesome, and they actually sent me a URL where we did take the main dash. So what we're looking at is the main dash. This is the monolith version. This is single. There's no web fragments here. And then we have this version that is slightly different. There's this text. This is like literally development version of it. So there's like random text. But the point is that it's the same dash with all of the functionality. But this content is the second copy of the dash nested in itself. So if you look at the element, we'll see that we're actually nesting. There's a web fragment boundary, and this is the application running in a web fragment. So the main dashboard running in a running in a web fragment, and it's nested into itself as a host application. So it's kind of like super meta. But the point is, like, now we can decouple the shell part of the application from the content part of the application. Throw away the shell part, replace it with the brand new shell, and the content part will be preserved for incremental migration, because it's going to take us years to rewrite. I don't know how many routes there are in this legacy application. So that's really cool.
No, definitely cool. I get it as a strategy too. Like basically like conquer and divide, or sorry, was it not conquer, divide and conquer? Yeah, sorry. Conquer and divide.
You can conquer.
You can also conquer and divide.
Yeah.
I think that some like for some private equity funds, they conquer and then they divide and sell off.
Yeah. But yeah, what was I going to say? Sorry. In terms of the open source effort and stuff, and what's been going in the project, I like roadmaps and stuff like that. There's a couple questions. What was it? Is there a plan to create middleware in other languages, Python or C#, or is this like, contributors can kind of,
Yeah, good question. Not right now. The question is whether it's actually needed, because if you think about it, the middleware is really just HTTP middleware that needs to be able to rewrite HTML, and you can just take Node.js or Cloudflare workers and put it in front of a C++ or .NET application without the application knowing about it. So it doesn't need to be baked into the server-side part of the legacy application. You can just have it as a transparent proxy in front of the legacy application. So for this reason, I don't think we'll rewrite this into another language. If somebody really wants to, they could, but
That said,
I think it's completely unnecessary.
If folks are feel inspired to do it, they can open up a request. We can think about it.
Yeah. The last couple questions, and honestly, if you've got more questions for Natalia and Igor, please ask them in chat now. This is your chance. They seem to actually be more about just experiential stuff. I think a lot of people have a lot of growing pains with micro-frontends and these kind of things because, like, I don't know best place to ask for this kind of advice, but like, there's a question like, from a QA perspective, how confident can teams be that there won't be any regressions once all these separate apps come together? Is there a specific recommendation with the setup?
Yeah, that's a great question. Again, it comes to
end-to-end testing all the way.
Yeah,
well,
so you can.
Yeah,
you can
Go ahead.
So
Go ahead.
like there are several parts to it, right? Like the application itself, you can end-to-end test in isolation. If the question is about regression caused by the virtualization breaking down and there's like leakage between applications, then that's a bug in the fragments and we need to fix it. If the regression is because there's shared state between parts of the application, then minimizing the shared state is the right approach. And if you can minimize it, then you have to write end-to-end test that verifies that these different fragments talk to each other correctly.
That said, this is why we are looking for early adopters, because we want as much feedback as possible. And
Makes sense. Like the other question was actually kind of similar again. It was like, did you guys ever run into a problem with one team breaking the event contract between fragments? How does it look like when a fragment needs to change APIs that other fragments are using? I mean, these are general kind of micro front end kind of questions, right?
Yeah, or microservice, like,
yeah,
like I think if teams rely on this a lot, TypeScript can help a lot. Natalia has done a lot of work with TypeSpec, which is exploring how to like have type-based APIs across REST APIs. But I think the same applies to events. You could, like, just like we have TS API and like these various TypeScript-based RPC frameworks, you could use the same for the client-side communication. Cloudflare released Captain Web as an RPC framework for JavaScript just a few weeks ago.
Yeah.
One thing I would like to do is explore, like, could Captain Web be used for communication between fragments in a type-safe way? Because it's basically like protocol, a better version of protocol buffers, but for JavaScript.
Nice.
So I think they're like, this is the area where we need help, where we need people to go and try and let us know what works, what doesn't, and we can then agree on some best practices.
Yeah, makes a lot of sense. Yeah, because what you have here is like the mechanisms available now, like the low level mechanism, and the best patterns that form around this are something that we're just gonna have to wait and see. Like, people have already been building on with micro front ends for years now, but yeah, maybe with a tool like this, it becomes that much more accessible to do so. So very, very exciting. Are there example websites or URLs that people could try just to like take a look at?
Yeah, we have obviously the official repo, but we have some samples. I don't know, Igor, if you can.
I have
So
the, I'm going to drop the URL to our chat and Ryan can share it.
Yeah.
Just a sec.
I'm also collecting links because I'm going to be posting them on the YouTube as well, like on the video and on the description. When
that
we get
said,
to that.
the auth use case is being asked about a lot, and I'm going to spend some time creating a sample for that. So.
Oh, nice. So what you just shared is this, which is, what is this? This is a web fragment React migration path. Okay.
Yes. That's a demo we just showed.
That's the enterprise demo that we're showing.
Right.
Earlier.
So yeah, showing an old single page app, kind of not old, I guess it's React 19, but showing a single page app, client side rendered React app, and then showing the progress into different frameworks with full stack stuff and the web frameworks that we were looking at earlier. Very, very cool. Okay, I think we're pretty good here. Is there anything else you guys want to share before we let you guys go?
No, just I want to encourage people to go out and try, and thank everybody who has given us feedback, because we were able to get this far only because we were able to spend some time with different people and get feedback from like Tanner and others. Dylan and his streamable DOM, writable DOM library, like many of the things we are building on so much of the contributions from the community, directly or indirectly, and just want to say thank you all for that.
That's awesome, and thank you for being on the stream today to talk about this technology. Really, really cool. I like that intersection of like really interesting novel approaches, and then the fact that there's like solving a real problem, like a real technical challenge that's been existed for a long time. That intersection is always super, super interesting, and keep it going. I'd love to have either of you guys back to talk about whatever comes next. So
yeah, once we add
exciting.
1.0, maybe we can come back and just talk about the Delta.
But yeah, very exciting stuff. So thanks for joining me today. The stream is not over, guys. I'm going to continue a few topics, but very exciting, and it was great having you all both. So
thank you.
Thank you. Bye-bye.
Bye-bye.
Bye.
Bye.
All right. Very, very cool. Oh, yeah. Yeah, I mean, as I said, it's reminiscent to certain parts that we were working on, and like you kept mentioning Dylan's work at when we were working stuff at eBay and Marco. But I think we're getting very close to seeing kind of like the finished story. I think the virtualization, along with the writable DOM, it kind of it completes the story, which I've waited a long time to see this. There's a comment earlier like that's reminding them of Taylor or Mosaic. I don't know if anyone remembers that. They were Micro-Frontend architectures that kind of like, I think I watched like a go-to talk back in like 2016 or something about that. Like, and the funny thing is, I felt like that approach was doing a lot of things right. It was just very involved, very specific software. You were like putting together like 10 pieces to make this work. But it was like generally trying to be like the right sort of solution. And then even them, they like stuff changed over time where everything became spa centric and everyone started trying to like load all these frames on the client. And I don't think that's the right path. And I think what we've seen here is kind of coming full circle again to like a really kind of good solution potentially. And I mean, more to flesh out in a sense, but it's a core mechanic. It's a primitive essentially. And I think that's always what's interesting to me when you can, there might've been stuff that was being done kind of somewhat similar in certain ways, like not like the virtualization or whatever, like that's crazy. People try to do stuff maybe with even iframes in the past or whatever. But clunkier. We've been like now, or I say we, but they were able now to boil this down to a point where, it is these couple mechanisms coming together, delivering an incredible amount. So I'm very, very excited by this technology. Yeah. All right. So what on to next? Well, I got more topics. We can definitely keep streaming for another hour, maybe close to 2 hours, depending. Yeah, I've been holding back on my hack MDs for a while now because there's been so much good content coming in. I mean, even just there, that Micro-Frontends thing was a good 2.5 hours, and we got to talk with Tanner earlier about this kind of isomorphic first mentality. Yeah, I want to see where that goes, but there's been actually quite a few different kind of thought experiments or kind of stuff we've been working on, and I actually want to talk a bit more about Remix and kind of, you guys saw my live reaction to it, and I guess some of it even got shared because I definitely reacted pretty heavily to a few things, but I have more thoughts on this stuff as well now, so we should talk there, and also we should also check out Tanner's article that he was sharing before we started the stream. Use restraint. Oh man. Yeah, near the end of every, yeah, that's true, right. There was something else. Oh yeah, right. There was NextConf this week too. I didn't really. I know they have something called cache components. I guess another approach to caching. To be fair, I haven't really. I wasn't like on the like last year. I was at NextConf. I was in San Francisco. It was just down the road, so to speak. I wasn't really around it this year, so I didn't really see much of that. So won't be talking about that today probably. But yeah, yeah. Let's look at this because first, because Tanner actually wrote something that I bookmarked. What is it? I'll continue to die on the hill. Magic directives are bad API interfaces. They're not type safe. They're not extensible. No native runtime control. They're just strings. I can't believe this, but I'd rather debate at directives. Please rewind history. I have a few thoughts, but I want to see where this goes first. So this is where this thing. Now we're getting a bunch of, if you don't like directives, it's because you're not smart posts. Okay, we're not going to go there, and let's go there. You babies think building software means create next app every 2 weeks on another dumbest side project. You'll never finish cramming. Okay, whatever. But some people work on other types of software where they live back in. There's a standalone service running on Node or Bun or something else. There's a wide range how this code gets compiled and run in production, and they're all valid. Providing a library type feature that requires a compiler means it has to support every single configuration of this. It's more to maintain, more to deny, more complexity. So choosing this new workflow is how much heavier choice, project dependency this way. In fact, manage to completely change the JS and then ask you to do this. And to illustrate my point, if I want to use this library today, I can't because all our stuff runs on Bun, and you need to ship Bun plugin called Rust Transform. So add a new kind of function coloring that's going to run into awkward APIs, heavier work. I'm not saying the library is bad; it just looks good. People find value. If you don't like it. Well, okay, that's also a very aggressive take. It's actually bundling, not compiling, that I think is the point of contention here. Because the funny thing is, like, I don't know if Dax is responding to the same stuff, because Tanner's not talking about not using a bundler or not using a compiler. So I don't know if the fact that directives or not makes a difference. Okay, I need to read all of this to understand what the argument being made is. Because if you guys remember, I didn't use directives originally when I was working on Solid Start. I introduced server functions originally as just like server, and then decided to add a $sign because it wasn't like obvious what was going on. We needed somewhere to flag it, and I thought what Quick did was kind of cool, so I added a $sign, and then talked to the Quick guys, and they're like, "Yeah, this is sweet. We should do it too." And then eventually I started changing things to use server. And there's a very good reason. I actually went on in a stream. If you guys remember, I had a hack MD where I went in a whole bunch of depth. I actually proposed a completely different model for how to handle use client, use server, and since they're entry points, I made a whole argument of doing it on import, and even like using a standard syntax that was like import blank as, like basically use like I forget what the name of the spec is, but use like the import call side to do it. Like I went very far, and then I decided that React was right. So I'm interested to hear what the argument is. Yeah, import assert, is that it? Well, I mean, and that's the thing. I mean, the base of it is that we kind of want. I mean, there's pragmas, which we already do, like JSX import source, or like, and there's JS, and then there's also like, it's almost like we just want macros, arguably, like almost like C style macros. It's funny because I think Jared and Bun was doing some pretty fun stuff there. Jared was actually part of the reason who actually convinced me that directives were a good approach. Just from the perspective of generic handling mechanism for his bundler to be able to know. It's just funny that like that was the argument being made, but Jared was actually the one who convinced me on directives. I don't know if people actually know that. Right, and I actually got flagged on one of these where someone finally agrees with me. What do you think, Ryan? And well, let's read what do we have to say here. For years, Java has one meaningful directive: use strict. It is standardized, enforced by runtimes, and behaves the same in every environment. It represents a clear contract between the language, the engine, and the developers. Now, new trend of frameworks inventing their own levels: use client, use server, use cache, use workflow, and more are appearing across the ecosystem. Yeah, now, I do have a fear about this because I think the meaning here has to be very clear, and just adding a directive once a current directive isn't convenient for you doesn't make sense. Like, use cache and use server are fairly similar, and I definitely started feeling the where when use cache was mentioned, but let's keep on going. They look like language features. They sit where real language features sit. Its effective code is inserted and bundled and executed. There's just one problem. They are not JavaScript, sure. They are not standardized. Browsers do not understand them. They have no governing spec. Each framework is free to define its own meaning, its own rules, and own edge cases. Okay. This might feel harmless or ergonomic today, but it carries on to consequence the ecosystem consequently. Okay. Doesn't look like platforms. Developers treat them like the platform. Okay. So it's interesting because this is like kind of like the other side of the argument. I was saying that no one could tell that my server functions were server. Like I was sitting there demoing server functions on Theo's stream when I first did Solid Start, like way back, and he's like, okay, I get the $sign, but he's like, we had a couple functions that took multiple arguments, and he's like, well, does this run on the server or does this run on the client? And I'm like, you know what, you're absolutely correct. It was not obvious because the wrapper was kind of suggested as much, but the problem is it was actually the scope that should have been defined as being server, not the wrapper function. And we have lots of functions if you use signals, right? Because everything like has to, or callbacks and stuff, like everything ends up being wrapped in functions. So I was like, our convention is always the first function. When you have a $sign function, it is always the first function, right? And I think Quick has similar conventions when they do their code splitting. I know it's like in the opposite direction, but like it was essentially, I was like, just come up with a convention for it. But it didn't quite fit right. I actually find use cache different since you need functions to find other behavior for cache. I don't know. It's kind of weird. Yeah. It's not as clean, right? And you start going, should your directives have arguments? Should you say like, and combinatorics, use server cache, like don't get like composability. But I'm going to get there for a second. These are specifically designed on the fact that they aren't composable. This is actually a language feature. This is a positive that they're not composable because server functions aren't actually composable. Just FYI, they don't compose the way you think they would. It's okay for not everything to be composable. I think this has actually been one of the most interesting developments over time with React. React is so composition oriented. And I think they know that server functions aren't composable, which is why they're fine with this. But then what ends up happening is reality, not everything ends up being as composable. Like I wrote a whole hack a while ago about how server components aren't as composable as you think. I stand behind that still. I think there's a reason. It's not just because of popularity that you don't see as many server component libraries on npm. It's actually fundamental to the design. But let's continue on this here. And can I make this maybe okay? When directions treat them like the platform, a directive on the top file looks authoritative. It gives the impression of being a language level truth, not a framework hint. That creates a perception problem. Developers assume directives are official. If you can treat them as a shared API service, which is I think what React wants. New learners start to distinguish JavaScript from framework magic. Oh man, I mean, has this ship sailed? I mean, it's so funny. I feel another side tangent, but I feel like Solid is one of the most just JavaScript frameworks out there. But if you like talk to a React developer, they're just like, no, that's not the case. And you're just like, I don't even think people can tell at all anymore. Like even remotely. I know we went over that whole conversation I had with Maple on the previous stream, but like I don't think people have any clue. Like React compiler, Svelte compiler, like people do not know what JavaScript is anymore. Like sometimes JavaScript is clunky because that's JavaScript and that's how it works. People are getting to a level now where like the DX expectation here. I mean, I was even thinking about it the other day because this morning, someone I think Scott Linsley was like saying like, I think Svelte remote functions are like the best API for remote functions. And I made kind of like a cheeky, great design. I love it. Right. Obviously making a reference to the fact that Solid starts remote functions and Svelte remote functions basically look identical. Right. But there's actually one difference. And actually Dev got it wrong in his post that he made. But it's in my original talk. When we put the query function around our server function, the use server goes from outside the file, atop the file to inside the function. I don't know if I can find this right now to say what I'm saying, but like, I mean, I could just throw it in the playground. You'll see what I'm talking about. Let's just garbage this. Bam. What I'm saying is like, you might start with something like use server and be like export my function, some function, my func, whatever. You might start something like this, okay? And I mean, I get Tanner's first argument. This is async, but use server can't tell you that it's async. Like if you use a wrapper, it'll actually force async. People miss this people do miss this. To be fair, like this is what he means about types. The types are fine. You import the types you get, but the problem is that this async is you can just not do this and get the wrong types, but like it has to be an async function, right? Essentially, or return a promise. TypeScript doesn't really differentiate too much on that. Okay, so my point is you can start here and you can do stuff, do the stuff, right? Now, if I want to add caching, if I want to do caching behavior to this, right? You actually have to wrap this function. So you can say like, actually, let's go export const myfunc equals cache or query. Let's go query this, right? Sweet. Now we query, we can even give it a query key or something like whatever. It doesn't matter. Like it doesn't matter the API too much. But the problem is the query cache is on the client. So technically speaking, this shouldn't be here. This should be here, right? And I'm just bringing this up, right? In terms of people with JavaScript, like in a sense, when I look at the Svelte remote functions, their use server is out here even though it's doing this. So like what you see is not what you get, right? They're like, oh, look, you just export these query things. But the truth is like in the .remote function, this telling you that the whole thing's like on the server probably. No, I mean, the reality is it's split between the client and the server. But we're like putting in the right scope is actually explicit. You know what I mean? Like, Sorry. It's all right. Why doesn't it? That's my bad. That's the way I did it. But like, do you know what I mean? This is like a nitpick, which is funny because you're like, well, none of this is just JavaScript. But what I'm getting at is there's something like I hit this when I was designing the system. I was like, crap. I need to actually put this in the block scope. But like, it doesn't make any sense for this to be like main.server and put the query here because the query is not on the server. Do you know what I mean? Like, so like there's things you do for convenience and things that you do because they're explicitly correct. Yeah, I mean, I guess I don't know the install case. Our query cache is on the client. That's what makes this powerful, right? You don't have to go to the server to know if it's invalidated. And like at least the way that I implemented it, because you can invalidate on the server, obviously, through the actions and the single flight mutations, but you also have the client drives the interaction of terms of like that's the benefit of the architecture. And if Spell compiler has a different query logic on the import on the client side, again, that's hidden from you, right? I guess because like if you think about how a bundler works, like I don't think they're looking at, I mean, I guess we'd have to double check. I don't think they're looking at the call site and going, okay, I'm going to add the wrapper code here. I think what they're doing is they're actually taking their .remote module and forking it into two modules, essentially a client version and a server version. And then when you import on the client, you end up with the right wrapper on each side. I have no problem with the mechanical aspects of it. I'm just pointing out that it's misleading from like the just JavaScript. But there's no expectation that Svelte is just JavaScript. Right? Let's continue. The boundary between platform and vendor blurs. Okay, sure. We're already seeing confusion in a while. Many developers cannot believe use content server just modern JavaScript works, unaware that it only exists in specific build pipelines. Yeah, I mean, especially if you're living in the React ecosystem. Share chance well as share respect is fragile foundation. ECMAScript. Shared syntax, shared contract, framework directives. Shared syntax, no shared contract. Okay. Directives create an ecosystem arms race. Okay. Okay, so this is basically the argument against it. This is not what was like I got from on Twitter. The lock-in is subtle but real. Even when you know bad intent directives, lock in by design, mental lock-in, tooling IDs. Well, the tooling lock-in is actually really important because the problem is this is almost why one of the other arguments why I kind of got strong-armed into it a bit. It's the same problem like JSX is one of the worst. I love JSX in that the spec is open and anyone can use it. But on the other hand, TypeScript's use of JSX, and the fact that they provided transform is one of the worst things that has ever happened because it said like, this is the way. And even React themselves ended up changing what the way was, but TypeScript had this built in and it lets people, again, have no connection with reality, right? Right. Like where we were talking before, where new learners start the framework magic. Yeah. Like, people like I used, what was it? Like I use, Fresh because there's no Dino. Yeah, that's Fresh. Yeah. Because there's no compiler and it's like, that JSX isn't transforming itself. Well, it's TypeScript, right? Well, it's like, it's not, like, people who say that they don't use a build tool and then transform the JSX with TypeScript are like there's a disconnect there. I don't want to call them hypocrites, but the positioning is hypocritical, right? So like tooling lock-in is real. Code lock-in addresses the same to, okay. Directions don't look private. They have way more private than API could because they reshape the grammar of the ecosystem. If we want shared primitives, we should collaborate, not fork the language, server execution boundaries, line framework directives. Okay. I get his argument now. I think this is a reasonable argument. My justification or thinking around this had a bit to do with the tooling lock-in consideration, but it's actually a mechanical thing, right? And I think this is probably why the React team went there too. When you look at the problem, the reason importing isn't good is because in the case of stuff like, these client components or whatever, this is a self-identifying moment, right? Having use client in the file with the code is like saying like, look, I am a client component. You can't import me as a server component. You can't do anything else. This is my identity, right? And maybe you can use linters and that. You can like look and go like, I am a client component. This means I shouldn't have state or something. Like what I'm getting at is it prevents the risk of it being something that it's not. And if you talk about all the other solutions, they don't do that. When you decorate something, when you don't make it part of its identity, you can always get away with someone abusing it. To be fair, this argument holds up way better when you think that things are composable. If you thought server components were going to be composable and all over NPM, the last thing you want to do, you think, is like you want to just be able to author the component to work in a certain way. You're like, I am a client component, and just put it out there in the ether and it just work. Not people like misuse or be like, oh, I'm going to import this here and do this. Like a lot of the stuff around, like there's rules. So, I mean, we talked about it earlier on the stream around like lakes versus islands, and you can't import a server component into a client component, right? The identity here matters, and it makes sense, like what I was showing here, for you to actually recognize the scope of the change. Like, don't get me wrong, I could always do this, right? But I think it's important to you'd be like, okay, I don't like this, right? You're like, I don't like the server wrapper. I'm going to make this query $, right? Like this is like the first thing you think of doing. But the problem is it's actually, sorry, I got rid of this. It's actually this call site that matters here for the transformation. So like you can't compose this, like wrap this in it, like extract out part of this and then inject the function from a different location. Like it doesn't actually work. So like people might not, like I get it now. The argument against directives is that it masquerades itself, like it basically leverages it's a problem that we've had a lot. It's like it overloads an existing syntax, and whenever you overload an existing syntax, it's dangerous, right? It's the reason I don't like the way Vue and classic Angular do templating, right? It's like you're adding new semantic meaning to an existing syntax is always dangerous. So that is a great argument. The problem is the alternatives are not particularly foolproof when you consider it in like a larger scale in terms of composition. Now, since server components don't really compose, this is probably premature. I mean, I did a whole article I showed earlier where I was saying, sorry, and I should actually put Tanner's thing here. Just share it in chat here. But like, yeah, I don't know what the, like, I myself often choose stuff based on the mechanics, like the shape of the solution. And from that perspective, I do think directives make a lot of sense. But I'm also, as I said, because of that article that I went over earlier with Tanner, we're talking about not even use client, just using, just use server. And I think that at least feels more natural because you're calling out a specific environment and not the generic. I think what rubs people, like Tanner probably wouldn't have even wrote this article or cared about this if he didn't have to write use client. I don't think use server bugs him, use edge, whatever, as much as use client. Use client sits really poorly with people because in their mind that is the shared, that is the default. And now you have to denote what the default is. I think this just hits people in such an awkward way. That's why we end up with this conversation more than anything. Mechanically, declaring at the scope level makes sense. I get it that reusing the language feature is bad, right? And I've talked about wanting decorator functions as well as what you said revisiting might be better, than adding like a billion of these variations. But we are really looking for a scope level thing. Like, so from a mechanical standpoint, the characteristics and composition, all these things, this makes sense. That being said, this is also a very good argument. Okay, what do you got here, chat? The person made you strict will only know the consequences this will have. It's ironic that JS devs are so unhappy with these directives while C, HPC signed uses fragment and compiler directives all over the place. Yeah, I mean, I don't have experience with that much experience with those languages. I mean, I used C back in the day and had a lot of fun with macros, but mostly that was just for recognizing that your C code runs on lots of different types of systems. So like you'd be like, oh yeah, it has, it used a lot of the macros back in the day used to be like, oh, there's a different like CPU architecture, and you would have to just like very top level swapping. Anyway, I don't know. I get it. I get this argument. I do think that mechanically the solution makes sense. I think the usage, I think part of this discussion is getting really warped by how much people feel that there's like a cadence mismatch with React server components. All right. What do I got here? Did all my transitions. Do we want to talk solid 2.0 or do we want to talk async? Okay, I got an idea. So which one was this one? Dynamic optimized for elements. I don't think this one was. Yeah, no one cares about this. That one's old too. When did I do that one? August? And I haven't found a reason not to talk about it. Nah, did I cover this on stream? Is it ever safe to write to a signal in a derived computation? I feel like I did. I'm just gonna publish this one anyways. I'm not gonna talk about it today. If I haven't published this one, I should. I did this on a previous stream. I'm almost positive. Okay, so then let's go to the present. I did the JSX one, the true successor to JSX. Okay, and earlier I did isomorphic. Let's talk about this. Designing an async first framework. This is a reaction to Rick coming on my Rick Hanlon coming on my stream about, what is it, like 3 weeks ago? And it's also a reaction to Svelte 5. And let me share this one out. Let's publish this as well. Hopefully HackMD doesn't limit my publishing. Yeah. I can't publish too many articles at once. I don't like publishing these until usually I talk about them. I share them on the Solid Discord, but yeah. Sorry, quick. Oh, that just spammed like crazy. Oh, did I share the wrong link? Damn it, I always do this. This is my edit link. I need to share the actual copy share link. I need this one. Sorry, that link probably doesn't work. This is the link we want. Yeah, my bad. Use client directive could be unnecessary if the caller add it to the component hook level instead of the. Yeah, I mean, we've looked at ways of like automating this. It's one thing. I mean, you could look for use, but like compile like language level features are always better for analysis. The same reason that I thought it was really interesting, like what Ripple did with the templates and that JSX thing, because like a for loop you can analyze. A dot map function you can't really safely analyze. I know people will like hack it in, but that language level features are just better for compiler because you know that it is the thing it is. People can't just like alias it. And it's the same problem with the hooks. Looking for the existence of hooks isn't always clear. There's also things that there's shared components. Technically in React, there's three categories. You have server components, which, well, actually, I mean, it's not technically. You have components that are, yeah, I guess async components, like server components that have to be on the server, and then you have stateful components. There is possible to be a third category that is neither stateful nor async that can run on either side. This is like the thing that's missing in like the Astro models of the world, because Astro has like Astro and then your framework components. You can kind of force it in Astro by saying like, don't hydrate this client component, but there's no guarantees there. Someone could put state and say, don't hydrate it. And then you get like a stateful server only component. I think React really wanted to avoid that because they were like, it breaks expectation. Like I didn't really care. I'm not gonna lie. I was like, whatever, it renders. But people are like, well, it's weird to write a component that has state in it and then that state never be able to update. I'm like, okay, sure. But like there are definitely those two categories, three categories, right? You could argue that in a sense, there's actually two categories in React: components that were imported somewhere, on the, like from the beginning, which starts on the server. And then there are components that are stateful, right? So whether there are no server components, they're just components that were started from a server entry point because it's all one tree. And then stateful components that have to be client components. You could make that argument that there's only two types. But again, it's the reason why you don't need to use server, or they got rid of the .server file names on server components. It's because you don't need to enter back into the server except for with API calls. That's what use server's for. It's not for server components. Whereas like use client is something you need to denote, like this is the thing that's different, right? And as I said earlier, when I was doing that stuff with Tanner, that's like absolutely backwards than what we've been doing for a decade. Sorry about that. It's like I pressed the back button, like on my mouse kind of like accidentally did the back motion and I got booted out. Give me a second here where I share my screen again. Yeah, I mean, you can use it, but it's not a solution, it's a hack. Yeah. Same as not hiding app install code or removing substance if it's true, but like, or you can do it in all of them basically. Anyway, so yeah, I mean, I feel like what I talked about at the beginning of the stream is really relevant on this in terms of like, as much of the friction is around these directives as it is around the default switching. It makes a lot more sense for people coming from a front-end framework standpoint is if their normal code, either their client-side code is their normal code, and that they denote like, hey, this is something that runs on the server, only. Because their normal code runs on both sides, right? That's an isomorphic first kind of take. Anyways, so completely other end of the spectrum, that was an isomorphic first framework. What does an async first framework work like? Because what I was looking at is in Svelte, everything gets locked up and they use the reactive graph to kind of figure it out, plus compiler tricks. Honestly, I don't know exactly how it works, but it seems the results are pretty impressive. I played around with Svelte async model in terms of like trying to force places where branching would happen to cause show that it's not a transition. And to be fair, Svelte seems to handle it fine. Like my classic example where I have tabs and you click to the next tab and you have like a counter counting underneath it. So technically you think about it, if you're going to the next tab and it needs to load and that counter is underneath it and it's updating, you would release that tab in order to render the other tab if you didn't have any kind of forking. Svelte manages to keep that example working, which suggests to me that they do have some level of forking or isolation. Maybe it's shallow or whatever, but it's effective enough that I honestly, in any kind of basic demo, you're not going to really notice the difference between Svelte's behavior and using a transition in Solid. It's actually quite impressive. But okay, so you can kind of, even though not exactly the same thing, you can view what Svelte's doing as everything as a transition. But I was like, okay, the problem with that is always pending state. You're always like, you're like, where do you find out what's pending? You have to ask the world. And in fact, in Svelte, $effect.pending, it does that. You're kind of like, is the world pending? And to be fair, in Solid 1.0, our transitions were all locked together as a single thing. So we had the same thing. No matter where you use transition, you would go, you'd basically get the pending from it. You can basically not even use the transition, just grab the pending and it would all be linked together in that kind of global state. I put it in the API for future considerations, but generally we had the same global pending state. But in a different world, you have to solve that problem because not all transitions all entangle all the time. So like Svelte handles at the block level by like within the boundaries, they kind of scope it. It's only like a component kind of level consideration. But anyways, you start thinking about how different solutions work. And then on the React side, Ricky came on and tried to basically turn every event handler into a transition implicitly in the design system so that when you go write your code, you're in a transition all the time. Like basically you're either in React or you're in a transition. There's nothing outside, right? Transitions are outside of React in a sense, like they're outside the reactivity, but they are basically means the second you step back into the event handler, you're like, you're on the outside coming in, you're like straight into React, like into the transition. The end effect is that React and Svelte kind of end up being the same thing. So you start going, well, if you're going to make every event handler a transition anyways, why don't you just make on click a transition? Why do I need to be involved, right? As the developer. Now, maybe there's good reason, but that's the starting of this article and this thinking, right? Sorry, chat. I'm back, right? You guys can see me, right? No one's commented in chat since RIP. React and Svelte becoming the same thing again for the first time. that's you guys are hilarious. No, it's Svelte 3 and React compiler are very, very similar. The thing is, we're all kind of circling around the same kind of zones. Svelte, obviously, with Svelte 5 adopted ruins, signals, and some of the other patterns that we've been seeing around like the Solid ecosystem. But async is a brave new world, so we've got to like start thinking about it like in a way that makes sense for our solutions, right? Okay, so where are we? Once in a while, it's good to question our core assumptions, ask yourself, we could start over what we do. My recent work on async got me thinking about this. All current JS frameworks are sync first and build the consistency around that. But what would an ideal async first framework look like? Well, first of all, I said that everything would be a transition. Transitions would be implicit and not require an API. You'd opt out of async into tearing, like we do with create optimistic. But the default would always be on. This means no click action. On click would just be a transition, even the backside of create effect. What I mean is like the actual callback functions of like create use effect or whatever, like make that a transition too, right? Like you don't really want to be setting state necessarily in an effect to cause a loop, but if you do, transition it. Like let's just go crazy, because we honestly wouldn't know. If we had no transition API, we'd have to make those decisions. Any place that the framework identified as entering in, would have to, I mean, I'm not suggesting that they hide a transition wrapper. I'm saying more, which is what I just said sounds like. You have to just start thinking that if you call set state somewhere, you need to pretend that that's the beginning of a transition implicitly, right? Oh, and also thank you everyone from chat to tell me that I'm alive. I appreciate it. Okay. So that's the first piece. Second piece is you need to determine pending state by asking. Is pending wouldn't just apply to all downstream things from async portion to change, but anything from the start of the change that hasn't settled. Set the next tab, but can't see its change yet. Is pending would return true for it. This is something that I started like thinking a lot about, because I built an is pending in Solid 2.0 where you could just like literally use the graph. I dev used in a demo where we have the demo, so we can do it. I have this demo, collections, beyond signals talk. Where is it? Graph power. Okay, cool. I love this demo, obviously. But what's cool about this demo is we ask is pending on upper phrase here so that we can show this, the affordance that it's graying out, right? When it's not airing. See graying out? Graying out, sweet. Now, upper phrase isn't actually the async thing, phrases. So we can ask this question because we can basically trace the async graph. We know we're not ready, right? But I was having this funny thing is that if you have something like use transition, it also has a pending state, right? And you're like, why do we have two different pendings? Like, what's going on? I have this pending and this pending. And I was like, well, how do you show pending for something that's off the screen, right? It makes sense that this is different. This one, when you have the data in front of you, you can ask about it. You can go like, hey, is this pending? But when you're going to the next tab, you don't know if it's like, it's something off screen is pending. What are you asking about? The thing off screen? Well, it occurred to me, and whatever, let's just save that. Let's go back to my dashboard and go into my collections, Solid 2.0 experiments. I mean, I might have not even updated this one recently. I haven't. These are 18 days old, so I guess I'm gonna put my what is it? Oh, where is it? Switching tabs. I thought there's a different one. Tabs. Solid experiment tabs. Let me see what this one is. Yeah. This one, right? Where you switch and then it shows suspense in some cases and shows pending. How am I showing this pending? Right, I'm using is transition pending, but we don't have our transition API. So what can we do to fix this? Well, let me see. Let's first make sure that I'm on the right version. I'm not. So let's update to 2.0 experiment 10. But okay. So yay, okay, still working. Like loading too fast to see it. Yeah, it's like anyways, you get the idea. But it was like, okay, well, if we don't have use transition to enter this pending state, how can I tell if I'm pending, right? If it's the thing off screen, right? So let's just get rid of this. So we're using transition, and then you're like, okay, well, now this is pending somewhere is going like, what's going on here, right? So we have is pending. What's pending? What are we asking here? Well, as it turns out, we should be able to ask the tab if it's pending. Even though the tab is upstream of async, we should be able to ask this question, which hopefully this works. Yeah, sure enough, it works. Yeah, there we go. See, still graying out. I mean, it's too fast. This is like something I was doing very recently, this changing is pending to work like this. But where is my server? Is there API? I'm trying to remember where am I? Oh, it's the child components. It's too fast. I don't really want to make it slower than that. Yeah, I mean, you can see it's working. It's still graying out. Sometimes it's so fast that it doesn't gray out, which is what you want. You want quick interactions, not to show any pending state. But yeah, you can see that it works. And it's because we can ask the question not just on things that are async that haven't loaded, but we can also ask on anything from the source that changed. So if your transition sets the tab, then the tab that we weren't able to update it right away, right? There's a delay. When I click on this, it doesn't switch until it's completed. That means that tab is pending, even though it itself is an async. Essentially, the value in the background is 2 or 1, or like going 1 to 2. The value in the background is 2, but it's showing 1. That means it's out of sync, it's pending. So it occurred to me that if I was designing an async first framework, we wouldn't have a global pending. You just ask for what's pending. Slow it down by it's the AI slop. I mean, these are artificial timeouts. There's no actual data fetching. But yeah, I mean, what I'm getting at is like, this is a beautiful use of using the reactive graph. Again, common theme in a lot of stuff I've been talking about, to basically ask this question. If you have global transitions, you want to know what's actually transitioning. Okay. State changes would apply async. Everyone's going to love this one. Yes, the React behavior. Since derived values could take time to propagate and you wouldn't want to witness a torn state, it makes no sense to commit state changes immediately. More state changes could occur before the synchronous block ended, and that could cause async to entangle, so you could never know at the time you write that you can't commit it right away unless it's optimistic. What I'm saying is, if you had an async first framework and you called, we can look at our example, right? There's no transition wrapper. You call set tab to 1. You can't read that tab is 1 on the next, or sorry, you're on 1 and you want to set tab to 2. You can't read that the tab is 2 on the next line because it might be in a transition like this, right? We don't want to switch the view, right? Like, this works that we can read it like outside of the transition. We show the old value, and then inside the transition we see the new value because we fork it. But if you have no transition wrapper to show the two different realities, you have no choice on read but to basically say especially outside of the context of the reactive system, like when you're actually rerunning the code on either branch, you can see the appropriate values. But when you're out in the effect, like out here, in our effect handler, you can't actually know and that you can update 1 to 2 and immediately see it. You could be like, okay, well, does it trigger anything async? I can make that decision. But you can't, because without the transition wrapper, you could call set state like 4 times. And it might be the 4th one that actually triggers it. And if they're entangled in any sort of way, as I said, even with smart parallelized transitions, if the state for the first one touches the same state from the 4th one, and they entangle, which would cause them to lock up to prevent tearing, then you can't update that value. So the only correct behavior is React's behavior, that you can't read the state update on the next set state if you're in a purely async. Right? You guys following? I know. I'm not suggesting that we're doing this, but this is one of those examples where people will criticize React till the end of time. Reading a pending value could be flush sync. Yeah, but the problem is you can't flush sync because it could be async. Yes, you can basically flush sync at that point, and if it's updated, If it can update, then it can. If it can't, but you don't even know at the time the sync is the same, because that's also no, like, because that's actually opting out of the block, like, essentially, because if you do the first set state, then you read it and you flush pending, then you're kind of, and then the next state comes in that actually would entangle it, you're kind of lying to the universe. Do you know what I mean? Like, you're basically saying, okay, you could, like, it's one thing to say I'm calling flush sync, which means I'm ending the transition here. But it's another thing to just read a value and implicitly end the transition because you read the value. So yeah, we've talked about these kind of solutions, especially when I get to the next section, because one of the challenges with a push-based reactive system like R3 that Milo did is that you have to basically flush when you read pending values. So like there's an alignment here, but that I'm about to talk about it here in a second. But generally speaking, if you had an async first framework, the state updates have to work the way React works. I know that's not popular, but just throwing it out there. Latest like pending is a way that you could try and like, like a flipped latest. So you can like choose to tear. You can be like, show me the value that's behind the hood. Yes, you could use a helper that says show me the value behind the hood. Yes. Yeah, you could probably do that. I'm just saying the default read would have to be set the state. The default would have to be that the state doesn't update immediately. You need a special helper. Why can't React just be universally bad? It would Twitter arguments so much easier. Yeah, I mean, you know that meme, what the meme generator or meme, what is it called? Distribution graph. The stupid meme, right? Everyone uses this meme wrong. I'm scared to use this meme correctly, but I think it's perfectly fair to say that, like, if I put the React developer right here, and then I say like people who dislike React on both sides, it's perfectly fair. Like, I once made a quote that I was like, I don't know who's more frustrating, the people who don't understand React was 80% right, or the people who don't understand React's 20% wrong. And then I recanted and said, no, it's definitely people who don't understand React's 80% right. These guys over here are there's no like, I dislike React on this side. There's no helping them. React is very well designed. I don't think it's the best solution necessarily, but it's very well designed. People can't argue that very effectively. No one in like my field who build that can't have some amount of respect for the way React is designed. Yeah. Like, yeah. And the people who argue that React is just wrong for everything, I don't even know how to debate with them. It's like, I'm not sure if they're acting in good faith or bad faith, or if they're just like really that stupid. Like, it's really hard to tell the difference sometimes. Yeah, I don't know. Okay, yeah. So, but let's think more about it. If you can't commit right away, push-based algorithms like Milo's R3 look more attractive. Since there's no expectation for reads to trigger early stabilization, since we aren't committing state changes right away, we don't need to notify early, which means we could skip notification altogether and do more performant algorithm. Also interesting is, since R3 is eager, we don't actually need create async. The main reason for it is it forces things eager in a lazy system. In theory, any create memo, create projection could just be async. I was very hesitant about this in the current design because I've designed a pull-based SSR, but maybe push-based SSR is possible too. So Milo, if you guys don't know, he hasn't come on the stream to talk about it, but I've hinted at it, and I talked about it a couple months back. He was trying to beat alien signals in terms of performance on like signal performance, and he did. He came up with an approach because push pull, well, it's very smart. It knows exactly what has changed and the impact of that change. It still requires double traversal. It's more like 3 traversals, like partial third, because you notify down, then you pull, then you're at the bottom and you start pulling, which means you kind of walk up. And you walk up to a certain distance, and then you end up running back down again. So it's like 2.5 traversals. And actually, Joe Savana at his React Conf talk actually talked about this, because he was trying to say that signals weren't the most efficient algorithm in terms of updating UIs. And in a sense, he's not wrong, except his benchmark that he did is completely useless. That's a whole other thing, right? It didn't show what people who watched the benchmark thought it showed. It basically it's useful for what he was doing on his work with React, but like is not indicative of like how someone would use signals or at all. Like you don't change the signals and then not use a signal-based data structure. It's like it's bonkers why anyone would ever do that. But what he was saying, if you kind of like ignore the benchmark and ignore that, is that it does have truth to it. Like, why do a double pass algorithm when you can do a single pass? Well, as it turned out a few months ago, Milo did exactly that and showed that there's a way that was faster in signals. But the things you give up, no one would want to give up. The big one here is this is not easy. Like, you really don't want set signal to, when you read it on the next line, to see that change. That just forces new work. Like if I scala draw this, when you talk about any reactive system, you can actually talk about it. You can actually talk about them under the same. Gonna scroll out a bit. You can actually talk about them under the same thing. They actually have. There's a few phases, right? There's when you write state. Then what else do we have here? When you commit state, pure side effect, pure computation, and let's add one more. The cycle, whether I'm talking about React, whether I'm talking about Solid, Vue, Svelte, whatever, it's all the same. Side effects, like 4 phases, okay? Right, 4 zones. Now, I don't know if this is the best visualization of it. I just want to show that like these things, roughly, most of the time when we talk about signal solutions, what signal solutions do is they have like, this happens right away. So I'm going to use signals. What you end up doing is you write state and commit state immediately. But the reason they can stay consistent is they also they tie these two together, and they also notify at this point. So they do their first pass, signal, notify, okay? This way, if anyone reads the state, they know that it's changed, so that if there's any early state changes that requires pure computation, they can go run them on the fly, right? This way, if you like, you end up, yeah, I'm gonna keep green for signals here. Whereas, like over here, this phase happens either on demand. Yeah, actually, this phase always happens on demand, whether when you ask about it or when you pull it here, and this should be white. And then finally, for signals, this is scheduled, right? For most things. Actually, it's always scheduled. Even in Solid 1.0, which does sync stuff, we just run it at the end of this current synchronous frame. It's still yeah, I mean, this is pretty much scheduled for everyone, right? But the difference is, like if I'm going to use a nice blue for React, let's grab this with React. This happens like React set state. And then what React does is React does it this way. They group this side together, right? React, and this is like pure render. And then, I mean, I feel like this just needs to be white because literally everybody schedules this, right? It's like the same, but it's like a slight difference, right? Signals have to do work here, like a small amount of work here to notify, and they do this so that, for the most part, they defer this work until it's scheduled to run, right? Whereas which, I mean, it's also scheduled technically. Okay, scheduled pure render, right? So like this is for everyone. These end up running back to back. These end up running back to back as well when you don't access them early. But signals have to do this extra work here so that if someone asks for the value early, they can preempt that and do the work earlier. React also doesn't have the graph in the same amount of detail, but I'm just talking purely on scheduling here. And then like R3 could be like this, right? It doesn't have to work this way because we can still schedule this kind of work, but for R3, it's like set signal, let's say. And then I mean, it's a lot like React actually, except it has graph awareness, right? R3 is just, then it's like scheduled push data traversal. It's not. It's smart. It's not. It's glitch free, which is really cool. Which most push systems are not. But what I'm getting at is there's a tiny bit more work that has to happen up front here, and then this does like a much more complicated dance than both of these that run kind of top down. The biggest difference is React doesn't know what has changed and R3 does. So this is like, you can start seeing why like maybe the React developers would start designing an algorithm that's similar to what R3 does. Notify of change. There's a great article, Michelle Weststraight, Mobservable, 2015, fully. And actually, you know what? Actually, screw this. Supercharging reactive performance. Milo's article, no. What? That was weird. Supercharging reactive performance. Milo's actual article is probably the best reactivity intro article for algorithms, not for like how to use signals, what are signals, but like how the algorithms work. That it's kind of like the update on Michelle's article. But the idea is to prevent, oh, come on, what's going on? Why is the images being weird? Where did these go? What? They like, lose the images? That's really frustrating. To prevent diamond. Okay, this one's here. To prevent these weird kind of diamond problems where you have like this depends on this and this depends on this and this and this, where things can like go down one side and like not see the changes from the other side. What most signal libraries do is they do a notify pass where they go down all the nodes and say, hey, these ones are like, these ones here are like, this changed, so I know that I'm invalid, I need to run. But then these ones get like, maybe you should check first. I don't know if I need to rerun, but I need to check. And this one this way. And that way, when you evaluate this, it knows when it reads this, it goes, okay, I should check. So it goes up and looks and see, oh yeah, this changed. I do need to do something. Because if you don't check, this chain could be broken. Like if you're propagating down this way, push, and you get to here and you rerun this, you might not realize that D's changed. See an old version of D, and then when it propagates down this way, it'll run a second time. To be glitch free and to run once, the easiest way to do it is propagate the notice of change first, so that all the sources know that they potentially be changed, and that way you avoid like just like double following the graph. Okay, so I don't know why all the other images aren't there. I'm glad this one is there. Like they're all from the exact same. That's just odd. Anyway. Yeah, this article reads a lot worse without the images, because the images are literally the whole thing. Anyway, what I'm trying to get at is, from an algorithmic standpoint, other options are faster. That being said, sometimes the algorithms don't actually matter that much in practice, or like you don't scale it. So like this might not even be necessary. The difference in performance between alien signals and solid 1.0 signals on a signals benchmark looks significant, but basically don't translate into any meaningful difference in like kind of real world scenario. Like even in the hyper focused benchmarks, so the DOM-like.js framework benchmark, it's not the thing that tips the scale. So like, you know, creating thousands of rows. Sure, the DOM is overbearing that benchmark, but generally speaking, like the algorithmic thing isn't going to, the structural considerations, the architectural, the data structure are going to make way bigger changes, which is kind of obvious. I think I know that was a conclusion of Joe's talk, but I think it's kind of obvious. But all right, I'm hoping this makes sense, right? So new algorithms need to be researched. Yeah, okay, sir. But basically, yeah, R3 looks really attractive in this world because you don't have to like do that extra work, right? You can just basically not commit the change and then schedule and do it in a single pass. So, I mean, that's good for performance. It's kind of like the best of what React does and what Signals do. If you're willing to give up the thing that literally, new picture, if I tried to propose that Solid didn't set state right away, people would freaking flip their lid. It's so funny. People are upset about splitting effects. Like, it's so funny, like the kind of things developers focus in on. You know, I get it. There's like an ergonomic thing, but like, I don't know. I do have to be mindful that there's like a line between correctness and like usability. But again, I have a lot of respect for what the work is done on the React side of things. Okay, so. Don't translate into real world, exactly what Joe said. Yes. And also they were using like the React Fur thing or whatever. They were using like, it's not the full feature set. You find when you add extra feature sets, like concurrency, that's a fun one. Your performance kind of goes down. When I added concurrency, like I actually, in Solid 1.0 repo, you see a benchmark section. I basically had to properly test the different reactive algorithms in bare test. I had to strip all the concurrent features out of the signals implementation so I could at least compare them head to head to understand. Because when I added concurrency, like, you know, that's another, you know, it was another like 10% hit. So like when you, if Solid didn't have transitions. We do compile them out when you don't use the feature because of, again, code splitting. Why bundling is like amazing. But assuming you have an app that has transitions in it, so the code's in there, the checks that avoid the transitions or do the transitions, like the extra overhead in the code that can't be tree shaken out because you actually use it, ends up adding like another 10% to the signal's reactivity, which again makes no actual difference in reality, but it's something to consider, and in the same way the React for thing probably didn't have concurrent features in it. So like the gap between the reality of what you're doing and like the hyper benchmarks to show like the proof of the concept, sometimes that gap ends up just closing anyways once you actually try and do anything real. Like the way performance works, it's not like you're only as slow as the next bottleneck. You know what I mean? Like it's not like it's like this linear thing you work down. Oh, did he repost it on his blog? I'm gonna need that link at some point. But yeah, it's a great article. Okay, so yeah, but we also need new algorithms, right? Because even though we go down to a single pass, forking everything on all state changes feels like it would be kind of expensive. Iteration would be nice if this scenario could be known by tracing the graph. Now, Svelte does some cool stuff with the compiler, but I'm not going to trust a compiler here, and I'm the just JavaScript guy. So let's when I look at a solution, I think about how you can do it without a compiler, and then decide if the compiler can help with the ergonomics. Always start with JavaScript, right? Another reason to hold off commits to collect the whole set of changes. We can trace downstream observers for async nodes to determine whether to fork. This may mean an additional pass. Also unclear if this method is foolproof. Async can be inherited from any source, so any change of condition could reveal a different apply to async source. Yeah. So what I was thinking is like, if you don't commit the changes right away, like you're just sitting there with all the right state. Now you get to the end of the stack frame. You got to the end of like where you're doing, and you're like, you scheduled it to run. At this point, you see the challenge with async is, once you notify, you're changing the state, which means if you're cloning transitions, you have to clone at this point, like at the point of notification, because otherwise, because you're gonna have nodes that are dirty off screen and nodes that are clean on screen. You can't, you have to clone at notify, which means that you have to make the decision right at right. Whereas in this one, you can defer the decision of when to clone when you get to here. So your first thinking, with something like this is a data aware graph like R3, is that you would be able to do a pass here and decide, like basically in this, instead of notify, you'd add the second traversal back in now for async and be like, tell me if anything's async. If it's not, we'll just run as normal. If there's something downstream that's async, then we will fork. But we'll defer that decision until we get here. Now, I was like, that's pretty good if you think about it. And I've hit this, work on the transition stuff. You kind of know the graph. So it's pretty easy to go trace any depth down and be like, okay, there's async down here. Like you can tell on a simple, cheap traversal similar to notify that you have async down there. So like I didn't bother doing a preemptive async check on the Solid 2.0 transitions that are working on the signals kind of style, because like we're gonna pass over it when we notify anyway. So like, who cares? I guess the cloning is that traversal, to be fair. So I guess we do it here, but what ends up happening and I saw this also when I was working on the transitions. Sometimes it is possible that stuff that happens at the time can cause a different forking, which will now reveal a different async dependency. And what I mean by that is, I'm trying to think if there's an easy way to show this without like drawing it. It's possible that a downstream decision will open up a path to something else that's async that might already be in flight or triggered by a different ace. No. See, if it's caused in the same stack frame, here's the scenario. If it's caused in the same stack frame, if any of the writes hit async, then it will definitely lock up appropriately. But if one frame goes out, like one synchronous frame, and triggers some async, and then the next frame you do a couple sets, and they trace their dependencies, don't see they intercept with async, so they should be able to commit right away. You're like, okay, sweet, I can just commit right away. So async's off over here. You can keep on clicking that counter, so to speak. Yeah. Then, but if a count becomes bigger than 5 and now reads from that other async source that was previously gone, now you suddenly have to lock that up. It's like too late. You're already traversing and you hit it too late. So the more I think about this, I think you almost have to always fork, right? Like, I don't think this is actually detectable from the reactive graph purely because while you can collect all the changes from a particular synchronous stack frame, you don't know across different synchronous frames, I think, like what async could possibly be uncovered by the change of propagation, right? Like, you know everything down, but you can't control conditional up, right? Like if a new source enters the fray. Yeah, sorry, I'm not going to draw that. I mean, I could write it as code if it helped people, but like it is possible to have like a equals create signal, whatever, and then just make the graph right here so we can see it, and then we're gonna add. We have const c, which will be create async, something async that depends on a, let's say. And then what else do I need? I need probably create effect. No, I need a memo first. Const d equals create memo. I mean, I think this should be visibly understandable. It's like b bigger than 5. Actually, I'll just use an if statement. If b is bigger than 5, return c. Otherwise, return b. Okay. Hopefully this makes sense. If you look at this from a dependency graph standpoint, when it initializes, it sees that the only dependency for d is b. I don't need the effect it doesn't matter how the effects go. So it doesn't, like, you when you set b here, you think that you're safe. You're like b just a d down to some effect. Okay, so we can update this right away. And if a updates, well, it triggers c, which is async, which is maybe in a different effect. Doesn't really matter, right? But it's possible that if without a transition wrapper knowing like the scope of what the clone, if you set a in one event and then immediately after set b, and at that point b switches to bigger than 5, like, well, it's just doing 1, 2, 3, 4, it's fine. But if it immediately switches to bigger 5 at that point and returns c, it now should be entangled, but you've already updated b, so it's too late. So does that make sense? Completely off topic. Why 700 kilobytes every company tends to 5 minutes single level? I mean, was that AWS was it amp? There's something like AWS library that's like the worst for this. But we took the wrong turn because people wanted to use the same tools for building applications that they use to build websites, and applications have a different need. Thank you. Yes. Okay, good. I'm assuming you're saying yes to understanding what I'm saying here. Okay, cool. So then following along from here, like, I actually don't even know I mean, maybe I'm saying right now, I don't think maybe it's possible, but people like Milo surprise me all the time. So you'd have to be smart. Otherwise, you'd basically be forking every single operation. And I can't imagine that's fast. If you've ever seen like JS Framework Benchmark, the transition version is like 30% slower than just using normal React. Like, it's considerable. Okay. And then also finally, actions would need to be collected differently. Right now, we like await the actions and collect them like as part of the transition. Makes it really easy. No transition wrapper would mean wrapping each action. You know, be saying like we do like in Solid and Svelte, like our RPCs, you wrap it, you can be like action this. So like in a sense, like we have some APIs, but if you want the action the mutation action to tie to the pull state, which is why I've actually been following React's APIs here. In Solid 1.0, we didn't do that. We kind of just like did a bunch of actions and then transition the states coming back in. But if you actually want to tie the action to the state, which is why, you know, there's that second start transition call in React, or why we use resume in Solid, then you kind of need async context. Like, you need a way of like keeping stack scope. It's not just good enough to wrap the action. You actually need a way of like going, like continuing this thread. So, you know, like even if we wrap it and like inject it in the then, one more await loses it. Now, obviously, you can wrap each of those awaits along the chain, but the problem with promises, people don't realize this a lot of times. They incidentally just add extra thens without reason. Like every time you have if you have a function that returns a promise, that's fine, right? It returns a promise. But if you await an async function, and like then return that, like you're still returning a promise, which like you've added a dot then implicitly there by adding an await, right? You didn't need to. You could have just passed the promise straight through, but by awaiting it, you're like the async function is like implicitly adding another then to the end of your promise. So like breaking the chain is not difficult in this world. Like people could just do it accidentally. And I mean, I don't know about the whole timing on promises, but my understanding is like it's the same way when you have an async function, you return 5, like a number, it becomes a promise, it becomes async. Anything you return from an async function becomes itself like a promise value that resolves on the micro task queue. So my gut here is that this would just, like, people could do just stupid, simple stuff like, you know, as I said, you wrap something with an async function and basically lose stuff. Like you need async context if you want this to work. So doable today. Actions only happen outside the system. A means to come back in. So making that global effectively extends the scope of the system. Is that too forceful? Yeah, I wonder about this a lot, right? When I think about like, you know, Svelte runes, impacting like the whole world, needing to be transpiled. Like, does the framework have boundaries, right? React, sometimes the answer is really easy. It's like, we only care about what's inside the component. But I think we need to live beyond the component, but do we need to own like everything outside of it? Events, effect callbacks are generally designed to be synchronous. Sure, if you don't need effects to return cleanup functions, but it's just a thought, right? Like, if you know how effects return the cleanup function, if in an async reality, I feel like you wouldn't have it return because it'd be common to like make the effect an async function, right? Like transition, do an action in it. It would be weird to have it return a cleanup function. This is why I'm asking these questions, because if there's a reality where we want to be more async prone, certain APIs probably should be avoided, right? Just thought. Vue does something cool where they inject their cleanup function in the callback function. We had our global on cleanup, but it's weird for us to, if the effects aren't tracked, it's weird to have the cleanup function. Like that, it doesn't make sense. It doesn't work in a non-tracked scope. So like if we split effects and say this half's tracked and this half's not, the not tracked part, it doesn't make sense for it to, you can't use the global because there's nothing for it to hook into anyway. And another comment here, the transition function is actually quite similar to MobAx's action function. Generators exist for a similar reason, calling the transition again. In absence of async context, it feels unlikely any solution will fully invest in this direction yet. Yeah, I think this is the problem here. Like, you can use generators to kind of keep these continuations up, but then like, are you expect all your event handlers to be generators? Like, it's asking a lot. Is it the future? That's a better question. Biggest question comes is eventual worth anticipating? Should it impact API design now? Delayed commits of set signal would be incredibly disliked. Having a single is pending is pretty powerful and reduces API service. So yeah, what do I say? Deferred set signal. I can't picture anyone loving this change, but the one advantage of this approach is it obscures the reactivity algorithm from the developer. There's no push-pull versus push versus pull question. So technically, you can choose the approach that at will based on what is the most efficient. When you allow for immediate reads after writes, there's no avoiding doing work. Push-pull minimizes that work versus others, which can't know if what you are asking for needs to check for updates. But if you remove the question, then it never gets asked. This is again outside the system concern. Inside track scopes, you shouldn't be writing to signals, so it's generally consistent. So in general, immediate propagation of state changes is a convenience for cost. Deferring it is theoretically always correct solution, but we all know correct doesn't mean best. Yeah, so this is a hard one, right? People, it's so funny. Like there's this like tension, right? Between like React must feel this all the time because like you have Svelte on the other side. They're like, why don't you just assign a variable? Why don't you just call a function? And it's like, see, it's so simple. It's like, don't quite often the simple solution, like the easy solution is the right one. Like in a sense where you're just like, look, why are you making all this ceremony around something like when the average person is just doing blank, why make all this ceremony? Right. That was Ryan Florence's problem with flush sync, right? He said he's like, let's just call update. If you're gonna put an update function, which flush sync essentially is like, why don't we just call update ourselves, right? He really disliked that aspect of React, but then it's like, it's there for a reason, like a very good reason, and you'll lose every single one of those memes where the guy who with the the question mark meme when you make these kind of decisions, but in a sense it'll be the right thing. It just most developers will be too stupid to see that. So I mean very conflicted here on that side of things, right? But generally just something to keep on. Is pending on the other side. The proposed underlying not ready transition isn't only nice because it removes the need for use transition. It highlights that asking pending need not be considered via optimistic state. In fact, it's considerably different. Optimistic straddles both realities converging on a future. Pending is ephemeral and it only needs to exist in the visual branch. To be fair, when I said this, I was being optimistic. I ended up implementing the pending check internally to use a form of optimistic state because it was the easiest way to handle it. I might talk about that in a couple minutes, but what's nice about single mechanism from a composition standpoint is you can write your affordances one way. Like sometimes a component isn't the source of a transition, but has its own loading state or not. Suspense isn't built for this case, which is more for the large initial load scenarios. A dropdown probably should show loading disabled when its options are pending, as any selection here would be lost. Is pending would trigger apparent suspense initially, but now the update case works regardless of the change was in transition or not. There's a loss of connection of cause and effect, but the question of what is pending is descriptive. Is routing is asking if the router location, like the URL, is pending, rather than using a pending state provided with the routing transition. So it's possible to get false positives if the graph is related. I don't know if those are actually false positives though, but it'd have to be, but if you have a list of to-dos and you ask if a specific to-do is pending, it'd be possible we knew the action was refreshing the list that it would be. Is it a bad thing? I'm not sure. So to be fair, I'm not sure the implications of this kind of is pending. We always still have optimistic state as a way of like injecting, like saying like, hey, this is pending, like this action doesn't touch state, or like, I'm going to pull a real world example in 2 seconds to show what I'm talking about. As with any new sort of shift in thinking, we have to be careful not to go too far down the rabbit hole at first, or we distract ourselves and we don't know the full implications of these decisions. However, I love seeing these sort of parallels between developments happening in different areas that would aid here. I think the bottom line is until async context, this is probably dead in the water, but definitely something we should be keeping in mind if this would ever change. Okay, cool. False positives. Yeah. Yeah, it's fine. I'm not going to edit it at this moment. Okay, so let me pull up another example to kind of talk about this specifically. And it's the states example. I'm going to pull up both of them, actually. The first one, was the Ryan Florence demo, right? And actually, this looks good. Okay, so we do this. This one locks up, right? This demo's been going around a bit, right? And I changed this one, so I'm saying like if is pending cities, then this is great. So it's funny, we changed the state, but because it's downstream, we can make the same determination, right? The reason that I actually want to use this example, actually, I'm going to use the other one. Sorry, I'm going to save this while I'm here, but let me use this select transition and select. This is a remake. If you remember, Rick came on our stream and made his version of the to-do app. This is applying his thinking in terms of design components, having the transitions baked in terms of what the experience should be for this state selector. Typos are a good way to see if chat is still alive. But I thought this was kind of interesting because I'm using his change action convention, right? But in here, we have is pending props.options. You can kind of see it make more sense. Like if you have a select list and it has and your props.options aren't available, like the options you're literally going to iterate over, then you probably need to disable it or show a loading state or something. I use disable, it could be a loading state, it doesn't really matter, right? But generally, if I made this component and I knew nothing about transitions, transactions, whatever you want to call it, I just want to make sure that I'm using the right version. Are we on signals? Signals 0.4? No, it's the wrong version. I want 0.5. RM PM lock RM node modules. Okay, let's update. Just make sure I'm on the right version. Okay, cool. So. All right, and this still works. Yeah, beautiful. Okay, so what I wanted to kind of show off here, well, kind of working through this, is that this makes sense regardless of whether transitions are involved. And obviously, this works because the transition is locking it up and it works beautifully. But my point is, if I got rid of this transition, right? Let's just get rid of this transition for a second. There's no resume function. Whatever. Got rid of the transaction. Okay, whatever. What you're going to see is this still is going to work because this is pending, is downstream, and it's just the truth. The difference is, see how this is tearing? You see Utah before this because we tear by default instead of going back to fallback. Like if this is React, the whole thing would get like jump back to suspense without a transition. So we are tearing here. To be fair, there's other ways to avoid tearing. We could do something like, if is pending city, show like don't show this, I mean whatever is pending city thinking whatever. Otherwise city plus state. Let's add like a. All right. Ta-da, Now when I change it, look, I didn't show torn state, I mean, there's lots of ways to add affordances to do it. Transitions make sense because they lock it up. But what my point is, I mean, if I can even hoist this into a memo and use the previous value. You know what I mean? Like we actually only tear at the edges. We don't actually tear in the reactive graph to prevent async waterfalls. So like technically speaking, if I go back to this, back to this, and then I did something like const selection equals create memo, and then copied this over. Essentially, let's make it a one of these strings, and then $, just like people don't necessarily need transactions to work. Like, what did I? Oh, create memo. I need to import it. Create memo. You know, loading, and then oh look, it's the same behavior as if we had a transition, right? Like you don't necessarily need transitions, and I think in a lot of cases people won't bother with them. But what I'm getting at is like, is pending, this behavior of asking is pending works really well when you have a tearing interface and you just want to like go, hey, is this thing loading? And which is like the baseline when you have a synchronous framework. Like I built the stuff in Solid assuming sync first instead of async first. It's like completely opposite of that article, right? Whereas like, what would I want to do if I just wanted to like had a synchronous system? As it turns out, what's really wonderful about this is we can also, as I said, go back to the beginning and keep those same sync affordances. Actually, I'm going to keep this memo here just for sake of it. Actually, not this. Yeah, I'll keep the memo for the sake of it. I can go and add this transition back here now. Transition. And then resume. We passed this resume in because we want to tie the specific transition to the specific action. React doesn't need to do this because React entangles all transitions. But what I'm saying is adding the transition or removing the transition doesn't change the behavior here if you do things with pending states, right? Like, so you can build, if you're always checking with is pending, transitions are just an additive feature for the things that you haven't handled the affordances for. So what I'm getting at is this is pending along the graph is a universal concept or feature, which I think is really, really powerful. I'm going to undo this example back to the beginning. But okay, so I'm hoping people are kind of following what I'm getting at here. This is why is pending is actually really quite cool. But okay, so I finished the article, right? Yeah. Yeah. So I wanted to show off this example because it actually relates a bit to some more Twitter stuff. We're kind of getting into this week in JavaScript now. What did you say no to? Not and I want to talk about this one really briefly. The more I think about Reinforced to select demo, the more I love it as an example. The cascading nature makes it difficult to localize state. When you select one dropdown, it's the other one that is loading. So I thought, what if I added a third and so on? So I want to show this example for a minute here because this is the same example, but I decided to add another dropdown and I changed the rules because when I originally set this up, and you can see it here, it automatically every time you set the state, it loads the cities, which is powerful. That makes sense. But the problem I was having here is every time I select it, see, when I select this here, it loads the cities. The problem I was having is whenever I selected the country, it would load the state and then load the city, and it would cause this cascade for a state that I might never care about. Like when there's only two, it doesn't matter. But when there's a third, you kind of want to like change the rules here, right? So I was like thinking about this example, and I really started thinking about that moment in the stream where Ryan Florence was like, who wants to wire up a dependency graph? And I was like, well, I think I do, right? And the reason that I wanted to wire up the dependency graph is because I have the same one select component that I've abstracted, right? It has the is pending check, like we talked about here. What's so cool about the is pending check is it's not it's pretty easy when you change something, like do a transition for something to know itself changing. But this is pending because a different select triggered. You understand how hard that becomes to compose, right? The select component makes that really obvious. Even though this is kind of obvious, like, yeah, my own options aren't ready, then I should be as pending. But it separates it from the source, which is the other state selection happening. So what's cool about this is I updated our example now. So we now have this placeholder state. And I'm going to show you the use of the placeholder state. The placeholder state is well, if there's no value, so you haven't selected one for yourself, and there is a placeholder that's available, placeholder and props. So this is just like a default. But I also said no value. So once you select one, the placeholder state disappears. There's a bit of delay in the browser, which made that not as smooth. But when I go here and then when I look here, it removes itself. So these are the two scenarios. So there's a little bit of extra logic here, but nothing in here is specific to this, like to the domain of the problem here. This is just a cascading drop down that takes a placeholder prop, options and value. So assuming I have a functional placeholder thing with handles this loading state, it doesn't handle suspense though. I don't think suspense belongs in design components because suspense always overrides. Do you know what I mean? Like you can get around this pending state if you pass optimistic state into this dropdown, because then it's not going to be pending. It's going to be the future state. But suspense you can't really opt out of very easily, I guess. Like I guess you could do the same way. Then if you're reading the optimistic state, it won't throw. But it's weird because suspense is designed so that the child is the inversion that decides. And I feel like the way suspense, the person who's responsible for adding suspense is the same person responsible for adding the create async or the use. Basically, it's the same level of scope. If you add the async into your app, you should be the one responsible to say like, hey, I want the loading placeholder. You don't necessarily want loading indicators on every single thing nested. You don't want, like if your design components had suspense in every single one of them, they'd all have their own separate loaders. And the way suspense works, it's the inside wins. So how do you group all the suspense, right? Well, you could be smart, but the default behavior is it's going to just make a dozen loaders for each of these elements, where I feel like if you don't have suspense in here and you have suspense on outside, then you control that loading flow yourself, right? So, okay, I have a generic select list with a placeholder, no suspense, handles pending state, all that stuff. How hard is it to add this extra dropdown? Well, I added it. I obviously had to add the extra data fetching, but assume the data is in your database. I just needed to add create async, create signal, for our country selection and wire that in. I also changed the rules, right? Before, like if we wanted this to cascade, see whenever states change, it resets to blank. That's what's happening here. I go states change, set it to blank. If I change this to question, I actually don't even need the question, but if I change this to 0, we're going to get the auto cascading behavior back, I believe. Oh, it's because I anded it. I got to get rid of that and. Yeah, it should be or. Yeah, see how it took longer to load? It's because when I change this, now it's going to do that load, then this load. So there, our auto cascading behavior is back. But I'm like, no, actually, I don't want to auto cascade. I'm just going to change the rule here. So now when it loads the state, it blanks it back to default value. Okay, so bang. And this is faster now. When we change the country, we don't automatically change it. So it's more reasonable. But basically, I didn't need to change the select. I needed to add my new select to wire it up. So I had to wire it up. And changing these behaviors is just a matter of tweaking the dependency graph, like the logic in the dependency graph. I'm not stepping into any event handlers. In fact, all these event handlers, like change action, is set country. I'm just literally calling the state setter in this example. Not all cases will boil down this way, but as I looked at this example, the more I thought about it, I'm like, how hard would it be to take the Remix 3 example, where you have the very imperative, like loading state, fetch, async cancel, undo loading state, and put it, and now add another dropdown. Like, how do you compose that? Now you're dealing with multiple loading states that aren't owned by your own select list. They're actually owned because of the data graph, right? When you select something, you're setting the loading state for a different select list, right? I don't know. It'd be interesting. I thought if I had more time, I'd actually try and like build that out and see, like, because you can obviously build the same imperative procedural logic in any framework if you want to. We just don't, because we think this is better. But I mean, the reason we think it's better is the way that it composes, the way that you can just set up the rules and have it set down. Ryan was like, I don't know if, I'm a simple guy, basically. All these graphs and stuff don't make sense to me. I just want to, like do this, what I call grocery list shopping. And I think that's a fair kind of like concern. But I mean, when does the grocery list become unmanageable is an interesting question. I think there was a lot of tweets this week were like along that side. I think I saw something from Rick, which was like it showed like, maybe I have it bookmarked somewhere, but it showed like, you're really telling me like this is better than, like, it was like a one-liner use effect, and then versus like a whole bunch of imperative logic to accomplish it a different way. As I said, I love that Remix is challenging the status quo, so people are kind of like questioning the reason we do things. I think it's important to always question why we do things. It's why I come back and I write these hack MDs, because I like questioning the original assumptions. Like, I was a little bit too harsh on the frame component, I think, which is also in Fresh, by the way. Fresh has those HTML partials as well. I forgot to mention that on stream previously. But I think I rewalk these paths dozens and dozens of times to just make sure I didn't miss anything. Because the worst thing is to assume that you know too much and then you miss something. But quite often, like 99.9% of the time, you end up coming to basically the same conclusion again. So I think this is what the JavaScript ecosystem needs. Maybe they will appreciate React more thanks to Remix 3. Like, I don't know, maybe that'd be a good thing. Sorry, did I just get a raid? I was deep in one of my thoughts and there's just people yelling in chat. Okay, so let's just wrap up with a couple more things from this week in JavaScript. Hopefully you guys are all still there. Let's back out of this. I'm just gonna duplicate. I'm just gonna open a couple other tabs. Bookmarks and profile solid.js. Okay. No, other than that, I don't know if a ton's been going on. Obviously, we've been getting out of conference season, but I mean, I think we talked about conferences enough last week. Solid logo, apparently, solid start logo is available on our website, which is nice. I do have my upcoming talk, kind of slightly refreshed version of what I gave last week at JavaScript Days for JS Nation in New York on the 17th and 20th. But yeah, I don't know if there's much more. Yeah, React Paris. Yeah, I'm trying to think if there's. Yeah, we talked about all this. Bookmarks. We talked about this. Just yeah. Here it is. This is the tweet I was looking for. Yeah. Okay, bet no wrapper, which is easier. I mean, easier isn't always right. Why do the Remix guys always freaking delete their posts? It drives me nuts. It's like, I mean, to be fair, it's so people don't hold, stupid stuff they say against them, but still. Trick, take use effect event, which is funny. I think Evan quoted this one too, because like in a reactive library, you don't even need the use effect event. Like you literally you can just call the console login here and call it a day. You know what I mean? And track the BMP. Yeah, like it's even simpler. It's just the simple use effect versus. Yeah, I mean, this is going to be interesting. What's going to happen is people are going to find new ways to abstract this with Remix 3. They're going to find ways to patternize it into helpers. It's the RxJX phenomenon. The way this kind of patterns lead to is not that people write this. No one ends up writing a bunch of crazy code like this. What ends up happening is you start coming up with named operations, kind of like RxJS, where you timer this or that, and you start reusing them, which is interesting because it is definitely a composition model. I think it's very easy for us to look at the um, to look at like the fully extended, like how would I write this by hand code compared to like, a built-in scheduling primitive like views effect, and say like kind of crazy. But on the other hand, this will beget new composition patterns. That being said, I mean, we've had RxJS for a decade, so I feel like we've also learned what that looks like and the trade-offs there. So, I'm not as optimistic about certain things, but I do think that like this comparison might not be the most like apt one. But to be fair, in terms of what it is fair because of what the framework itself ships. Just a minute. It was brought to my attention that the React folks attempted to do a comparison between their compiler and signals recently, but for some reason they chose to compare to a wholly different framework and then not follow the framework's best practices. Bizarre. Did I not like this? Thanks, Jason. I mean, we know that they use solid.js in the example, and yeah. Okay. Yeah, this is what I was talking about, the reacting thing. Just aside, I was reacting to this more than update, and I said immediately after that I'm sure they're using this for a different reason, which was true. They used it for context. They wouldn't use it just for this. There's a lot of confusion around Remix. I don't know if I need to get into it. Like some people saying it doesn't have a virtual DOM and all that. It's not important. Okay, I think I'm done with bookmarks. Anything else on my main stream? Let's go back to my profile because I'm not gonna stay here forever. Oh yeah, I guess when talking about change systems and UI libraries, I feel a lot more comfortable when I can answer both of these. When does it update? What does it get updated? Okay, that's me just talking about Remix. Not really important. Thank you. Oh yeah, stream hit 20,000 subscribers. I found out this is largely thanks to Theo pushing my content through one of his videos. So, thank you, Theo, as well. But we pushed that last little boundary there. So thank you all who watched the stream as well. Remember to like and subscribe. This stuff does help get more viewers and get more people to discover the channel. Yeah. Yeah, I guess I didn't cover the V conference stuff too much. I covered it in my previous stream a little bit. I didn't talk about the V documentary. I talked about V Plus a little bit, and my panel talk on Beat. Yeah, it was mostly V Plus stuff. That was my previous stream, This Week in JavaScript things. I didn't talk about the documentary. The documentary was one of great privilege to be a part of. I think Beat is one of probably the most important project in the last 5 years. And being part of telling that history, even if my own story wasn't as interesting as some of the other people's, I just love to be a part of it. I think Beat is monumental in its impact in front end. Yeah, callbacks, set intervals, basically try to react, but not things. And yeah, I mean this. Yeah. It's kind of neither there. I agree for the callback case. Half of Twitter posts about Remix is how they added declarative balance to it. So yeah, people will go crazy on how they would use it. Yeah, exactly. Yeah, that's when you have a system that is. There's a balance there. When your system's too simple, people will always just build the abstraction on top. It's a good thing. It's why I like React. People they didn't handle all the state stuff. People built state libraries. There is an identity thing you have to worry about, but I do like that quality. I think the challenge problem there is some people they're like, hey, I added signals to Remix, which is great. But then it's like Remix will never do as well as signals with something that actually accounts for signals. So there's this agnosticism kind of level to it. Sometimes it's great. Sometimes it's the lowest common denominator. Have you evaluated local first framework stack like Zero? No, I haven't done any comparisons on them yet. I've talked to a number of these guys because they're very interested in the way that we do fine-grained updates and projections through. And I have people like Dev working, closer to some of these integration points. But I have not actually compared them one to one. I don't have enough experience basis on like to say like one versus the other. I think the space is very hot and very interesting, and I think it's a place where reactivity is very beneficial. I have looked at the like integration for Zero. I out of those ones, I have looked at Zero and have closer ties to Zero than the others. But yeah, I'm pretty deep down my rabbit hole right now. Appreciate it. Thank you. Okay, so oh yeah, okay, we do have another topic here. I want to talk about this one. Yeah, I talked about this. I talked about remaking with his example. Yeah, a lot of my stuff was that select demo. I talked about this. Okay. Yeah, okay. So and we talked about this article. Okay, so it looks like the last topic I got here is this one. A little bit controversial, but honestly, this is another example of like, I think this is the one that made me want to reach for the meme where people are really quick to blame React for like stuff that like completely makes sense, but they're like, so the fact that this error is specific is actually great. That means React has done the effort of actually detecting it, which I don't think we even do in Solid. We detect it where we can, but hydration is actually a really hard place to detect it. The idea is an HTML TR cannot be a child of a table. This will cause a hydration error. Are you kidding me? I can't put a TR instead of table now? See, yes, fuck technology. Fuck you all. I'm done. I mean, obviously this is a little bit hyperbolic, but I see both sides of the problem here. But I want to talk about this because a lot of times React gets blamed for hydration when hydration is kind of like, first of all, it's something that all frameworks do and have the exact same caveats. Everyone like thinks they're special. They're not. And secondly, it's not even a framework problem because the web component people all come out, and that's what I'm talking about when I talk about this meme distribution, and I'm talking about like the people over here. I'm not saying that web component people are over here, but like this is what they look like when they criticize React. Like I could reproduce. I would have this hydration problem with jQuery. Like vanilla JS. This is fundamental to the language. This is not a framework. It's fundamental to basically having any sort of abstraction for, especially any declarative abstraction over what the UI should look like, which is almost like every solution since the dawn of time that has to scale it all. The actual error message is more clear. Okay, well, there you go. The screenshot was edited. Okay, so yeah, I don't even know what it looks like. This was all like just, maybe it's also just to fit it nicely in Twitter. I'm sure this thing blew up. Like my retweet got 445 things. Yeah, 4,000. Someone actually responded the right answer down here. But like myself, only gets 500. Most people walk away from this and they're like, yeah, React sucks. I'm sorry, again, this is you. I have no, it's like because you're a React sympathizer, you know, that people give Theo crap. Actually, I want to talk about the Beat documentary a bit more, maybe, but maybe I'll just tangent here. Beat documentary. Do you know what the top comment is? Just. I'm sorry, I'm tangenting here, but it's hard when you just hit such stupidity. Need to stack document. Okay, I'm hoping that's a top comment, but when I looked previously, the top comment was basically people going, "Why is Theo in this video?" Like Theo haters, like literally like 300 comments or something were sort by top comments. I mean, he does make a comment about one of the first 5 people who use Vite with React. I mean, he was being hyperbolic, you guys. He was super early, but I was just surprised that I shouldn't be surprised by how much hate there was, but someone actually went even in the chat here and actually collected all the negative comments about Theo, and it was like a page worth. Like there's just so many in here, and I was just like, I don't know what JavaScript influencers you guys watch, but my experience is most JavaScript influencers regurgitate basically. I almost find like maybe there's some value to some beginners, but the amount of even like, how do I put this? Theo isn't always 100% accurate, but he's usually not wrong. Does that make sense? And I know us as developers like to like nitpick on the details. That's like what our job is. But like for that reason, I find Theo's content incredibly refreshing. Because I can't stomach most developer content. He's one of the few people that I can actually watch. So because like a lot of people will say stuff that sounds correct and they'll cite correct information, but like, and so they'll be accurate, but they completely miss the point. I'm not saying like everyone's perfect, and obviously some like Theo misses occasionally too, but like in terms of percentage wise, his content's probably some of the best that I've seen in the space, not even close. So I mean, it's just funny to see this kind of reaction, and I don't know. I might just like I have no clue what they think of what I do if they can't even like see the value in what Theo does. I'm just like flabbergasted. It's just kind of funny. I do know that what part of this is Vite is very Vue associated, and most Vue devs think Theo hates Vue. Whereas from an outside of Vue ecosystem perspective, maybe he's like his balance is like not where they want to be, but he doesn't particularly dislike Vue. He just, when he looks at it, he's like, maybe he doesn't care about it in certain aspects of other solutions because he's like, I've seen this before. It's just, I think that might be part of where this is. It was just funny. The comment isn't here, but I'm pretty sure, just as an aside, that when someone spends the time to put out an amazing documentary where, story stitching together all the frameworks, so many people got hung up on the fact that Theo was in it. When he, honestly, from the React ecosystem side point, the Create React app piece was actually super, super important. The documentary only glossed over it, I guess, a bit, but it actually put into question the whole, do I need a framework thing? It's one of the most fundamental things that has happened. And as I said, Theo didn't do it necessarily, he just triggered it. But in terms of the identity of React over the last several years. So like, yeah, I don't know. Sometimes the YouTube commenters are worse than the people on Reddit, which is saying a lot. I guess Hacker News is the absolute worst, but just an aside. I've watched 3 or 4 of your streams recently. Side note, I only just recently discovered it. Okay, so I mean, the gist of it here is HTML and DOM are one of those few languages where what is allowed exceeds what is correctly formed. It'll try to fix it for you, which is one of the, on one side, what really admirable, it allows a lot more things to work. Missing tags, missing closing tags, missing quotes around attributes, putting elements in the wrong place. It also allows for really cool features such as displaying content as it streams in, even if it's incomplete. But on the other hand, these corrections don't fit well into declarative systems, ones that want to give you what you see is what you get. Generic mechanisms for walking nodes break, mirroring all the rules for the browser that would hit on sides, complexity and duplicate work for every library. There are benefits to being stricter. Yeah, what I'm trying to get at is like, it's so funny because again, web component people are kind of arguing like, blah, 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 I won't do this. And it's like, the thing is, you literally can't walk and trust what your children or what your children are, like in terms of DOM nodes. Like this is the reason why Google Translate breaks stuff, a bunch of stuff on the web. And they're like, oh, well, you can just use selectors. I'm like, are you going to select every freaking interactive element, and they're like, no, well, you know, I'd use a selector to get the stuff, and then I'd walk it. I'm like, yeah, so you're gonna walk and it's gonna break. Like I don't know if people like listen to what they say. Like anyway, I don't know. I think this is reasonable given the choices. If your choices are error during dev to tell someone to do better, put runtime checks on all the code that run in production to slow everything down, to try and fix this issue. I'm definitely going with the first one, right? Especially when it's something that's like, in general, this trend of the browser fixing your HTML for you is really, really quite annoying. We have validation, obviously, at compile time to try our best, but it's the problem with the SSR, especially, is you can have separate templates. You can have like two different JSX. You can have the table over here and the TR over here. Now, you can't on the client, because these get realized to DOM nodes and you can insert them into each other. They don't actually have an issue because the parser, HTML parser, doesn't see it, and it actually just works. But on the server, if those two separate things, they don't come together until runtime. You can't analyze and know what's going to be injected into where. We talked about type systems in the chat on that. So what ends up happening is they get pushed together, table into TR as an HTML string, send over the wire, and then the browser goes, oh, I see what you did. Let me just sneak this in here. And when those component hydrates, again, they don't know about each other. How are they supposed to know that TR is there? Now, you could like walk and go, oh, wait, is this? And you could like add these extra checks at runtime during hydration and go like, is this element what I think it is? Oh, if not, maybe I should like add an element or remove, like, because basically the code, like in case of solid, when we have a table and like we walk the nodes, we actually write the code that walks in, like it's actually compiled in. That's part of the performance piece. We can't modify the code that's been pre-compiled, right? Like you end up accounting this for the lifetime of the whole application. It just doesn't make sense. Not been interested in web dev since I didn't mode outside of the web. Well, I mean, that's the thing. But the web is not immediate mode. So it's kind of like, me and Joe Savannah actually had a chat. Theo connected us after the whole benchmark thing. And I think the last thing I said to him was, because, we were talking about theoretical solutions, the approaches. And I'm like, okay, well, that sounds great. I just, concerned that the distance between the abstraction and the reality gets too far. Things don't end up working the way anyone expects. And the hardest part with the web is that anyone can just freaking pull out the div or the HTML element. You don't get to hide that it's a retained mode API. So it's kind of like, it's really quite interesting, because we don't, like, anyone trying to push immediate mode, which, to a certain degree what React's trying to do over the DOM, it's kind of just really fighting, like paddling uphill. So it's kind of interesting. Yeah, if you can go somewhere else and not have to worry about it, then I think things become very, very, very different. But then again, even in 3D graphics, when you consider stuff like Vulkan, like, as much as we like to pretend that everything's immediate mode and you can just display the screen, with all the frames, retaining stuff is good for performance. And that's where these optimizations end up going eventually anyways. So it really just comes down to how much control. Does your API give you the mechanisms to control it, or is this something behind your abstraction, right? Almost all immediate mode stuff ends up having to retain stuff in the end. It just tries to hide it behind abstraction instead of putting the controller in developers' hands. Solution for Google Translate is sprinkle key props all over JS to force React. That's just like the worst. Yeah, lovely. As an XH1, the funny thing is we laugh about this and say this is terrible, but think about TypeScript on JavaScript. JavaScript is another kind of forgiving language. It's not as forgiving. Even CSS, the whole web is based on this premise that we should forgive and like auto cure. But now everybody loves TypeScript. So maybe XHTML was just ahead of its time. Yeah, I mean, and this is a challenge with isomorphic models, right? Hydration in places you didn't see coming. It's true. Which means that we just have to double down on strictness. I mean, someone said this is like Rust versus Go kind of thing. And it is to a certain degree, but like to be fair, HTML and JavaScript and CSS are like off the deep end on that side. So, I mean, it's one of the reasons the web is where it is today is because we end up between that and trying to do stuff more structured, we end up with the full spectrum. It's hard to stay like there's so many elements that keep the web from like, especially the front end, becoming mature. People kind of blame JavaScript developers, but I think it's the shape of the problem. Anyway, I think that's it for today. Thank you for joining me for the stream. We cracked 6 hours, or we're about to, but let's cut it. Let's win while we're ahead. Hopefully, we will do another stream coming up not too long from now. As I said, I've been working on some really sweet stuff with Solid 2.0. That is pending stuff is just like, I think the full story is kind of coming together now. I actually one of the things that I got absolutely tickled about that I thought was really cool was after I did the is pending demo, the last one, someone from this kind of in the Svelte community actually opened a PR against Svelte asking for that utility because it seems pretty powerful and makes a lot of sense. I love when good designs like that can just translate across the systems. As I said, I'm a big fan of the async work that Svelte's been doing, and I think that while I'm a little bit more graph centric, I think most of the work that I've been doing would equally apply well to Svelte because we're not that different than each other anymore. So yeah, let's keep these ideas rolling and see like how much better that feature works. Because as I said, as much as I love and respect the work done on React, I do think there's a better way. So let's keep pushing. All right. Have a good one.